Hey everybody, good morning, good afternoon, good evening. My name is Kartik, one of the co-founders of ETH Global, and I'm super excited to welcome all of you to Scaling Ethereum. We're getting all of you kind of rolling in. I see already a few hundred people joining us on the live stream, so I'm super glad to be welcoming all of you again. See a lot of familiar faces, a lot of new faces, and can't wait to kick off this hackathon. So all of you are joining us on ethglobal.tv. That is our live setup that lets you experience this whole event with us in a really shared state. So just as a heads up for all of you who are looking at this thing for the first time, we'll be using this platform for the entirety of this hackathon and for today, which means that you'll be able to watch the stream on the left side here in the window. And for any of the questions you have for our panelists, for our talks, or us, you can ask them here on the chat, and we'll be able to relay these questions directly to the speakers onto the live stream. Also, as a note, I really encourage all of you to sign up or log into the chat because we will be giving out POAP NFT tokens for all the people who participated during this summit today. So if you haven't already logged in, try sign up and say hi to us in the chat. So with that said, this event, I want to talk to you a little bit about ETH Global. So Scaling Ethereum is brought to you by ETH Global, and ETH Global is an organization with a very simple mission. Our goal is to make it easy for thousands of developers to come on into the Web3 ecosystem and really shape the future that we're heading into. And we do that by hosting summits and hackathons. Scaling Ethereum is exactly that. This is a 3-week-long hackathon, and we also have a handful of summits as part of this month. And I'll be kind of walking through what's happening, starting with the summits. So we have 3 summits. Each of them will happen on Friday. Today is our first summit, which is a scaling summit, and you'll learn all the things about different scaling techniques to different scaling protocols and how they work and all the details of anywhere from their internals to where they are to just what makes them possible. And we'll be covering all of that as a high-level overview right after this kickoff for the hackathon. Then next Friday, we'll have our merge summit. We'll be talking about what is happening with the ETH2 merge, and you'll kind of get to hear all the things about what we're doing to scale the layer 1 side of Ethereum. And then 2 weeks from now, which is Friday the 30th, we'll be doing our Zero Knowledge Summit, and we'll be kind of talking to a lot of interesting speakers about what is happening in the world of zero knowledge, especially as it relates to scalability, programmability, and overall the things that are just not possible without some of these new primitives. So all that said, there's a lot on the summit side that we'll be sharing on our website. And with that, I want to get off and talk to you about the hackathon. So this is a massive event for us. There's over 425 hackers that are participating just for the next few weeks on the hackathon side. And just alone for the summits, we already have 400 people attending who are not the hackers, but directly watching just the talks. The hackers themselves, all the participants are coming in from over 56 different countries, spanning 18 different time zones. So we're going to have a lot of fun over the next 3 to 4 weeks. And can't wait to see the hundreds of different types of projects we get to see that tackle scaling. This is just a simple map of where all the developers and participants are coming in from. We have a really, really diverse set of audience, and it's just going to be super fun. In addition to all of that, we also have 100+ mentors who are here to help you with your projects, especially if you have any questions related to scaling technologies that are out there. And they are coming in from over 20 different companies who will be there to help you really get to the project and really ship something super cool and fun. And on top of all of that, we tallied up the numbers, and this is the first event where we've broken our own records. We're giving away over $200,000 in prizes for this event. And it's going to be super fun to see all the amazing things that you built with different protocols to different solutions out there and just challenging yourself to try new things. I want to especially thank some of our amazing sponsors here. So I want to thank Arbitrum, Optimism, zkSync, Starkware, Scale, Loopring, The Graph, Seller, Connext, Polygon, Raiden, zkSwap, Taurus, Compound Grants Program, Protocol Labs, the Uniswap Grants Program, Aave, Superfluid, Chainlink, NuCypher, Covalent, Zapper, 1inch, Teller, Secret Network, the Ethereum Foundation, IPFS Main, DPay, Near Protocol, Diversify, Rarible, Lemniscap, and ENS for being with us for this event. There are a lot of amazing scaling solutions. There's a lot of cool DeFi products that work on layer 2, and a lot of our supporters from the community that are helping us out with this event. And I'm super excited for all of us to join and just put our forces and heads together to really make something cool for the next month. So this event is called Scaling Ethereum, and a lot of what we talked about publicly has been really carefully shaped around what it means to do something related to scaling. And the most common question we got for this event was, what can I build if I don't know how to do things on layer 2? So I want to quickly highlight the intent from our side and sort of what this means for all of you who are listening in. The key thing to take away is that we don't want you to necessarily come in with all the context you need to have to do anything on layer 2. This event is designed specifically for us to see what it's going to take for the whole ecosystem to make the transition to layer 2 a lot easier. And as a result, we have support from a lot of existing DeFi protocols and a lot of existing layer 2 solutions to help make it possible for everybody to see what we need to do to get everything done as smooth as possible. And as a result, if you're not sure how something works, this is the type of event where you get to ask the layer 2 solutions that you might be interested in using to understand how you can actually deploy something that you already have on mainnet onto layer 2. And that means you can try to port existing things you've done in the past from in the DeFi world, or if you were a participant in the last NFT hackathon, and see if you can deploy the same things on a layer 2 system and really make it easy for everybody to use your application without any gas or additional costs. You also have now the ability to really work on brand new applications, whether they're in DeFi or just any other category, to deploy directly on layer 2 and really start and pave the way for a brand new ecosystem to emerge on the layer 2 side. There are a lot of developer tools that we need to make it easy to have others also try out and bring L2 to mainstream. And on top of all of that, you don't have to necessarily only have to do a programming related project. You can also use this time to make it easy for others to learn how to do something on L2. And that means you can work on documentation, you can work on guides, you can work on anything you can to make it easy for everybody else out there to really explore how they can move everything to a more scalable solution. So that gives you a little bit more context. And I have a few more things that I want to share on that, and we'll go through that in just a few minutes. So we have the summit today, and we have the hackathon kicking off. So I want to give a quick overview of how the hackathon is going to work for the next 3 weeks. For those of you who participated in NFT Hack, you probably saw our weekend version of a hackathon, and we're kind of going back to a month-long series where we give enough time to really understand and really make sure that you are getting the help you need to submit and work on your projects. So I'll be walking through what it means from the team formation side, how you can get help, or how you can think about new ideas, all the prizes you can win, how the talks and workshops are going to be set up, how judging and submission is going to work for this one, and then lastly, the summits and how you can expect to be a lot more engaged with our summit-related talks. So for all of the participants of the hackathon, the key thing to notice here is that everything is happening on Discord, which means that if you have staked on your dashboard and you've connected your Discord, you will see what's on the left side here on the screenshot, which means there's a scaling Ethereum category, and there are more than one channel that show up. And that means you've successfully gained access to all of the event-specific channels. And if you're not seeing any of these channels, please message anybody on the ETH Global team on Discord, but this is where everything is going to happen. This has channels for all of us to talk with each other. This has the channels for you to ask any of the protocols, questions specific to those protocols. So you can see on the bottom of that screenshot, if you have a question about a really specific company or a protocol, you can message them there and they'll be there to help you. You can have all the things from just generic help you can need on the developer side, whether that's Solidity or front end or back end. All these things are all going to happen through Discord. And that's where all of our mentors are also going to be. On top of all of that, we've also sent a calendar invite for all the key talks and workshops that are happening over the next few weeks. and the entire schedule for everything that's happening, whether it's the hackathon or the summit, is already on the website. We want this thing to be as asynchronous as possible. So if you are in a position where you can attend something because of a time zone or a conflict, we want this thing to be as easy as possible for you to catch up on. So all of that is available on scaling.ethglobal.co, and you can check everything there from all the details, and it'll be updated live every time we do something. So with that, let's go into how the hackathon is structured. Essentially, you can start working on a project now. In terms of the rules and the criteria for this event, everything that you're going to submit must begin during the course of the hackathon, and you can start coding as of today. You can have up to 5 members on your team if you would like to work on a team, and you have 3 weeks from now to submit. So that's 3 weeks and the Sunday that's coming from there. So in terms of quickly just going over the rules more granularly, everything that you are submitting to be eligible for a prize must be done during the course of this hackathon, which means that anything that you're submitting should be done from today to the next 3 week onwards. All the submissions should be related to scalability. And this is a very broad rule that we're bringing on for this event. And that means whatever you're doing should interact with something related to either a layer 2 system or a layer 1 scaling side. Which means that if you're only working on something that's entirely just DeFi and does nothing to address anywhere from throughput to gas costs or any sort of abstraction, it will unfortunately not be eligible for this event. We really want everybody to see what's possible on the layer 2 side, and there are a lot of options out there that have different trade-offs and different features that you can explore, and we would like you to give that a try. On top of all of that, only RSVP'd attendees are eligible to win any prizes, which means that if your teammates are not on your team from our dashboard officially and you do win a prize, we will not be able to give a prize to somebody who's not listed as a team member during the time of submission. So you really want to make sure that everybody who's on your team is confirmed as an attendee and is successfully added as a team member on your dashboard. And on top of all of that, we know that there are a lot of broad categories here that will always have their edge cases. So if you have any other questions or clarifications you would like, you can ask anybody on the global team to clarify, and we'll be happy to answer those questions for you. And I kind of really want to just dig into the fact that a lot of you have said, I don't know how certain things work on L2, or I'm super new to, I've only been doing Solidity for a few weeks to a few months, and I'm really new to all this thing. Am I still a good candidate to be a participant at this event? The answer is yes, because we want this to be exploratory by design. And on top of all of that, there are a lot of others who are also in a very similar position as you, and we really want to make sure that you have a chance to find somebody who's in a similar position and work together. So as a result, if you are still looking for a team, you can head over to find a team channel on our Discord, and you can talk to everybody who is also looking for team members, whether that's a complementary skill set or they don't know what they want to work on. You can use that channel to see everybody who's in a similar position and contact those attendees and potentially pair up. On top of all of that, we really encourage all of you to introduce yourself in the scaling channel, because there's over 500 of you from so many different parts of the world, and it'd be awesome to get to know all of you from our side. And on top of all of that, we are doing a few live calls as well for you to help find potential teammates. So there was one earlier today. If you missed that one, there's going to be another one on Monday. The schedule and all that information is on our Discord and also the website. So you can join that call if timing permits and really use that to talk to people who are also looking for teammates. And on top of all of that, it is not required that you have a team. Obviously, it makes things a lot easier if you have a few people doing certain things. But you are totally also welcome to work independently and hack solo. So all that said, let's talk about talks and workshops. There is a lot of content that we're working on for this event, because this is really the opportunity for everybody to see what's possible and what's happening on the layer 2 side, the ETH2 merge side, and zero knowledge side. And this content touches everyone from beginners to experts in this ecosystem. So there's going to be talks, panels, workshops. There's for the hackers here, we're going to be doing a feedback session every week which means that if you're working on something you would like real-time feedback or help or any guidance, you can join a call with us once a week and really showcase what you've been doing so far and really kind of use that as a way to get direct help in a live setting. On top of all of that, all this information is also available on your info center, which all of you should have a link for in every email and calendar invite. And because this is designed to be as asynchronous as possible, if you cannot attend a talk or a workshop because of a time zone or any other conflict, you can immediately watch that after it ends on our YouTube channel because everything is recorded. So there's no need to try to do everything as it happens or make any different trade-offs. We are recording everything. And one more time, everything is available on scaling.ethglobal.co. So lastly, there's a few more things. So check-ins. So everybody who has staked here knows that we are introducing the notion of check-ins for our 3-week-long event. And the gist of all of this is a check-in is something that happens once a week where we'll message you on Discord and also your dashboard and ask you to give an update on what you've done since the last time we chatted. This is designed as a way for us to help make sure that you are not blocked in anything or you're getting all the help you need. And this is the time where you get to ask us for things that you would like to get anywhere from help on or unstuck on, or you need to really think through something or just tell us what's happening. Because it is a 3-week-long event, we are not expecting you to spend too much time or all of your time on these on your projects. So these check-ins are designed as a way for us to get a pulse of what's happening with your project. Your stake is returned if you respond to these check-ins on your dashboard and if you submit a project, and all that information again is available on the info center and also on your dashboard, and all this will be managed directly through your dashboard. To give a quick overview, a lot of you are usually ask us what it means for these check-ins, and this is like a simple slide where I just want to give an idea of like what this means and how you should think about structuring it. We would like you to spend the first week, which is the next 7 days, exploring sort of what is possible if you don't already have an idea on understanding what you would like to work on or find potential other people to work with, or really think through what you're trying to do is possible and kind of the best things, the tools or the protocols you need to work with. You should spend the second week really having a basic version of your idea done so you can try it out, get feedback from us, get feedback from any mentors or sponsors. And on the third week, you should just polish it up to see if everything is good to go and add any additional things you want to add to make it really nice and ready for submissions. And that should be the week where you're kind of in a state to submit everything and record that video. And submissions are due again on the 9th, which is 3 weeks from now. So the way judging is going to work is that as you are readying the day of the submission deadline, you'll be required to make a 4-minute video for your project. And this video will be the official submission. So where everything will be video submissions only. So this really gives you all this time to make sure that you can really tell us about who you are, what you've been working on, and what your app is and your submission is, and record that and submit that on your dashboard. And we'll use this video to do the judging for the event, which happens the week of the few days after submissions. And all this again happens through all of your dashboards. So just a quick reminder that because you have to make a video, please make sure that you don't do this thing last minute, because it does take a little bit of time to make sure that the video is just anywhere from within the time limit to doesn't have any audio video issues, and is really the best encapsulation of yourself as a team and your project. And of course, this is an online event with hundreds of people, so we want to make sure that all of you are being mindful of our code of conduct. The rules and the criteria for how we want everybody to behave is outlined on ethglobal.co/rules. And even though we have a lot of details there, the gist of it is that please be respectful to everybody on the Discord and for this event. Harassment and abuse is not tolerated in any form. And if you need any help, or if you have any questions or concerns, whether it's about how your experience has been at the event or on our mentorship or literally any topic about the event, please don't hesitate to reach out to anybody on the global team, and we'll be happy to address and answer any of your questions. And finally, because there's a lot to wrap up, I want to remind everybody here that you should definitely pace yourself. We don't want this thing to be a marathon. The event is specifically designed to be 3 weeks because we don't want you to actively make any trade-offs or choices between your work or your school or any other full-time or longer commitments. And this, having all this time makes it easy for you to really pick the time and the hours you want to spend on your projects. And we don't want this thing to be exhausting for you in any form. We want you to specifically have fun doing this thing because all these events are designed as a platform and a way for all of us to share what's happening in this ecosystem and how you can learn what's going on, especially at the cutting edge. And this specific event is very much about experimentation because not only are you learning about what could be possible on layer 2, all of our protocols are here to get that feedback to understand how they can make that transition from layer 1 to layer 2 the best experience as possible. So really focus on the learning side of this, and we want to be there to help you get to where you want to be as part of your events. So all that said, that covers all of the logistics. I want to wish everybody a very happy hacking for the next 3 weeks. And I'm going to quickly shift gears to what is happening today with some of the prizes, our sponsors, and then move us off into our scaling summit. So today's schedule is as follows. We are going to have a lot of amazing talks about what is happening in the world of scalability. We're going to learn about what all the types of rollups are and how they work. Then we're specifically going to focus on how optimistic rollups work and how the OVM is designed. We're going to learn about how optimistic rollup works from the Arbitrum side. Then we're going to do a quick panel on different trade-offs and how these rollup architectures are different and how they work. We're going to learn a bit more about how specifically Ethereum native chains work with layer 1. We're going to learn about generally how the broad ecosystem of layer 2 has expanded from sidechains to generally just other native app specific blockchains. We're going to learn about the nuances of what it means to think about security of your assets for optimistic rollups. We're going to learn about how liquidity and specifically DeFi things will be possible in the world of L2. We're also going to have a lot more talks around just how do we actually make a lot more financial applications on the layer 2 side as we move everything over. Then we're going to switch gears and learn more about the world of zk rollups. So we're going to have a talk on zk Porter. We're going to learn a bit more about Starknets and what Starkware is doing. And then we also want to really show what's possible on the protocols that have already existed on layer 2 for a little while. And that's when we'll learn about how Synthetix is currently on Optimism and what they've learned and how they are thinking about their transition to layer 2. So this is just a quick preview of some of our talks, but I'll kind of go through all of those as they happen in about an hour and a half. And with that, I want to really kind of focus on some of the prizes for this hackathon and some of our amazing sponsors. So there's a lot of things happening on that front. And what we're going to do is we ask some of our sponsors to share and record some videos for us to talk us through who they are, why they're excited to be part of this event, what they're working on, and how you can use their protocols or their apps into your hacks. So we're going to be quickly walking through some of these companies and these protocols. And what we'll do is we'll have Arbitrum first kick us off with what they are going to be sharing. And we'll play a recorded video for them real quick.
Welcome to Scaling Ethereum. I'm Steven, co-founder and CEO of Off-Chain Labs, the team building Arbitrum. We're super excited to be sponsoring the hackathon and can't wait to see all the awesome projects that you'll build. And we hope that you'll hack on Arbitrum. Arbitrum is an optimistic rollup scaling solution for Ethereum that's currently live on Kovan with an open, public, and permissionless testnet and coming soon to a mainnet near you. We'll be actively participating throughout the hackathon, and some events that you don't want to miss are the brainstorming session at 8 p.m. Eastern Time on Thursday night, the Arbitrum keynote at 1:45 p.m. Eastern Time on Friday, followed immediately by the Optimistic Rollup panel, which we'll be participating in. And on Monday at 1 p.m. Eastern Time, you can roll up your sleeves at the Arbitrum workshop and work with our developers to start building on Arbitrum. If you have any questions throughout the process, technical questions, just want to bounce ideas off us, or definitely to show us what you built, please join us on Discord. We'll be active in the Scaling Ethereum Discord, as well as the Off-Chain Labs Discord, and we're there to support you every step of the way. And if you had so much fun in the hackathon building on Arbitrum and you couldn't get enough, well, we're hiring, so please join our team.
Hi everybody, I'm Ed Felton. I'm co-founder and chief scientist at Off-Chain Labs. Let me tell you why you should use Arbitrum. Arbitrum has low cost and is scalable. We get the gas cost of most transactions down to around 2,000 L1 gas. Arbitrum is fully EVM compatible. You can send EVM code directly to it. There's no special compiler, there's no special version. You don't have to use Solidity or Viper. You can use whatever toolchain you want. There's nothing to download. An Arbitrum node speaks exactly the same RPC API as an Ethereum node. So to deploy a contract or to submit a transaction, you can send the very same bits that you send to Ethereum. Arbitrum is trustless. It's built on top of Ethereum. Its security is rooted in Ethereum. And Arbitrum guarantees that any one honest party can force correct execution of the entire chain. Arbitrum lets you break out of the limits that Ethereum puts on you. You can go beyond Ethereum's transaction gas limit. Some other solutions have a lower gas limit than Ethereum. Ours is much, much higher. You can go beyond the contract size limit. Because of the way that Arbitrum works, we never need to deploy your contract on L1 or run an entire transaction on L1. And therefore we can break beyond those super annoying size limits. And finally, Arbitrum is a more mature technology. We've been running an open public testnet for about 6 months now. That's a full system and includes the fraud proofs, all the security features and everything. Not a demonstration, a real system. You can use our Coven 4 testnet today. We're a community project. We have never limited access to Arbitrum and we never will. Our testnets have been and our mainnet will be free and open for everyone to use. What you see on testnet now is a mainnet release candidate. We are close to mainnet release. We're not yet ready to announce a date, but you'll be hearing about a mainnet date very soon. How do we do that? We do that by using an optimistic rollup type of approach with a little bit of secret sauce. So we record the call data of transactions on the L1 chain. We move computation and storage off-chain, and the protocol merely confirms on the L1 chain what everyone already knows is the correct result. And it's optimistic. That means that in the normal case, people simply post on the L1 chain a correct claim about what your transaction will do, what the chain will do. We have a special and super efficient dispute resolution protocol that allows us to resolve any disputes that happen very quickly. So Arbitrum checks all the boxes. I don't think any other system can say it checks all 5 of the boxes. Low cost and scalability, fully EVM compatible, trustless, breaking beyond the contract size and gas limits, and mature and fully available in a system today. If you have any questions using Arbitrum, please reach out and let us know.
Hey there. My name's Harry Kolodner, and I'm co-founder and CTO of Off-Chain Labs. We've been sponsoring ETH Global Hackathons for almost 2 years now, and we're pumped to be back. We're especially excited because this hackathon focuses on scaling Ethereum, which is an area near and dear to our hearts as we've been developing Arbitrum. In order to make sure that everyone is excited as we are, we're offering our largest hackathon prizes yet, totaling $12,000. I'm going to tell you more about how you can win these prizes building on Arbitrum this hackathon. Our prizes are broken down into 4 categories: scalability, cross-chain interoperability, protocol development, and tooling. The winner of each category will receive a $3,000 prize. I'm going to give you a bit more detail about each category so you can start to develop ideas for what you'll build this hackathon. Our first prize is eligible to any team that deploys their smart contracts on Arbitrum. But we're most excited about teams that take advantage of the scalability that Arbitrum provides to stretch the limits of what's possible in smart contracts. This is a pretty open-ended prize, so we'd love for teams to have fun with it and can't wait to see what you come up with. Next up, I want to talk about cross-chain interoperability. Arbitrum provides the general capability for Ethereum contracts to make Arbitrum transactions and Arbitrum contracts to make Ethereum transactions. This sort of general ability to send transactions between the chains is a powerful building block for new cross-chain primitives. A few ideas in this category are cross-chain dexes, new types of fast withdrawals, and cross-chain synthetic assets. And we'll be happy to brainstorm with teams working towards these ideas or others. For this next prize, you'll be integrating directly at layer 1 with the Arbitrum smart contracts themselves. This is your chance to get into the nitty-gritty details of protocol development by integrating directly with the core Arbitrum rollup smart contracts or the Arbitrum token bridge smart contracts. Work towards this prize to make the Arbitrum rollup protocol even better for Ethereum. Last, but definitely not least, our final prize will go to the best Arbitrum-related tooling. Developer and user experience is critically important for the migration to layer 2, and we'd like to recruit scaling Ethereum hackers to help. This prize will go to a team who makes an awesome piece of tooling to make Arbitrum easier to understand, easier to use, or easier to develop for. Thanks for listening, and I hope people are excited to learn more and dig into Arbitrum over the course of this hackathon. Good luck and have fun.
Amazing. Thank you so much, Harry and Ed. Those are super well, thank you so much, Harry and Ed, for giving us an overview of Arbitrum and what you'll be doing for your prizes. For all of you looking who did not have a chance to catch up on the prizes that were just shared, I want to just quickly summarize that Arbitrum will be giving away $12,000 here, and they'll be giving prizes for the best use of Arbitrum scalability, the best use of cross-chain interoperability, the best use of Arbitrum protocol in general, and the best tooling related submissions for Arbitrum. So we've shared all this again in our prizes page. And with that, I want to go on to our next sponsor, and that is Optimism. So we'll be sharing a quick video about Optimism and how they're excited to be part of this event.
Hello hackers, welcome to the Optimism keynote. This maybe should have been a presentation on the technology and how it works, but it is not that. It's more like some kind of montage. In any case, I hope that you enjoy it, and I hope that you stay hydrated and that you stop by our Discord to say hi.
At the dawn of time, the first ever response to the Bitcoin white paper, http://www.bitcoin.org/bitcoin.pdf. We very much need such a system, but the way I understand your proposal, it does not seem to scale to the required size.
A long time ago.
What?
I'm trying to think. Okay. How do I do it?
Fun, more Carl.
Okay. Blockchain scalability. Oh, yeah. It was a real hard problem. We came together from all corners to solve it.
Hello. I'm Josh Stein. I'm the CEO of Harbor.
All right, so I'm Carl. I'm a researcher at the Ethereum Foundation.
Hey everyone, my name is Kevin Ho, and I'm going to be your lecturer for Chapter 3.
I'm Aurelian, founding member of Consensus Diligence and a smart contract auditor.
Sure, yeah, absolutely. So I'm Ben. I'm a part of Plasma Group, which is an open source community-driven Plasma implementation. All right, everyone. So next up, we have Liam Horn. He's going to be telling us about state channels. Clap, come on now. There we go.
All right. Hey, is that TV? Show the slides or no?
A couple posts by Vitalik and, 17 Plasma implementers calls later. My God, these have been crazy. And
Plasma XT, Plasma MVP, Plasma Unlimited, Plasma Cash, Plasma Debit, Plasma Cash Flow.
Yet another Plasma, thank goodness.
What is going on?
Plasma Prime. This is, I would say,
fun with names, to be honest with you. I mean, so the kind of history of Plasma is somewhat interesting. Iteration after iteration, first Plasma MVP came out, but we realized that there were mass exit vulnerabilities, and then Plasma Cash kind of addresses this, but it has its own weakness with fungible assets and transaction history growth, and then Plasma XT trying to address transaction history growth, and then Plasma Debit trying to address the fungibility problem, and then finally Plasma Cash Flow and Plasma Unlimited. These are the kind of the frontier, which you'll hear about soon.
We did some user testing with IDEO, actually, and we realized that people wanted functionality. They wanted smart contracts. They wanted a Web 2 experience, not scalability.
And we, scaled thousands of transactions per second with Plasma. Like an annoying parent, I would hear, "Can it run Uniswap?" And the sad truth is, no, it couldn't at the time run Uniswap. And so we went back to the drawing board. And we thought of generalized Plasma.
Stands for one coin on chain, because the coin on chain belongs to this next chain, belongs to this one. This is sharded Plasma. This is sharded Plasma. Also sharded Plasma. It's one. We only write one Plasma Cash exchange ever.
Exactly. One of the main research hurdles that we surpassed this year with Plasma was the creation of generalized Plasma.
You totally verify it. It's so fucking sad. You guys, it's insane. It's so good.
What generalized Plasma allows is for some limited subset of what you can do with an Ethereum smart contract. So you kind of have smart contracts on layer 2, which is pretty dope.
So all this has then is a function that just asks that if it can be exited. Exactly. And all this has the function exit function that asks the coin if it can be exited. Exactly. So that tells it where to ask we need another exit. Oh my god.
But can it run Uniswap? And once again, the sad answer was no, it cannot. We did not have the unstoppable smart contracts of Ethereum layer 1.
Generalized Plasma was a lesson on many fronts. It honestly sucks ass to scrap something that you've been working so hard on for so long, but ultimately it wasn't pragmatic, and we learned that Ethereum smart contract devs want to build with ease, which means preserving the existing experience, not onboarding devs onto a whole new development paradigm. So because of those fundamental limitations, we scrapped the whole project and started anew.
We're very clever, and so we came up with the name Optimistic Rollup. And so it turns out that in this trade-off space, you can get general computation, and you can get the no data withholding, problem, the kind of unstoppable nature.
And it turns out that the ability to have data on chain basically just gets around some very fundamental game theory issues that have to do with data availability.
And so that gives you what really resembles smart contracts inside of layer 2. But can it run Uniswap? Yes, my gosh, of course it can run Uniswap.
First question down. Let's go.
All right, so what are we building? So we are here building Optimistic Ethereum. Now, what is Optimistic Ethereum? In one exhale.
Optimistic Ethereum is fundamentally a proposal to enable scalability on Ethereum. It's an upgrade to Ethereum. It's not a different thing. That's the goal of the Optimistic Ethereum network. It's the goal of Optimism as a project, is to make Ethereum scale, not to become something different that tries to scale Ethereum.
Optimistic Ethereum is just like Ethereum, but with better scalability, 10 to 100x cheaper, and secured by L1.
Okay, guys, I want you to tell me what optimism is with as many buzzwords as possible, and it's okay if they don't make any sense. What is optimism?
Optimism is the layer 2 scalability stack for Ethereum.
That's what it says on our website.
Shit. Roll it up. Okay, Carl.
Okay.
What are you learning from this?
I'm learning the reality of George Hotz's advice of keeping things extremely simple and using the simplest tool to get the job done.
The optimistic Ethereum design philosophy is keep it simple. That was completely wrong.
Where did we fail?
We failed by having a feature that was not going to be used by our protocol or integrated by our protocol until it was complete. So we didn't have an iterative strategy for building this feature. Instead, it was a full top-down approach where we built out all the failure modes, all the edge cases from day one.
I think we've learned that premature optimization is a trap.
Yeah. So despite our best efforts to build an MVP every single time, we went with a waterfall approach and then we slapped the agile process over it and pretended like we were doing some fucking agile MVP shit.
The optimistic Ethereum design philosophy is keep it stupid simple and don't get wrecked. Plus also aligning yourself with Ethereum as a whole.
What does that mean?
If you write a bunch of code that you design an entirely new protocol, is it still Ethereum anymore? It's like a ship of Theseus type thing.
Right? We're not sitting here trying to go, oh, Ethereum doesn't work because it doesn't scale. We have to reinvent everything so that it scales. It's to say, well, we did the best that we could at the time. We now understand how to scale underlying blockchain systems better, and we have to apply those models to the existing amazingness that is Ethereum.
I'm not running our code as a standalone bit of software that now people need to understand the depths of. We're running it as diffs against the existing tech stack.
And our philosophy is like very, very minimal diff.
What really gets me going is like looking at that 200-line div compiler, you know what I mean? Like think of the complexity eliminated from like, you know, our early days of transpilation of like your 6,000-line JavaScript, you know, bytecode ingester versus now you just like write, you know, 200 lines of UL and it's done, you know? It's just phenomenal.
If you're wondering why it's taking us so damn long to write a 200-line compiler, that's because it takes so many more than 200 lines to get to the right 200 lines that maximizes functionality for minimum lines. And that's just for the compiler. Optimistic Ethereum is extremely complex because it has a lot of moving pieces. And so it takes many, many iterations to get that right.
Just because there's not a large diff, like doesn't mean that you don't have to put a lot of thought into like what that diff is.
You know, none of this is perfect yet. We have to find the right balance between pragmatism, auditability, shipping speed, and it's all trade-offs. Code is really sensitive. Even very small changes can have very big breaking impacts. So one benefit of minimizing the diff is compatibility with a whole ecosystem of Ethereum developer tooling.
Ridiculous for us to think that we could come in and like catch up with 5 years of like global open source development is just not practical. Like,
because there's a reason people have been doing that work for years and years. It takes a lot of effort to make things good.
There's something really awesome to be said for going from corporate to startups because as a nurse, I felt like I knew everything on the ground, but I was a drop in not even a bucket, but the ocean.
You used to work at a hedge fund. Why are you working here now?
This is where the action is.
Holy shit, come on, 1,000 Gwei. 1,000 Gwei.
Oh, it was accepted.
Oh my god.
What was wrong there?
If they don't fucking accept my 1,000 Gwei transaction, I'm gonna be pissed.
You just sent 1,000
$20 for the other one, and it's no compute.
We got in.
Oh.
That was a disaster.
I went to my first Ethereum hackathon in 2017, ETH Waterloo. I was really worried that it's gonna be these crypto anarchists. They're gonna be unwelcoming to a noob like me. What I found was a community that was super inclusive and willing to help. I remember someone stayed up with me until 2 a.m. walking through the Ethereum yellow paper. Yeah, and I just think working at Optimism, I can feel those same vibes of welcoming, inclusivity. Yeah. Aww.
Why is solving fundamental problems in blockchain fun?
Solving fundamental problems in blockchain involves solving fundamental problems in computer science.
And that's fun.
Yeah, they're hard problems in computer science, problems that haven't been solved before.
So why not do it at Google or something?
Because I don't really care about serving ads faster to people. I don't really wake up excited in the morning to track people on the internet.
What do you wake up excited in the morning to do?
To solve fundamental problems in blockchain.
Okay, prize.
Although I am a sucker for compilers, so that would be good too. Some new compiler could be fun.
Like a Viper compiler?
Yeah, exactly. Yeah, or Fay.
Ooh.
Adding increased time to get.
I didn't participate in the optimistic Ethereum. Gosh, guys. We want to give back to the community as a whole, so we have prizes dedicated to hacks that benefit Ethereum as a whole. This could be contributions to Hard Hat or Ethers or an EIP, really, you name it. We also have prizes dedicated to hardcore, helpful, and meme hacks. So it could be Geth mods, Viper compilers, ports of existing contracts, new layer 2 native contracts, cross-chain, t-shirt designs, riffs on our brand or our logo, beautiful NFT artwork that we can gift to our community members. All of these count. I'm super looking forward to what you guys are building. The distinction between categories is not that clear, so just give it a shot. Oh, and you should go to the website for the detailed prize information. But we are putting fat stacks in each category, so definitely go check it out. Okay, last note, Carl is going to be giving a presentation later today if you want to get a little bit more in-depth into how the technology behind optimistic rollup works. So look out for his presentation at 10:30 a.m. PT.
That was extremely fun and entertaining to watch. Thank you so much, the entire Optimism team. And that was super illustrative and just reminds us back when we can go back to the in-person events that It Global does. And I can't wait to see so many more stories and teams like this. So that was super awesome to watch. I hope all of you got to learn a bit more context about Optimism and optimistic rollups in general as well. And just to summarize what Jing said at the end, the prizes are available on the website for Meet Global as well as the Optimism specific domain. But the prizes for Optimism are the most hardcore hack. We'll be giving $4,000 for that. The most helpful hack, $4,000 again for this. The best use of memes will get $1,750 in total. And the best good for the community hack category will have $3,000 being given away. So hope you had a chance to enjoy that video as well. And we are ready to learn more about our next sponsor. And that is zkSync. So let's watch the intro video by them.
Hi, everyone. Really happy to be here and honored to greet you at the ETH Global Scaling Hackathon. And what a time to be in crypto in these crazy times. I just bought these 2 NFTs from a local OTC at a great discount to celebrate the Coinbase going public. But let's start. My name is Alex. I am CEO and co-founder of Meta Labs and one of the co-creators of zkSync, which is the first EVM-compatible zk rollup. And zk rollup is the most interesting scaling protocol, L2 scaling protocol, because it has the same security properties as a layer 1, which is it's the only protocol which has this ability. And we are very excited about the EVM compatibility, which is coming on testnet in May. and will be released in production in August. Please come join us at a ZK EVM talk at ETH Global ZK Summit in 2 weeks, I guess, where we're going to deep dive into the details how we did that. But zkSync is first and foremost a mission-driven project. It started because we wanted to make a contribution into acceleration of mass adoption of crypto. We believe in freedom, and we believe that freedom will be enhanced in all of the world through the mass adoption of crypto. And we're building our philosophy on the Ethereum's values of fairness, inclusion, and resilience. And we do everything around those values to support them technologically, using the power of zero knowledge proofs, which I think is the most most underrated and the most promising technology for crypto for the coming decades. We are happy to support this hackathon with a number of prizes. We're going to offer you mentorship. We will be there for you to answer questions about zkSync, about zero knowledge proofs, share ideas, provide any feedback. And I just want to offer you one of the recipes how to pick great ideas to work on, which are going to catch a lot of attention and will lead to something really big and successful. And that is, please think several moves ahead. Don't build something that solves an immediate problem. Don't build something that is obvious today. Build something that solves a problem which will become acute once the current problems are solved. And if we look back at history, we started zkSync a couple of years ago with DevCon 4, where I first met my co-founder and we discussed the idea. Back then, the fees on Ethereum were minuscule. The scaling was vaguely in the air, but it was not at all a burning problem. However, we realized that if crypto is going to become big and all the dApps which were being built back then, and those were like the actual things that people needed, like DeFi and NFTs and all the protocols we have and enjoy, most of them were not available back then, and they were kind of obvious things to work on. But we thought, okay, if those are going to be big and get a lot of traction and get a lot of usage, 20 TPS is by far not going to be enough. So we started working on scalability, also because zero knowledge proofs were becoming mature, and it was clear that we will be able to use it and solve scalability, breaking out of the scalability trilemma for them. So yeah, we launched in summer last year. We are now live on mainnet with a zk rollup for payments. In May this year, NFTs and trading is coming to mainnet. And also we released a testnet for zkSync 2.0 with support for Solidity and general EVM compatibility or EVM portability. But this year, yeah, of course, we expect a summer of scaling with a lot of scaling solutions launching, and a lot of users who were excluded from the participation in Ethereum because of high fees are coming back from side chains, from other layer ones. And a lot of new users who got excited about NFTs and all the crypto buzz are coming to Ethereum as well. But let's think one step ahead again. Like, what's going to be, like, once those solutions launch and all these users come back, what's going to happen? And retrospectively, if we look at what happened over the past year, we will see a very interesting phenomenon. The number of users in Ethereum, the active DeFi users, grew around 1,000 times, but the fees grew quadratically proportional to that. And the reason for this is induced demand, a term which describes what happens where you increase the capacity of some public good and a lot of more users coming, and you have a lot of more new use cases, and also trading just intensifies. The existing use cases already intensified. And this is likely what's going to happen with rollups, unfortunately. The expectation is that we'll get 100x more users with 100x scalability boost, but the reality might be closer that we just get a lot more trading again and some more use cases, plus or multiplied by the number of all those users, which will just eat up the the scalability boost, and the prices. Currently, rollup transaction prices are around $1, like more or less. If they grow 10x, 50x, 100x, we again are going to have a whole class of users who are excluded from the Ethereum ecosystem, and this is not cool. So we were thinking about this, and we built a solution called zk Porter, which falls under the class of Volition, and it combines the best properties of zk rollup and Validium. And we encourage you to come to our talk on Friday at 5 o'clock Eastern, where we're going to deep dive into that. And this brings, this is really interesting. I'm very, very excited about this. Please come to the talk. Really, you're not going to regret it. And yeah, but then there's going to be a next problem that a lot of rollups that launch will have centralized sequencers, and this will jeopardize the resilience of these protocols, because all of a sudden we are subject to a lot of pressure, maybe political pressure, maybe some economic or like just some faulty behavior, which we will solve for zkSync with an L2 consensus, which we're currently working on already. And then we think one more step ahead about the problem which will come after next, which is minor extractable value, which jeopardizes fairness, because the class of users will be in a lot better position than others using those values. So we will solve it again with cryptography and with zero-knowledge proofs with time-locked encryption. So yeah, looking forward to what you guys are going to build. We are there for you. And yeah, have a lot of fun at this hackathon. Thank you.
Amazing. So that was Alex talking to you about zkSync and zk Porter. And just to summarize what they're doing for prizes, they'll be giving away 4,000 USDC for the first place of zkSync use. There'll be 2,000 USDC dollars for second place. And then 4 teams will win 500 USDC for the third place for the best use of zkSync technologies. So with that, let's move on to our second zk rollup sponsor, and that is Starkware, and I'll let them share a bit about themselves.
Hello, everyone. So my name is Eli Ben-Sasson, and I am co-founder and president of Starkware, and I would like to tell you in this 8-minute talk a little bit about the road we're taking from zkStark to Starknet. And I would like to tell you that it goes through Cairo, which is a very cool programming language to which you're all invited to come and start programming in. And that's the purpose of our address to you in this hackathon. So Starknet is going to be an Ethereum-like Stark rollup. It's going to have very low amortized gas per transaction. It's going to have tremendously good TPS, transactions per second. So everyone wants to come over to it, right? Just a little bit more about what do we mean by Ethereum-like. It is going to be universal and support any smart contract logic that you wish, just like on Ethereum. It's going to be permissionless. You can deploy smart contracts without asking permission from anyone. Anyone can submit transactions in a decentralized manner. It's going to be fully decentralized. Both operators and provers are going to be decentralized. It's going to have some form of crypto economic incentives to the various participants in the network, the provers, the operators, developers, and so on. Now, to your question, whether there will be a token, so the answer is no comment. Good. So we'd like to get there, and we're already on our way. So already in 2020, Starkware has deployed the foundations for Starknet, and I'll talk about that in the next slide. And all of these foundations are already humming in practice, in production, and delivering scale for our customers. And we want to expand this to everyone. So during 2021, within a couple of months, we will give access to Planets, which is going to be run by a single operator and offer only a single app on it. By summer, we're going to have Constellations that's going to allow multiple apps to compose with one another, running on a single operator. And by 2022, we're going to reach the stage of Universe, which is going to be this Ethereum-like decentralized multiple operator system, permissionless for everyone. Great. So a little bit about the foundations, the stuff we achieved so far. And I want to mention all of these things are right now operating in production and supporting our customers. So first of all, we have Cairo, which is the programming language in which we express our logic. And this will be the programming language to be used also for getting scale and efficiency on Starknet. We have StarkX, which is an application layer, and it will be ported and streamlined and ported over to become smart contracts over Starknet. And currently we have 3 StarkX applications. So think of these as 3 preliminary anchor smart contracts that are going to be ported over to Starknet. And we have the framework of Stark provers, the most powerful provers in the world, with the leanest, fastest, meanest, and most secure cryptography behind them that also reaches the vastly greater scale than that obtained in production by any other proving system. So the 3 applications we have already running, the first one was Diversify, spot trading, deployed already in production over the past summer. It reaches currently a TPS of 9,000 for trading. So 9,000 trades can be done per second, and all of this on mainnet Ethereum. For payments, you can double that and have 18,000 transactions per second. A week ago, we deployed 2 systems, immutable with NFT trading. It is the only solution for scalable NFT trading right now that also sits on Ethereum. It gives you a price of not $40 per minting of an NFT, but rather 1/5 of a cent. And during the very first day it went live, the amount of trading that went on Immutable X was greater than all of the NFT related trading that took place on the week before that on Ethereum L1. And it didn't really, affect gas prices, all of this scale. The third system that was also deployed last week, 2 systems deployed in production within roughly 2 days. This is the first Stark rollup. It is DYDX and it supports perpetual and margin trading. And it reduced the gas cost per trade by a factor of 50x. Again, it's the first rollup for Stark that is right now running in production. So these 3 anchor systems are going to be part of Starknet, and they are all written in Cairo, which is the language that gives you the best access to using the power of Starks. So what are Starks, and how do we get from Starks to Starknet through Cairo? So zk Starks are a family of very powerful cryptographic proofs that offer computational integrity. And computational integrity in the context of blockchains roughly means doing the right computation even when you're on an L2 and no one else is watching. So zk means that you get the privacy of zero-knowledge proofs. The S in Stark stands for scalability, which means that the verification time per batch is only logarithmic or exponentially small in the amount of transactions going on in the batch, while the proving time stays nearly linear. It is a universal system, meaning you can get it for any computation in the world. It is transparent, that's the T in Stark, so no toxic waste, no trusted setup. It also gives you unlimited scale without reconfiguring the system. And it is based on lean and battle-hardened cryptography, basically on the security of hash functions like SHA-2 and SHA-3, and it is post-quantum secure. So how do you use it? Well, you take many transactions. So each one of these transactions is one of these little red squares. Each one could be, let's say, an NFT being minted. And instead of processing each one individually, you send them to a prover. The prover doesn't have to be trusted. The math of Stark implies that it cannot produce a proof. The proof is this red pi that is generated. The prover cannot get a proof if he's not asserting a statement that is correct. And then there's a verifier that runs an exponentially small time and checks whether the proof is correct. And again, the math of it allows you to move from the current system on the right, which is verification by naive replay. So you need to check each one of these NFT mints, and each one of them may cost, let's say, $40 in gas. You can move to a system where basically you get one proof that can assert for 600,000 mints mintings being correct, and a new state of the system captured by a Merkle root. And now you only need to verify the exponentially small proof, and then you move to the new state of the system. So this is how all of our systems work right now in the StarkX mode, and they are written in Cairo. A few words about Cairo. Cairo is our minimal viable language for getting production Stark systems. It follows the Goldilocks principle. So it's the just right balance between the expressibility needed by developers and getting the Stark prover efficiency. It is very simple in its structure and virtual machine. It has only 3 registers and a minimal instruction set. But on the other hand, it is extremely powerful. It supports functions, recursion, branching, random memory access. Being production grade means that it comes with a very elaborate set of tools that is needed by developers, like a compiler, virtual machine IDE extensions, tracer, application code, examples, and so on and so forth. So summing up, our applications currently have been written in Cairo. They support diverse business logic, and sometimes this logic is quite complicated. And this is the best way for you to jump on the wagon or this train that is heading towards Starknet, and its next stop is going to be in summer 2021. So the next step is to join us on Discord. That's the left QR code, and go and start tapping into all of the resources of Cairo using the right QR code. So thank you very much.
Amazing. Thanks, Ellie. So you kind of got a quick overview of how Starkware and their road to Starknet is going to make their debut here for this event. And what Starkware is going to be doing is they're going to be giving away a few prizes. So the first place for the Starkware prize will get $5,000 for the best use of integrations with the Starknet protocol. The second place, there will be 2 winners for the second place for 2 $3,000 prizes, and then there's going to be 3 $1,000 third place winners. So we'll be sharing a lot more details on these specific prizes. They're already available on our prize page, and you also kind of got a gist of Cairo and how the Starkware scaling solution works, and there'll be another talk for our summit later in the day going more into details of how Starkware works with Ethereum. So with that, we are ready to move on to our next 2 sponsors. So we have Scale and Connext, and we'll be sharing a quick video for both of them.
Hello, everybody. My name is Jack O'Halloran. I am co-founder of Scale, the Scale Network, and the CEO of Scale Labs. Really excited to be here today. We've been doing hackathons, or ETH Global Hackathons, since August of 2018. ETH Berlin was our first hackathon, and we've done every one since. So really, really pumped to be here, to be supporting you. And this hackathon in particular is very unique in that it goes for such a long period of time. So I think what that means is an opportunity to build even cooler things, get even more creative, put more effort and time into it. The other thing that I want to call out before we get into this, we've had the pleasure of having over 60 submissions on Scale, and we've given out over $60,000 worth of awards at ETH Hackathon. So I've seen a lot of these over the time, the last 3 years. And one thing I've noticed is that when you look at the teams building on hackathons and the sponsors that are there supporting them, you fast forward 18 to 24 months later, this is the future of crypto and decentralization. These things being hacked on become the things that are being used. So a lot of the things we see out in the wild today were actually ideas and thoughts and submissions at hackathons before. So it's a phenomenal way to build recognition as a developer, get awards, get awareness for your project or your team, but also to innovate and push the industry forward. So the people here doing this are the ones that will set forth the future agenda for Ethereum and Web3 and DeFi. Okay, without further ado, I'm gonna get into some slides and show you more about awards and how to hack on Scale. All right, here we go. So we'll get into the awards, talk a little bit about Scale, talk about how to deploy on Scale. I want to cover the hackathon support resources quickly, and then we'll close on a bit of a summary. So, all right, I'm really excited to say this is by far the biggest set of awards we've been able to give through Scale, and that's because the Scale token's now live, the network's live. There's $2 billion staked into the Ethereum mainnet, which gives pool security to the Scale network, and This is again coming from a community pool and going to developers. So there'll be 5 awards given. One will be the Denali Award, which is the name of the most recent upgrade. This week, the Scale network is upgrading, and you're going to see Scale chains going live. You're going to see a lot of, there's over 100 teams in the Scale Innovator Program that'll be pushing out different applications in DeFi, Web3, gaming, NFT, B2B disruptors, social, music streaming, etc. All right. And then we'll have 3 Kilimanjaro Awards, which is the name of the first mainnet upgrade, first decentralized mainnet release last October. There'll also be 1 Partner Hack Award where you build something on another partner at the hackathon or an ecosystem partner, integrate that with Scale. We want to show off and award people that are using the Ethereum ecosystem. All right, so before I go further, I want to talk a little bit more about what it means to be an Ethereum native multi-chain network. And so we need to then define what is a multi-chain network and what does it mean to be Ethereum native. So let's first talk about pooled security. And pooled security is a key component of a multi-chain network. You have a large set of nodes, there's security, there's stake across all of those nodes. And at any given time, a random subset is pulled into a blockchain. That blockchain, and in this case of Scale, those are called Scale chains. And those nodes are not just randomly assigned, but they're rotated in a random fashion. All right. The cool thing about Scale is the Ethereum network is actually orchestrating all of that assignment and rotation and stake and slashing, et cetera. And there's already $2 billion plus in pooled security in the Scale network at your disposal now that we are at the Denali upgrade, ready for you to help support you push Scale into the wild. All right. And so that's a multi-blockchain network where you have not just one blockchain that's shared, each application has its own blockchain. And so when you deploy to Scale, you get your own Scale chain. When you get a Scale chain at this hackathon, you get your own endpoint that you point to, your own RPC port, and that's where that's your Scale chain. You don't share it with other hackers, okay? And these are blockchains on demand, so to speak, or Ethereum on demand. Now, this is not a new novel thing. We've been building this since 2017, building a multi-blockchain network or a multi-chain network, but there are a lot of them out there. I mean, you see these, there's some big brands that are building multi-chain networks. And I think they also see that the world's best tooling and developer traction is on Ethereum. So what they're doing is they're saying, hey, we have EVM compatibility. We're going to build a bridge to Ethereum. And that's pretty much the extent of their integration. Scale, I want to call it, is very different. And that's why I'm passionate about this term Ethereum native, because it means something. It's not just marketing. The Scale network through the Scale manager actually is guided through the Scale manager. So in the Scale network, any orchestration, as I mentioned, which nodes go to which chains, any rotation of those nodes happens through the Scale manager and in conjunction with Scale nodes. But smart contracts in the mainnet make that happen. In addition, there's network management that happens on Ethereum. So there's an ERC-77 token. It's called the SKL token. That's on Ethereum. It lets you delegate from Ethereum to the Scale network. And then when you do that, when you stake, that stake actually lives in the Scale network, and it's pooled security that supports decentralized applications, all right? That lives on Ethereum. Same thing with any bounty awards, Scale chain fees paid by developers for Scale chains. Any sort of inflation, the inflation in the network that helps bootstrap the network and augments the fees in the first years. Any sort of slashing. So if a node operator is malicious and they get slashed, that happens on Ethereum through Scale Manager. Check it out on GitHub, Scale Manager and the Scale GitHub. It's a very complex set of smart contracts. And the other cool thing is when you use Scale, you pay Ethereum. It's this modernized rev share model that is decentralized, which is a very cool way of partnering, and as opposed to competing and just kind of connecting over through a bridge. You want to pay for a Scale chain, you have to pay in Scale, and you have to pay gas fees. Send a Scale token, you pay Ethereum and gas fees, etc. Okay. Scale also is, I think, doing really cool stuff with containerization, and these elastic blockchains or elastic shards are actually can be selected in different sizes based off your needs. So won't go too deep on this today, but it's one of the cool components here where every node has, virtualized subnodes, and a core that speaks back to the scale manager on Ethereum. All right, so again, deploy to scale, you can have sub-second block times, much larger block sizes, very great, easy user experience as if you were just deploying to another chain without a lot of complexity, but it's an Ethereum native chain, right? And so the way you, at this hackathon, in order to do this, one, you have to request the chain, which I'll show you how to do in a second. It's very easy to deploy, 2 lines of code. Then if you want to bridge, it's not a requirement, but if you want to bridge and show tokens moving back and forth between Ethereum and Scale, you can use the Scale IMA, which is there at your disposal, or another bridge. Maybe you want to use Connext or something else, or maybe even you want to create a bridge. I think that would also be a cool award winner. And we'd love to see somebody do something creative. Or connect another bridge that exists to Scale and show something happening. That also, I think, would be very creative. And then lastly, once you have your chain, do something cool in the ethos and spirit of Ethereum, show off these larger block sizes and smart contracts. Again, closing on awards. So there are $5,000 will be given in Scale to the Denali winner. And hey, again, do something cool, do it in the spirit of Ethereum. The next piece, 3 $2,500 winners, the Kilimanjaro Award. Again, build something cool, have fun, get creative. And lastly, Partner Hack Award. And there's some integrations that already exist between Chainlink, The Graph, Connext, and others, Covalent, NewCipher. So build something cool, integrate a partner. Ethereum is about the ecosystem. That is the strength of Ethereum. It's not just Solidity, it's not just EVM, it's not just the security within the Ethereum mainnet, it's the developer ecosystem, and Scale wants to support that by also giving an award for someone that can show this integration between Scale and another piece of the ecosystem. All right, so how do you learn more? The first step would be in a few hours today at 11:30 a.m. PT, Chadwick Strange, VP of Product for Scale Labs, will be giving a talk. So join that for a much deeper dive. You can go to scale.chat to the Scale Discord and learn all you need to know how to hack on Scale, get connected to the team. You can also go to the Discord run by for this hackathon, and we'll be there to support you as well. There's also a dev portal here link, and a link to get a Scale chain. Lastly, there's a Scale store. It's a zero profit store. It's a community store. Anyone who hacks, there'll be a discount codes given when you get your Scale chain. So please check that out. All right. Again, just want to close to say, this is a phenomenal platform for you to build something. And the secure. All right.
It looks like we're having some minor technical difficulties, but luckily we were at the tail end of what the Scale prizes were. So I want to just quickly repeat what Jack was saying about Scale prizes, and they are as follows. So for the Denali Grand Prize, you'll be getting $5,000 in Scale tokens. For the Kilimanjaro Prize, you'll be getting $2,500 in Scale tokens. And for the Best Partner Integration, there will be $2,500 in Scale tokens. That is over $12,000 in prizes being given by Scale, and this is the largest they have done for an ETH Global event. And this is just absolutely incredible. So I hope you had a chance to learn a bit more about how Scale is structured from this quick talk. There's also going to be another talk during our summit in a couple of hours by Chadwick, going in more depth around how Scale works under the hood. And yeah, hopefully that was informative. And with that, we are ready to move on to our next talk for our next sponsor video, and that is Connext. And we'll be sharing what Connext has to say momentarily.
Hi, everyone. My name is Arjun. I'm one of the founders of Connext. Welcome to Scaling Ethereum. Connext is a protocol for communicating between different layer 2 ecosystems. So that's rollups, sidechains, any other kind of EVM compatible chain, and then eventually also like non-Turing complete, non-EVM compatible Turing complete systems like zk rollups. Connext works by, Connext is basically a network of liquidity providers called routers. Those routers hold liquidity pools on different chains, similar to like Uniswap LPs, and they allow you to swap value between them. And you can even do more interesting things like pass call data between, as part of these swap interactions that allows you to call a contract on a given chain from another chain. So it kind of looks like a cross-chain meta transaction pattern. Connext is live today. We've been live for the last few months. We've been working with pretty closely with the Polygon ecosystem, XDAI, and a bunch of other early kind of L2 pioneers. And then now we're hoping to go live with Arbitrum Optimism soon, and then zkSync as well when it rolls out. Connext works, so a few examples of where Connext works right now. So Decentral Games is a metaverse casino that exists on Polygon. Decentral Games uses Connext to onboard in and out of Polygon from Ethereum. One of the great things about Connext is that you can, because you have this like swap of assets on one chain for another chain, you can bypass like entry and exit windows completely. So Polygon has a 6-minute onboarding and a 3-hour offboarding time normally from Ethereum, and then with Connext that ends up being pretty much instant. Users can kind of just do this in a single session. So particularly for people who are not necessarily as familiar with Ethereum and particularly like the nuances of Ethereum bridges, Connext ends up making that experience a lot more seamless. Another way that people are using Connext is direct layer 2 to layer 2 interactions, and we think this is an incredibly powerful space that is going to be really, really valuable in the future because, well, to be honest, the ETH is just so incredibly expensive right now that like it prices out a lot of different types of activity. So we've had folks say that they have like funds stuck on XDAI or BSC or eventually things like Arbitrum and Optimism, and the funds are not really worth bridging out of the chain. But if you can move them directly between layer 2s, then they become interesting to play with. And right now that threshold is kind of like $40 to $50, which is actually a pretty significant amount of money when you're not, just being like an absolute DeFi degen. We found that this layer 2 to layer 2, these swaps are actually really, really great for people who want to ape into protocols from things like Binance, because there's a very clear and easy path to go from like Binance chain to move liquidity off of Binance chain and into like the actual Ethereum layer 2 ecosystem. And the last kind of user flow, the last kind of way to use Connext that we're most excited about is basically this cross-chain meta transaction pattern. So Connext has the ability to build what are called withdrawal helpers. Basically, we have like middleware contracts that you can deploy between the Connext contracts and then whatever else you want to do outside of Connext. And then you can pass call data into Connext when you make a cross-chain transaction. And by creating withdrawal helpers like this, you're actually able to like call any contract directly from Connext and do that across chains without having to pay gas on the receiving side. So what this looks like is it's kind of similar to a meta transaction relayer pattern where like you only need funds, you're able to pay for a transaction that normally would cost ETH gas, but only using, USDC or DAI. And in this case, you're able to pay for a transaction on a receiver side chain only using funds on the sender side chain. So for instance, like paying for an Arbitrum transaction using ETH from Arbitrum rather than ETH from, and like an Arbitrum transaction on Optimism, paying only ETH from Arbitrum rather than ETH from Optimism. A great example of a project that's building with this technology right now is Superfluid. So Superfluid is a cross-chain money streaming protocol, or a money streaming protocol more generally, and then they're building cross-chain money streams using Connext by enabling users to be able to like set up these money streams on different chains. We think there's some really, really interesting new kinds of places to explore here. So for instance, you can build like fully atomic cross-chain DEX aggregators, which we think are incredibly powerful and are probably what DEX aggregators will look like in the future, where you're not just aggregating from all of the AMMs on a single chain, but you're also aggregating across a bunch of different chains. You can use the same kind of pattern to build things like cross-chain money, cross-chain lending, cross-chain yield aggregation, potentially even like cross-chain DAO interactions and things like that. There's a couple of ways to integrate Connext today. We have a SDK. So we have a widget that looks like this that you can pretty much just drop directly into your UI. That is extremely fast to integrate, and we have like great instructions for that in our docs. We also have a lower level SDK that powers this. So in case you don't want to use our UI or you want to do more complex behaviors like the cross-chain money, cross-chain contract calls that we just talked about. You'd be able to pass those more detailed like call data calls directly into the SDK. Both of these resources for integrating both of these mechanisms are available in our docs. And for the duration of this text, we're actually hosting routers on testnet specifically for this. So if you have a project that you're building on top of us and you don't want to have to go through the headache of like hosting a router and supplying liquidity and things like that, we have some publicly available routers that you can use. We also have some additional resources. So we've put together like a list of things that could be helpful to hackers in a hacker kit. You can find that at connext.network/scalingeth. And then of course you can also find us and ping us anytime in the Sponsor Connext Discord chat on the ETH Global chat. We also have our own Discord if you want to join it. We are super responsive there as well, and you can find the link to that on our landing page, connext.network. And then lastly, we're giving out a bunch of prizes as part of this. So we're giving out 1,500 each to the best applications that implement the widget SDK, best applications that use this like cross-chain meta transactions pattern. We're looking for a team to build teams that build metrics and powerful data analytics against our network. So we're exposed in the process of exposing that currently. And if you're interested in that, definitely come talk to us. And then we're doing a couple of joint bounties with the Graph and Optimism, where if you build using both of us, you would be eligible for those prizes. Yeah, that's basically it from our end. Thank you guys so much for coming to Scaling Ethereum, and really, really excited to potentially work with you, and good luck in the hackathon.
Thanks so much, Arjun, for that intro. And just to sum up the prizes for Connext, there is going to be $3,000 being given for the metrics related hack. There's $1,500 available for the cross-chain DApp submission. And the best use of a cross-chain transaction on Connext will also get $1,500. And there'll be two $750 prizes for the best widget or SDK integration. So that's a summary of the Connext prizes. And then we have a few more sponsors who would like to tell us about their excitement to join this event, and we'll be doing Protocol Labs and Seller together here.
Hello, welcome to Scaling Ethereum. I am Dietrich Ayala, and I'm the IPFS ecosystem lead at Protocol Labs. Protocol Labs is an open source research, development, and deployment laboratory. Our projects include IPFS, Filecoin, libp2p, and a whole bunch more. We aim to make human existence orders of magnitude better through the technologies we're developing. We're a fully distributed company. Our team of more than 100 members works remotely and in the open to improve the internet, humanity's most important technology, as we explore advances in computing and related fields. Protocol Labs has 4 prize options for scaling all the things, which it may choose to split up amongst multiple winners if too many of you build amazing projects. Our first prize, the NFT Metadata Updater, $1,875 US in Filecoin. Mo minting, mo problems. Right now, everybody's minting NFTs and figuring out how to manage them. There aren't a lot of tools or services for managing large numbers of NFTs or even personal collections, being able to update metadata dynamically and in bulk across multiple assets. So this is a prize for the best method for managing signed, permissioned, timestamped updates to NFT metadata stored on IPFS via any L2 chain, the chain of your choice. Our second prize, Filecoin Turbo Retrieval, $1,875 in Filecoin, for the best method of bundling, managing, warming up, pre-flighting, or otherwise speeding up the payment channel creation process for easy mass retrieval from the Filecoin network. Our third prize, Sailing the Seas of CIDs, $1,875 in Filecoin. Right now you're publishing everything to IPFS, but where's your stuff? What is it all? So this prize is for the best tool, the best service, website, library, for working with and managing, visualizing large collections of IPFS CIDs. Our fourth prize, the Filecoin Super Disputer, $1,875 in Filecoin. Disputing optimistic window proof of spacetime proofs is a fun and profitable hobby that will also impress your friends. But how to show that off? This is the best prize for a disputer history visualizer, a leaderboard, or some other way of understanding what the set of potential disputes that you could take on are, who's disputing them, and any other way to be able to manage and help the dispute process and allow people to participate in this opportunity. Thank you very much for listening. Thank you for joining the ETH Global Scaling Ethereum Hackathon. Protocol Labs is very proud to be part of another amazing event. We are looking forward to the things that you build with IPFS, Liquidity, and Filecoin. If you have any questions, join us in the Protocol Labs sponsor channel. We're here to help you and answer your questions and make the things that you build even more awesome. Looking forward to evaluating and judging your projects, and we'll see you on the internets.
Hi, this is Mo from Sarah. It's great to meet you all at the Scaling Ethereum Hackathon. Today, we're bringing a new project called Layer 2 Finance for you to use and actually build on top of. This project is really about bringing access to DeFi for everyone. And just to give a quick intro, if we look at the entire DeFi landscape, it's almost like a city where your wallet is basically your home, and you have different kind of a DeFi shop you can go and park your money at and earn yield. The problem about this particular DeFi city is that right now, the only way of transportation is this kind of a super expensive limo service, which is an L1 transaction. And ideally, for any kind of a modern city, we would expect to have some pretty good public transportation system where people can aggregate together and go to certain destination and split the cost. This is essentially the idea of Layer 2 Finance, which is providing a trust-free DeFi public transportation system through Layer 2 rollup scaling architecture. We have already launched on testnet, and currently there are quite a lot of activity on this testnet, but most notably, we're seeing about 80 times lower cost compared to directly using Layer 1 DeFi protocols. The good thing about Layer 2 Finance here is that it really is a composable product where it doesn't require Layer 1 DeFi strategies or Layer 1 DeFi protocols to migrate to a different chain. Instead, it only requires a simple connector to bridge the Layer 2 liquidity back to Layer 1, and this is what we call a strategy adapter. Now, this hackathon is really about bringing innovation on that strategy adapter layer, and we're providing a $7,500 prices to build with a Layer 2 Finance Strategy SDK to connect and combine different strategy protocols and DeFi protocols into novel strategies. The first price being $3,000, and we have 3 runner-ups of $1,500 each. We're hoping to see some really novel combination of DeFi protocols in these strategies with a fully functional strategy contract build. And to find out how to build the easiest solution is probably just join the Discord and follow us on Twitter. And we also have a GitHub, of course, but we will always send notification in the Discord channel and also publish our workshop, talk about how to connect the existing DeFi protocols into this Layer 2 Finance product. And we'll have a summit later today to talk a little bit more in detail on how this is realized in a Layer 2 rollup construct. Well, looking forward to your submission, and good luck with the hackathon.
Thank you so much, Protocol Labs and Seller. So just to quickly summarize their prize, Protocol Labs will be giving NFT 1875 in Filecoin tokens for the NFT metadata updater hack, another 1875 in Filecoin tokens for a turbo retrieval hack for Filecoin, which relates to scaling. They also want to help give prizes for anybody who's helping scale CID retrievals. and also a 1875 in Filecoin price for a super disruptor category winner, and the details of all of which are on our prizes page. And to summarize seller, they'll be giving first place $3,000 for the best seller integrations, and there'll be three $1,500 runner-ups for the best use of seller protocol. So with that, we have zkSwap and Loopring up next, and we'll share their videos with you momentarily.
Hello, ETH Global Hacker. This is zkSwap. This is a quick video overview of what zkSwap is. So zkSwap is a layer 2 AMM DEX based on zk rollup. We launched in February 14th, 2021. It's been 3 months since our launch. We already have 1.5 billion in TVL and 1 billion in liquidity and 150 million in trading value. zkSwap has payment and layer 2 trading and liquidity mining. And it's based on zk rollup. It uses validity proof instead of swap proof. It has on-chain data, and there's no exit period. It has low gas fee and low latency. We have about 100 times the capacity of Ethereum, and the gas cost, the transaction cost, is 1/50th compared to layer 1 solutions. And the confirmation is instantaneous. The technical challenges and innovations were encountered while implementing zkSwap. So the circuit complexity is definitely one thing. As the complexity of the business logic increases, the block size and the proof time also increases. So we had to spend a lot of time optimizing our circuits and our proof infrastructure. We implemented a GPU algorithm to generate the proofs, and we achieved a 3-time improvement using our GPU implementation. And the other technique we used is aggregation proof. Instead of generating one zk knowledge proof per block, there's a way to generate a single proof for multiple blocks. So it decreases the proving cost on-chain as well, because we can verify multiple blocks with a one single aggregation proof. And we also looked into a lot of data compression of our on-chain data. On-chain data storage is definitely the biggest component of zk rollup cost. A little bit about our 2021 roadmap. In Q2 of 2021, we're going to launch version 2, and we'll support token listing for anyone, for users. And we're going to keep working on our zk proof efficiencies so we can improve our TPS as well. And we plan to launch a governance token for zkS. And in Q3, we're going to add stablecoin swap. So we're going to implement different curves for stablecoins and, for example, trading between different types of BTCs. In Q4, we'll be looking into supporting smart contracts on layer 2. For the hackathon, there are prices we are offering for arbitrage tools. So you could implement arbitrage purely on layer 2, or you could also implement some sort of cross-platform arbitrage strategies between zkSwap and, say, a centralized exchange. The other thing is you could possibly implement some sort of DeFi protocol based on zkSwap LP tokens. So the zkSwap LP tokens are available on layer 1. The liquidity providers, they deposit their assets on layer 2, but their corresponding LP token on layer 1. And this is something that you could use to build some sort of DeFi. Here's our links, like our official media, Twitter, Telegram, Discord. You can follow us on Twitter, zkSwap official. That's it. Thanks.
Hello, my name is Daniel Wang. I'm the founder and CEO of Loopring. Welcome to this hackathon. I wish everybody can enjoy this event, learn something new, make friends, and deliver something cool. As one of the sponsors of this event, I would like to introduce Loopring and our 2 challenges for you. Loopring is a zk rollup based layer 2 scalability solution, but we are not a general purpose layer 2. We are a DEX specific layer 2 for transfers, AMM swap, and outbook trades. We also offer a smart wallet powered by social recovery. So with the wallet, you don't have to manage your private keys. You don't have to do backups. We have 2 challenges for you. One is front-end challenge. We want to build a blockchain explorer for Loopring zk rollup. The other one is related to our cross-blockchain bridge or cross-layer 2 bridge. I want to share a few slides with you regarding the bridge. There are three small components of the bridge. The first one is what we call a flash deposit. So basically on layer 1, you can mint some token out of thin air and then deposit to Loopring layer 2. And then at the end of layer 2 block, you have to withdraw the same amount of token and return them to layer 1 to burn. The second one is a bridge. The bridge allows multiple users on layer 2 to transfer tokens to one single account on layer 2, and then withdraw the token to layer 1, interact with DeFi, and then optionally return another token back to layer 2 and redistribute those tokens to users. The third one is the converter, which is a special implementation of the bridge so that we can optimize the layer 1 footprint a little bit. So these are very powerful tools that you can use to bring interoperability to Loopring. So I wish, again, I wish everybody to have fun at this great event. Brecht and myself will be here to help. Thank you.
Awesome. So that was zkSwap and Loopring. And just to quickly summarize their prizes, zkSwap is giving a $2,000 prize for the arbitrage tool, the best use of arbitrage tool, a $1,500 prize for an aggregator related hack, and $2,500 for the lending category related hack. And Loopring is giving about $5,000 in prizes, and the first place gets $2,500, the second place gets $1,500, and the third place gets about $1,000 for the best use of Loopring protocols in their hack. With that, we are moving on to Raiden and The Graph. So I'm excited for them to quickly share about their prizes and themselves.
Hello everyone, this is Jacob from the Raiden team. Today I'll give you a brief introduction of Raiden and the prizes that we have for the Scaling Ethereum Hackathon. The Raiden network is a payment channel network. It consists of off-chain channels that allow for fast transfers because we don't have to wait for the blockchain. It scales linearly with the amount of users using the system. It is very suitable for high-frequency token transfers, and in this hackathon specifically, we'll focus mostly on the light client. So Raiden is a good fit for you when you want to do many frequent transfers, you want instant finality on those transfers, and you want to work with a simple API that lets you focus on building things. So the prizes and the challenges that we offer for this hackathon are $2,000 in RDN for the best hack that uses the Raiden Light Client SDK to power payments. So this is a very broad category, and if you're not entirely sure what you want to build, we also have a list of ideas and inspiration that you can get from us in Discord. So this is probably for you if you have some idea that includes Secondly, we have $2,000 in RDN for the best hack that ports Raiden to a rollup solution or a sidechain. So this could be putting Raiden on Optimism or putting Raiden on XDAI. Optimism is probably harder than putting it on XDAI. So for this, if you do XDAI, we would also like to see some good tooling around interfaces and bridges for XDAI to Ethereum and the other way. Then there's $2,000 worth of RDN for the best hack that builds a new frontend for the light client or rebuilds the current one. So we would like to see a frontend that focuses very much on making it easy and simple to do payments in Raiden. For all the categories, we will also reward $500 in RDN for the runner-up submissions. If you're looking for some resources, inspiration, and support, you can find us in Discord and ask whatever you want. We can brainstorm some ideas together. We also have a list of concrete ideas, and you can check out the workshop that Andre did when you want to get started building on the SDK. A quick intro to the team. We have Andre, Paul, Tora, Talal, and myself, and we will be following in Discord for this hackathon, and we'll be very happy to help you out if you have any questions. We're here to help. And lastly, I'll just mention that we also have a grants program that could be relevant for continued collaboration after the hackathon. That's all for me. Thank you very much, and good luck and have fun hacking.
Hi there, my name is Eva Balin and I'm director at the Graph Foundation. For those of you who don't know, the Graph is the global querying and indexing layer for Web3 and querying any blockchain data at all. We're so excited to be sponsoring Scaling Ethereum and helping you hackers build better and more sustainable applications. To learn more about the Graph, I suggest you go to thegraph.com/docs, where you can learn how to deploy a subgraph, what a subgraph even does, and even learn more about our network and how to become an indexer. Now, we have a few bounties for this hackathon, so listen up. The first bounty will be one prize of 1,500 DAI for the best use of one of the following existing subgraphs by one of the other sponsors of this hackathon. So that includes the Rarible subgraph, the ENS subgraph, the Matic or Polygon subgraph, Uniswap subgraph, or the Aave subgraph. And again, you can learn more about how to use these subgraphs by checking out our docs. You can also head to the Discord, thegraph.com/discord, to speak with one of the other engineers in our community that's built subgraphs before, and even talk to other dApp developers who are currently querying active subgraphs. The cool thing about building a subgraph is that it's part of an open source, crowdsourced community. And so you're contributing to the global graph of data, not just using it yourself. And that's also the cool thing for you as an integrator. If you're not interested in actually building the subgraph yourself for whatever reason, you can use an existing one. And that means that you're reducing your own redundant backend work. You don't need to set up a server or database, and you also don't need to maintain it. But we do encourage you to build a subgraph for your use case. And so that might be as simple as making aggregations, just combining data between smart contracts, tracking events or call data, really anything to get your app functioning. Some of the other bounties we have are one prize of 1,000 DAI to the best new subgraph. And we also have 3 prizes of 1,500 DAI each to the best new subgraph on a scaling solution that's supported by the Graph's hosted service. Lastly, we have 2 prizes of 250 DAI each for the best memes related to the Graph and scaling Ethereum. Lastly, if you want to learn more about how to deploy a subgraph on an EVM chain, you can tune in at 4 p.m. Eastern to see Dave, a blockchain engineer at Edge and Node, and you can ask a lot of questions and just hear more about what happens behind the scenes. If you want to learn more about the graph itself, I'd also suggest checking out the forum. So forum.thegraph.com is where you can see a lot of our ongoing community work, whether that's a governance proposal for the network, or maybe even information and resources around subgraph development. You can also check out, example subgraphs by heading to thegraph.com/explorer. This is where you can literally, find the endpoints for some existing subgraphs. You can search to see what's been deployed already. And you can also play around in the playground so you can test out GraphQL queries before committing to it. If you want to learn more, I'd suggest also following us on Twitter, where we keep up with announcements on multi-blockchain, any other integrations, and our progress on the network. Excited to see you guys hack. Bye.
Those were 2 awesome, amazing intros from Raiden and The Graph. And just to summarize their prizes, Raiden will be giving $2,000 in Raiden tokens for the Litecoin SDK use. Anybody who's porting to rollup or L2 with Raiden will get $2,000 in Raiden tokens as well. And a Litecoin integration on the front end side with Raiden will also win a $2,000 prize in Raiden tokens. And then there'll also be a runner-up category for each of those, getting $500 each. And for the graph, the best existing subgraph related hack will get $1,500 in DAI. The best new subgraph that gets published will get 1,000 DAI. The best new layer 2 subgraph that gets worked on, there'll be 3 prizes for 1,500 DAI. And the best graph meme related submission will get 250 DAI in prizes. So with that, I want to move on to our last set of our sponsors, and we'll have Polygon and Compound Grants Program share some of their interesting perspectives.
Hey everyone, this is Muskan. I lead developer relations at Polygon. So we're really excited to be here, like sponsoring Ethereum scaling hackathon. And like I'm sure like all the hackers participating in the hackathon will definitely enjoy experiencing all the scaling solutions and building upon them, because like scaling is the need of the time right now. So I'm really excited to see like some amazing hacks coming out of the hackathon. So yeah, let's see. So telling you like more about Polygon. So Polygon is basically a well-structured, easy to use Ethereum scaling platform. So Polygon, which is previously Matic, was founded in 2017 with this hybrid POS plus plasma kind of chain approach. And since then we have like seen great amount of adoption on a POS and plasma chain. So basically these chains are a commit chain to Ethereum. So by commit chain, what I mean is that every like 256 blocks, we Merkle root transactions to Ethereum. And so by this, what I mean is that these chains are like tethered to Ethereum chain. And like like seeing like in our journey ahead, like going deeper into this scaling spectrum, we realize that like there have been a lot of like solutions coming up, like zk rollups and optimistic rollups, and some like there might be like more solutions coming in the future. There's no like one size fits all scaling solution. Like developers have to keep on like learning about new solutions and see like which solution will be like applicable to their kind of use case. So just like working on like seeing all these problems and working upon them. So we just came up with the idea of Polygon. So Polygon is basically a kind of a layer 2 aggregator, I can say, like be it like zk rollups, be it optimistic rollups, or be it any other standalone chains. So you will be able to find everything on one platform. So now it depends on the developer, like which kind of solution that developer needs for his kind of application. So if like he is working on some NFT kind of solution, so there might be another like he might need POS kind of solution. He's working on some DeFi application, so he might need another like optimistic rollup kind of solution. So like he'll be able to find every solution on one platform. So basically Polygon is a Swiss Army knife for Ethereum scaling and infra development. So like, of course, this will take a little time to develop, but right now the production ready chains are like Matic POS and plasma chains, which is like quite like which is well adopted chains by the ecosystem. Like there right now, if I say like there are like more than 200 plus applications which are being developed on these POS and plasma chains. So I think you guys will also really enjoy like building on these chains, because it's really simple to develop. Like we usually say internally that if you are an Ethereum developer, you're already a Polygon developer, because all the toolings and like functionalities which are compatible with Ethereum chain that are compatible with Polygon as well. And it's really simple to deploy. You just need to change one RPC and it's done. You don't need to like change any other things. You just need to change one RPC in your like contracts and you are done. That's it. Now telling you about the bounties. So we usually like to keep it very open, and like whatever you want to like build, it's just let your imagination run wild, and like you could build anything, because it's really like cheap to experiment things with Polygon, because gas fees is really less. So you could build anything, but like there are some of the ideas which I would like to share. So you could build some like a marketplace setup using Arzora contracts and Polygon. Any kind of minter to mint NFTs directly on Polygon, and an NFT bridge, which can be used to like move these NFTs from Polygon to Ethereum main chain. Then you could like work on some like forks of popular DeFi protocols like Balancer, Curve, or any other protocol you want to work upon. Next is some DeFi tooling, like something like yield calculators or like DeFi analytics pages for Polygon. Other can be a like bridge for the FX portal. So last is like use Superfluid on Matic to build the scalable streaming money applications. So yeah, these are some of the ideas like I would like to share. But it's quite open, and if you want to work upon anything else and make use of Polygon speed and scalability, just feel free to do that. Like sky's the limit here. So yeah, like we'll be awarding like 7,500 USDT to hackers which are building their hacks on Polygon. So like this is the distribution. Yeah, that's all from my end, I guess. And let's see, like I'm really excited like what kind of amazing hacks will come out of this Ethereum scaling hackathon. So really like thanks to
Hey everyone, I'm Adam from Compound. I'm the developer relations lead. My job is to help you out with building your Ethereum related development projects that include the Compound protocol. Compound Grants is sponsoring this year's Scaling Ethereum Hackathon with ETH Global. And if you haven't heard of Compound, it's a protocol for supplying and borrowing of assets on the Ethereum blockchain. So developers can include interest rates in their applications by using the smart contracts. Popular apps that use the Compound protocol are Argent, Pool Together, Exodus, Zerion, and there's a bunch more at compound.finance. Developers can learn more at compound.finance/docs. We have method documentation for all the smart contracts, API docs, as well as open source code and blog posts that explain how to include the protocol in your app. Lots of education materials there. You can also join us in Discord at compound.finance/Discord. There's a development channel where you can ask questions and bounce ideas off the community, and they'll help you out there getting started with your project. So this hackathon's Compound bounties will include projects that scale the Compound protocol. The current challenges for users are high gas fees with supply and borrow, and also claiming comp, as well as governance proposals and voting. So projects that implement general Compound protocol gas savings or zero knowledge technology or layer 2 will be considered for the Compound bounties. So you can join us again at compound.finance/Discord, and we'll help you out there. You can chat with us, and yeah, we're always here to help. So we're excited to be a part of Scaling Ethereum, and we can't wait to see the creative projects that you all are working on. See.
Amazing. So thank you, Muskan and Adam. Those were the last two videos we wanted to share from our sponsors. And just to summarize, the Polygon prize, they were giving away over $6,000 for the best use of Polygon and the Matic network. In the first place, we'll get $2,500. There'll be two $1,500 second place prizes and two $1,000 third place prizes. As for Compound, we encourage you to check out the list of open bounties and ideas that are being proposed by Compound Grants. And they're here to support this event and really get in the zone of helping out and seeing how we can make DeFi and Compound more possible on the L2 side. Now, of course, those were some of just the sponsors that were able to share their prizes and tell us about themselves directly, but there are a handful of other ones that are also doing prizes. And I'll just quickly give you a heads up on who they are and what's being given out by each of these companies. So Taurus is giving away $7,500 in prizes. Aave will be giving away $5,000 in prizes. Superfluid is also giving $5,000 in prizes. Both Chainlink and NewCipher are giving $5,000 in prizes for the best integrations for all of these protocols. Covalent is doing $3,000 in prizes. Teller is also doing $3,000 in prizes. Zapper is doing $4,500 in prizes. 1inch Exchange is doing $5,000 in prizes. The Secret Network is doing $5,000 in prizes. And ENS integration prize is $1,000 in total. And there's a few more sponsors that are finalizing these, the total numbers for their prizes. So we'll update that in the prizes page. And just so you have all of this handy, all of the prizes and that information with the details for what it means to win a prize and how you qualify and how do you use anywhere from documentation to the details of each of these protocols is available at scaling.ethglobal.co/prizes. This will take you to the info center on the prizes page, and you can see all these details of $200,000 plus in prizes there directly. So we are ending the intro and the kickoff for the hackathon. I want to wish everybody again a happy hacking, and we'll be switching gears to our scaling summit. So that said, I want to quickly just say hello to everybody who joined in just now for our summits. Scaling Ethereum is a 3 to 4 week long event that's happening. We'll be covering a lot of talks and summits related to scalability and what's happening in the Ethereum ecosystem. And there's also a hackathon that goes on for 3 weeks. People will be doing a lot of interesting ideas and experimentation related to scalability and Layer 2. My name is Kartik. I'm one of the co-founders of ETH Global, and I'll be your MC for today, especially with all of our summits. And just as a quick note for everybody joining in, we are using ethglobal.tv as our platform to watch all of our summit content. So I really encourage all of you who just joined in to sign into this page so you can ask us questions that we can relay directly to our speakers in real time. And also for everybody who is signed in, we'll be monitoring everybody who signs up and giving out NFT POAP tokens for attending this summit today. So all that said, there's a quick overview of what the next few hours look like. We're going to have talks about the high-level categorization and the works of rollups by Patrick McCrory. Then we'll jump into how Optimism and Arbitrum are set up internally. Then we're going to have a quick panel about optimistic rollups, where Patrick and our previous 2 talks will be doing a Q&A. Then we'll learn about scale and app-specific chains, and then transitioning into how Matic and their scaling solution works. Then we're going to learn about what it means to do withdrawals and security for assets in optimistic rollup scenarios. Then we'll also learn about how swaps and liquidity providers can play a role in the L2 ecosystem, especially as we think about cross L2 transfers with Connext. Then Mo from Seller will talk about Layer 2.finance, their approach to understanding how we can make DeFi better on Layer 2. Then we'll have Alex talking about zk Porter and zkSync and how they are doing their zk rollups. Then we'll have Tom from Starkware talk about their road to Starknet and making it easy for everybody to really make quick and cheap transactions on mainnet. And then to sum up all of this, we're going to have a talk by David on Synthetix, who have been live on an L2 solution for quite some time, and they'll be sharing their experiences and the challenges that went into porting Synthetix over from mainnet to Optimism. So without further ado, I'd like to welcome our first talk of the day. Patrick McCrory is going to be talking about what are rollups, and he'll be doing a really amazing talk on how everything works in this world. So Patrick, welcome, and I'll let you kick off with your presentation.
Awesome. Thanks for the introduction, Kartik. I'll just share my screen now. Hi, everyone. So I'm just going to quickly present for the next 15 minutes, what even is a rollup. And what I want to highlight before I begin is that I'm not affiliated with any rollup, project. So I'm going to try my best to give you an unbiased view of, the problems that they're trying to solve. I currently work for Infura, and I also advise Lemnicap. So without further ado, as everyone's aware, this wonderful event is going to be about blockchain scalability for the next month. And over the past year, a bunch of new projects have emerged, like Arbitrum, Aztec, Seller, zkSync, Optimism, Polygon, Starkware, zkSwap, and Loopring. And these are projects that are called rollups that are promising low fees, smart contract deployment, transfers, and a much better user experience than developing on Ethereum. So what I really want to highlight is, why does this matter? What are the problems they're trying to solve? And hopefully set you up for the next 3 weeks so you can get a really good understanding of what's going on. But before I get into that, I always like to ask people this question. Have you ever deposited coins into an exchange or an online service like Coinbase, Binance, or Bitstamp? Normally I ask people to raise their hand, but there's no hands here to be raised. But pretty much, if you've ever used an exchange before, then you've actually used a Layer 2 system. You've had to deposit coins onto the service. You get a balance that, becomes positive on the website. You can then, trade, you can execute transactions, whatever. And the idea there is that these intermediary services, Coinbase, Bitstamp, Binance, etc., they're technically Layer 2 sequencers. They take all of their users' transactions, they order them, they execute them, then they update their, their Layer 2 database, which basically determines how much funds you have on the service. Now, the problem with these Layer 2 services is, one, they're fully custodial. They can freeze, confiscate, or they could even just lose your funds. Two, they're not auditable. that layer 2 database that they have, can anyone here access the Coinbase database? Well, obviously not, because it's opaque and it's not publicly auditable. So the question then is, are these layer 2 services, are they running a fractional reserve? And we don't know, who knows? We can't actually look at the database. And as I mentioned, they also, control the ordering of transactions. So given a list of transactions, they can order them and determine how they're executed. So layer 2 is used every day, but it is custodial and is high risk. Back in 2016, Goon had this wonderful tweet that 33% of Bitcoin exchanges have been hacked. And then as they get hacked, they tend to be large scale. So Mt. Gox has lost 850,000 Bitcoin, Bitfinex lost 120,000 Bitcoin. And it's not because they're not being malicious or adversarial. It's just very difficult to keep custody of a large, big honeypot of funds that a hacker can just get in, steal the private key, and then run away with all your funds. So the question is, all of these rollups and all these cool layer 2 protocols, can we transact on a layer 2 system while still allowing users to maintain full self-custody of their own funds? So let's find out. What I'm going to explore today is I want people to get a better understanding of rollups, and more generically, as Polygon said, commit chains, because rollups are just a single instance within this entire design space. And we're going to look at this from first principles. So what is a commit chain and how does it work? What is the wider environment they live in and what are the protocol assumptions? Who is the adversary? What is their power? And how are they trying to break the system and steal your funds? And finally, what are the security goals that need to be satisfied before a rollup is secure? And hopefully this will set you up for the rest of the hackathon. So the big difference with these commit chains is that you still have this sequencer. There can be one sequencer or multiple sequencers. They're still collecting layer 2 transactions. They're still ordering the transactions. But the big difference is that they have to post little checkpoints to Ethereum periodically. These checkpoints will define the order of transactions and also the execution of all those transactions. So what is the current state of the layer 2 database? And there's this little checkpoint that's sent to Ethereum. And so this big difference allows for layer 1 enforcement. So it's up to the layer 1 to enforce that all these transactions are valid and correct. Then Alice comes along and Alice wants to use the layer 2 system. So Alice will still have to deposit one coin into this layer 2 system. But the big difference here is that this coin is deposited into a layer 1 smart contract and is never given to the sequencer. So the sequencer never has custody of your funds. And typically you still have to do a signature in order to transfer funds in the layer 2 system. So this layer 1 contract that enforces the rollup rules also has custody of your funds. Then Bob comes along. Hi, Bob. And Alice wants to sign a coin to Bob. So Alice will sign a transaction, give it to the sequencer. Then the sequencer can ping Bob and say, Bob, you've now got one transaction, one coin. But this isn't final yet. This is still pending until the sequencer pushes a checkpoint to Ethereum. So we wait around, there's no new transactions, checkpoint gets posted, then everyone can see that Alice's transfer is confirmed and Bob has received the one coin. And over time, checkpoints get posted and that finalizes the transactions. Now, the final difference, which really makes rollups, and commit chains beautiful, is that Alice should be able to use Ethereum, this layer 1 blockchain, to get the ground truth data, about the layer 2 system. It should also be able to fetch the entire transaction history for the layer 2 system and recompute the entire layer 2 database herself. And then she can verify that everything is valid and everything is correct. But what does it mean to be secure for a commit chain? Well, Georgius has this wonderful Twitter thread that says, what makes layer 2 special is that layer 2 security equal layer 1 security. But I'm going to argue that's too ambiguous. Layer 2 protocols really cannot have the same security as layer 1, but they can get pretty damn close. And it's really this pretty damn close is where the detail and the really cool innovation is happening. So what does it mean to be secure? So now I'm going to cover the protocol assumptions and the threat model. What do we assume to be true? Who is our adversary? And what special powers do they have? And then I'm going to talk about the security goals and what we're trying to actually keep secure. So the adversarial model, I'm going to break it down into 2 parts. First, the adversary has control over the message control flow. So any message is sent on the layer 2 system, the adversary can view, order, and drop. So they can censor all the transactions in layer 2 if they want, and they can reorder them. The only thing they can't do, and this is a protocol assumption, is Alice can always reliably send a transaction to the layer 1 blockchain, which is Ethereum. And as long as he pays an appropriate fee, it will always get mined. And this also assumes Alice can always see the layer 1, Ethereum can always see the contents of that, and the layer 2 system can't stop her from looking at it. The second is, part of the adversarial model is that there's only two trusted parties. There's Alice, who's honest, the single user, and the smart contract, Ethereum. We assume both of those parties are honest. Otherwise, the adversary can corrupt everyone. They can corrupt every sequencer, and they can corrupt all users. So really, if I'm using this layer 2 system, I have to assume everyone can be corrupted. And I still have to be safe and secure within that environment. So really, we've described the most powerful adversary possible. And really not every rollup has the tools to fully constrain or outright defeat this beast. But another way to look at it is that it's a tag team battle between the honest user, this layer 1 smart contract, and they're fighting the sequencer and the adversary to make, constrain it and make it bend to their will. And if you don't have this epic fight in your hands for a layer 2 protocol, then it's not really a layer 2 protocol. And unfortunately, I'm not too interested in that. So what are the security goals? What are the security properties? What are we trying to keep secure? How are we trying to constrain this adversary? The first one is the data availability problem. So what do I mean by this? So as I mentioned, the sequencer has to post little checkpoints to Ethereum. It's typically a 32-byte hash, which will include the layer 2 state and a list of transactions that are being executed. So how do we guarantee that the entire transaction history for the layer 2 ledger is publicly available? So this is important for several reasons. One, audibility. Alice wants to recompute the layer 2 database herself. She needs the transactions to recompute it herself. Two, interaction. If she's going to send a swap on Uniswap on this layer 2 system, she wants to verify that the exchange rate she's being quoted is correct according to the layer 2 database. And finally, withdrawal. If Alice wants to withdraw her coins from the system, she may have to inform the layer 1 blockchain what her final balance is that she's going to withdraw. And bingo, this is where we get rollups. This is the only thing that rollups solve in terms of all these problems. A rollup literally means all transaction data is rolled up and posted to the layer 1 blockchain. This is actually a slightly stronger assumption. We now assume the layer 1 blockchain has plenty of storage. They can store all the transaction data. Bandwidth is not an issue. And everything can be stored on Ethereum. But this is one of 4 ways to solve that problem. But that is what a rollup is. The state transition integrity problem now. So the issue here is, how do we guarantee that the final execution of a layer 2 transaction is correct? Because a sequencer could post a checkpoint which has the state and an invalid transaction that steals everyone's coins. And if the sequencer can get away with this, then obviously they can just steal all the funds in the layer 2 system, and it's not secure. So there's another bingo card. This is optimistic versus zero knowledge, fraud proof versus validity proofs. I'm not going to go into it now, but you'll hear plenty of debates over the next few weeks about the pros and cons of either approach. But again, that's the only problem fraud proofs and validity proofs are solving, state transition integrity. And the final problem is withdrawal integrity. So let's just say Alice wants to withdraw her coins from the system. She says, sequencer, here's my withdrawal transaction, give me my 10 DAI. And the sequencer says, no, you're stuck forever. You're never getting your coins out, they're confiscated. The system should be set up so Alice can always withdraw her coins, even if the sequencer is offline or does not cooperate. So now we have our 3 problems: data availability, state transition integrity, and withdrawal integrity. If we can satisfy the above problems, then hopefully we can slay the beast, deploy a secure layer 2 system, and everyone can have all their unicorns. But even if we can satisfy all 3 properties, do we still need the trusted sequencer? So the answer is yes, no, yes, no, yes, no. One, it depends how well people can satisfy those 3 problems, and there's no perfect solution out there. But there's also other problems that pop up that relate to security. The first is minor extractable value. And you're going to hear a lot about this over the next 3 weeks. But the idea is that the sequencer can control the order of all transactions. So if I send in a trade on Uniswap and I allow for $1,000 worth of slippage, the sequencer can sandwich me. They front run me, they back run me, the victim transaction goes in the middle, and they interfere with your computation and they extract $1,000 from your trade. They haven't tampered with your transaction. They've just played with the state so they could take the slippage. Is this an outright attack on, the system, or is it a potential business model? Is it the Robin Hood of rollups? There's still a debate out there, but what we do know is MEV is very profitable. You can go look at the Flashbots project, and they're making way more money than honest miners who just take the transaction fee. I think over 60% of miners now are now using Flashbots. But most importantly, we need to trust sequencers because this is the difference between the fast path and the slow path, and I mean the very slow path. If sequencers are honest, I give my transaction to the sequencer, they'll acknowledge me right away to say, Paddy, your transaction will be mine. This is the final execution, and it'll be finalized within the next 2-3 hours. I walk away, I'm happy, it gets finalized, and the sequencer did what they promised. If the sequencer cannot be trusted, maybe I give them my transaction, they want to do some MEV or whatever, and I have no guarantee what the final execution is going to be, then actually I may end up on the very slow path. Because one, I'm waiting for 4 hours or 2 hours to know what the final execution really was. But also I may just have to send the transaction to Ethereum directly if I want it to be truly executed the way, I want it to be definitely 100% included in the blockchain. Then that's actually the very slow path, and that's even worse than Ethereum today. So we still have to care who these sequencers are going to be and what keeps them honest. So what we need to consider is that, first, how are sequencers selected? Is it centralized? Are they appointed? Are they elected? Do they have stake on the system? And also the consensus protocol. How do these sequencers reach agreement on the next set of transactions to be executed? Do they take it in turn to Alice Bob Caroline, Alice Bob Caroline, or do they have some BPFT protocol there? So this is my final slide. I obviously haven't given many solutions in these slides, but what I hope that I've given you is a much better understanding about the problems that surround rollups. And throughout the hackathon, you can now poke your favorite project and say, how do you solve the data availability problem? How are you solving the state integrity problem? Do you deal with MEV? Do you have order fairness, etc., etc.? So I'm going to finish with this slide. This is what a layer 2 protocol is about. And if you don't have this battle on your hands, then it's not a layer 2 protocol. So thank you for listening.
Thank you so much, Patty. This was super helpful as a context, and we also have a few questions coming in already. So what we'll do is we'll send you the list, and we'll bring you on at the end of the next 2 talks for the panel, and you can ask those questions and answer those questions there. So all that said, I am super excited to intro our next talk, and that is Carl. Carl's going to be talking about the optimistic virtual machine, the OVM, and Carl's from Optimism. And without further ado, I'll let Carl kick off with his talk. Hey, Carl.
Why, hello. How's it going, y'all? Very exciting. This is been looking forward to the Scaling Ethereum Hackathon, the best topic for a hackathon possible for a while. So, hello. I am Carl. I'm going to talk to you about just optimistic Ethereum, a quick overview, and the future, and a scalability deep dive, aka what do we really mean by scalability? So let's get started. Let me actually turn on a clock. There we go. So let's dive in. If this is what you think scalability is, this is incorrect. If this is what you think scalability is, this is incorrect. Scalability, the transaction fees are way too high. Thankfully, I have been talking about this for a long time, and people seem to, get the picture now. So that's really nice. 15 seconds, 15 minutes. These are all way too slow. We need super quick transactions with low fees. It is unacceptable. But let me go back a little bit, time travel, and talk about who I am, what's Optimism PBC, and how did we really get here? So I actually started out working at Consensus for a little bit. Then I kind of traveled around the world with Vitalik and talked on some stairs and, ranted like I'm doing now. And then, had a little introduction to cryptocurrencies and worked on this crypto economics book with Jing and Kevin and, told my friend, oh, you should really get into crypto. And they got really depressed because he was my last friend who wasn't into crypto. And then my friends got me out of that depression. Thank goodness. We formed Plasma Group with Kelvin and we were like, oh, can Plasma, scale Uniswap? No, it cannot. And so we worked on this thing called Optimistic Rollup and we created Unipig and we created this new thing called Optimism. And Synthetix was like, oh, Unipig was pretty cool. Let me take a look. And then, Mark joined and Krista joined and Josh joined and, Annie and Liam and Gigamesh. And it was, it's a big, big, happy, explosive family. So that is amazing. And, the Optimistic Ethereum family is growing bigger and bigger. And this talk is going to be all about community. It's going to be all about, Ethereum. But before we get into all that, let's go into a little bit of technical stuff, a little bit of technical right here. And then we got, after the technical stuff, we got some design principles, which is less technical. And then we'll go into the rest. So what is Optimistic Ethereum? It's a minimal addition to Ethereum that enables an EVM-based layer 2 rollup. But what does that really mean? Basically, it's just Ethereum inside of Ethereum. So, very technical work coming in. We got Ethereum, it's the L1, right? That's the base layer. And then we got Optimistic Ethereum, which is L2, and it's in Ethereum. Wow, very crazy. It's a little recursive, And before you ask, yes, in fact, you can do, a L3 and put Optimistic Ethereum inside Optimistic Ethereum. But let's dive in. Okay, so how does this work? Okay, first, y'all can take a look at a bunch of presentations that, Ben and Kelvin did yesterday. And, we've got a bunch of presentations on this. So I'm not going to actually take too much time, but Optimistic Rollup is, the Optimistic Ethereum is a combination of Optimistic Rollup and the OVM. And Optimistic Rollup gives us security and the OVM gives us EVM expressibility. And so I'm going to give you a 1 minute presentation, 1 minute, of course, for what exactly that means. All right, 3, 2, 1. Go. Let's see how I do. Okay, Optimistic Rollup. We've got the security portion. So Ethereum is processing all these transactions. It's a tired Doge. It's doing too much work. And so then Optimistic Ethereum comes in. Don't fear. Let me help you do some transaction processing. And then it goes bad. And then the verifiers prove fraud. And then it, goes well. And Ethereum is happy and a happy Doge. Success. Okay, so that's how Optimistic Rollup works. Very nice. And this is how the OVM works. So normally you have smart contracts, they talk to each other, but we need to put EVM inside of EVM. We need to put Ethereum inside of Ethereum. That means we need container virtualization. Boom. So we take the OVM. The OVM is this container virtualized EVM. We can run it inside of the EVM. So now we're diverting calls, to the, container contract, this virtualizer contract, and all of the stateful operations, they go through that. That's how we maintain a sandbox. And that's how this thing works. It's kind of similar to the diamond pattern and stateless execution. Bam. That was actually 1 minute. I did just record it. So very good. So Optimistic Rollup, right? For the fraud proofs. OVM is for the container virtualization. It's to give us EVM inside of an EVM. That's Optimistic Ethereum. But what is Optimistic Ethereum really? Like, what is the essence of this project? Because technology is only one aspect of the puzzle. So the Optimistic Ethereum design principles, 2 of them that I'm going to talk about today are incrementalism and minimalism. So incrementalism. It's really fun to say things like, oh, we've solved scalability. Oh, there's this big breakthrough. Wow, 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 and like the world explodes, right? That is, I said those things, in fact, many times. And, it's fun to an extent, but in reality, progress looks a lot more like this, right? We're like, slowly building up the kind of global intelligence of the human species, right? And it's been getting built for a long time. So we're little tiny cogs in that greater machine. And that is really what what things are like. And so there's a real scalability solution in Ethereum that doesn't get talked about nearly enough. And that is Geth, that's Open Ethereum, that's TurboGeth, that's these incredible researchers. That's these people that, for instance, in the past few years, we've increased the scalability of Ethereum over 2x, right? Like the scalability is not something that just kind of comes out of the blue. It is based on a huge amount of work from a lot of different people, including research that is being implemented as EIPs, like changing the gas prices of various opcodes or introducing access lists, right? Or the most cutting edge research, like things like Verkle tries for, stateless clients. This is the stuff that really gets us scale. And tooling, right? We've got a ton of incredible tooling in the Ethereum ecosystem, tons of folks working on it. And that is required if you're trying to build a production piece of software, you need production level tooling. And so all of this stuff is built on, open source software and public goods. And it's so exciting to be able to work and build technology that utilizes all of this different tooling. And so that is what we're trying to do with Optimistic Ethereum, right? We're trying to build on top of that software and kind of fit in like a puzzle piece. That means that we must support the OVM. The EVM. That means that we, need to, if we can implement this incredible research that's being done, and we can make use of the implementations of that research that are built for ETH1. It allows us, and of course, open source everything, that goes without saying. It's like we can be a test bed for ETH1.x. And so the other thing that I want to talk about is minimalism. So a wise sage named George once said that every line of code costs $100. So you better not write a lot of lines of code because it's expensive. So really what this, this process is, it's really just this surgical precision that you need to have when you're, for instance, upgrading Geth to be optimistic Geth, right? You need to minimize your diff. You need to minimize the lines changed. And the reason why is because we're standing on the shoulders of giants. This is a kind of weird photo, but it's standing on the shoulders of giants. And so that goes for the protocol itself, right? We can't diverge from Ethereum too far because the further we diverge, the less we can kind of make use of this incredible ecosystem, right? We're trying to maximize our leverage, maximize our impact. And to do that, we need to make use of all of the technology that has been built before. And that also all of the tooling that's been built before. We have to fit in like a puzzle piece and be that test bed for ETH1.x that I talked about. So those are some of the main design principles. The other one is, gotta be love, gotta give love, gotta be, be nice to each other. So anyway, that's that. Okay, so next we got the path forward. This is a kind of, overview of where we're headed. And then we're going to, after that, talk about this whole kind of deep dive into scalability. It's a little more technical then. But before we get into the technical stuff, let's stay at a high level. So we're currently on pseudo mainnet. We've saved folks over $10 million. It's pretty cool, pretty sweet. And we came up with a few names for these releases. I'm going to talk about a bunch of releases. And, these are subject to change, but the first release is Inconspicuous Medium-Sized Animal. This is the mascot for this incredible release. And we're hoping we need to go to full mainnet next. And the thing that will take us there is improving our upgradability infrastructure. So I was actually planning on talking about that in this talk, but I ran out of time. So the upgradability is a future talk coming up. There's just too much to talk about on this other stuff. So anyway, the code name Chalk Marker. This is our first, our full mainnet. And so the reason why is because we write on Windows with chalk markers. Chalk markers are great. You should buy them. They're great to write on Windows. So our full, 4 releases categories that I have here are Chalk Marker, then Irritated Window Cleaner, and then Poor Airbnb Rating. And finally, the finale, ultimate, release is iPhone 4. So we've got, for each one of these releases, there's, various things, and we'll go over each one. So first, Chalk Marker. We've got instant upgrades We've got arbitrary contract deployment. So arbitrary contract deployment, that's good. But we've got no slashing, and we've got a single sequencer with OVM self upgrades. So what does this really mean? It means that we've got these guardrails, right? We're definitely not at the decentralized, end goal that we want to be in, where we know that there are like things that are fundamentally broken about how the, protocol works. This would not be sustainable long-term, but it gives us the flexibility to actually, iterate on and try out the software that we are building. No eggs were harmed. The next step, we're getting better. We're closer to the decentralized utopia with delayed upgrades. So instead of being able to instantly upgrade the contracts, they're delayed. And we've got slashing, and we've got a single sequencer, and we've got some simple compression for data availability optimizations. And so that, that we're getting there, but we're still a single sequencer. We're still running it. And that we definitely do not want to be doing that as soon as humanly possible. Then the next one is poor Airbnb rating. So now we're really decentralized. We got super delayed upgrades, multi-sequencer, we're starting to mess around with speculative execution for scalability purposes. We've got pluggable compression and some fun stuff with, gas limit rating using an EIP 1559 curve. Anyway, all of this stuff, but there's one fundamental thing that we're missing, and that is ETH2. And so finally, the kind of nirvana iPhone 4 is, we've got ETH2 shard blob transaction feed. So in other words, we can use the ETH2 shards for our data availability. That means that we can scale up to use all of the availability, all of the kind of availability that is provided by ETH2. And we're actually going to talk about what that really means in very soon. And we've got some other fun stuff like Optim upgrade support that allows you to kind of fork the chain arbitrarily and conceal transactions and zkEVM, all these fun things. So this is the kind of high level progression, right? Starting out, centralized, more flexible. We have to have upgrades throughout this entire process. And then we get, more and more decentralized, one thing at a time, until we are like fully integrated into Ethereum and decentralized. So that is the path forward. Okay, so we did design principles, we got the roadmap. Now we're going to go back into some technical stuff because there is, I can't help myself. I'm going to talk about technical stuff no matter where I am. And this is one technical question that has come up so many times. It is, what is scalability? Like when people say scalability, okay, it means something goes up. But do we actually talk about what is that thing that's going up? Is it transactions per second? What does it mean to increase your quote transactions per second? That doesn't actually give you a picture, a vivid image of what the blockchain infrastructure needs to be. So let's talk about that. When you have a scalability problem, that means that you are constrained. You are resource constrained, meaning that you need to increase the supply of a resource. So there are 3 blockchain resources, and I'm going to claim that this is essentially universal across blockchains, and all of the designs of blockchains that you will see have these 3 components. And you'll probably hear about it in different words. Everyone uses different vocabulary to express the same thing. But here I'm going to talk about it as availability, compute, and storage. Those are the 3 blockchain resources. And so we're going to actually use an analogy to get a little bit more of a vivid image of what this means. So note, I have no idea what a water processing plant is, but I'm going to use it anywhere because it felt about right. I just vaguely remember from biology class or something. Okay, so we have got this availability. It's the pipes. It's the pipe going into the flagellation basin. And the flagellation basin is the kind of compute, right? We're doing something. We're churning up the water. And then it's going into the storage container, the kind of water cooler looking thing that holds all of this water. And this water is like the trusted computation that fuels humanity, right? Just like we have water, we need trust. We need trust in our computation, and we need to build a universal trusted computation layer for humanity. That is the goal. We need this system. It is one amazing machine, and we can get there. So availability, let's actually dive in a little deeper. What does availability mean? Well, messages are propagated throughout the network on these blockchain systems, and we come to consensus on what the next block is. And so availability is essentially how much data you can come to consensus on over one period of time. So the more the better, obviously, the bigger the pipes, and we're measuring this in bytes per second. So the more bytes you can come to consensus on, say these bytes are in the blockchain, the better. And then you've got compute, and that's the fluctuation basin. And essentially what that is, it's how much math you can do and trust that that math is computed correctly. And so it's like, your smart contracts, how many executions of your smart contract can you do? And how many cross-contract calls and all of that kind of stuff? And how many state roots can you produce? And so essentially, in some ways, it's just like how much you can do X times Y equals K over and over again. If you don't get that, ask your neighbor. So we're going to measure this in gas per second. Now, notably, gas per second is not really quite right for reasons that you'll kind of see later on, but we can think of this as more like the gas of pure opcodes per second that we can do and form consensus on the result of. So that is our computation. Pretty simple. Finally, storage. This is a little different from the first two. Storage is how much we can actually store in a single node. So this is measured in bytes. It's actually a fixed quantity. It's not a kind of, quantity over time, like a rate of change. Instead, this is just a cap. And currently we're at like 70 gigabytes, maybe it's 80 gigabytes, maybe it's 90 gigabytes. I'm always out of the loop about this. It just keeps growing and changing, but whatever. Maybe it's at 60. Anyway, so store and create, it's for like all the things that you store in the blockchain state. I call it storage, but it's really in the blockchain state only. It's not the history, it's the storage. So for instance, if it were to grow to 200 gigabytes or something like that, then nodes might start falling off of the network and have to be replaced with nodes that are run in data centers. And this decreases decentralization and is not good, especially for layer one. We need to keep the state low, and we need to make the computational requirements of running a layer one node as low as possible. And notably, this resource actually, the state actually always grows, basically. I mean, technically you can reduce it, but almost no one does it. And so it's always growing. And so even without changing anything, our blockchain, Ethereum, is fundamentally flawed because it will explode at some point. This water basin will just burst because there's just going to be too much state in the chain. And this is a ticking time bomb that literally is something that we need to essentially, save Ethereum from, soon. And that is that we're going to talk about that. That's some stateless client work. But anyway, if we want to, support all of humanity on this thing, unfortunately, we can't in this current state of affairs, right? Like, look at this thing; it's tiny, and there's nothing in this water basin that will, this water cooler is just going to fill up. So we need to increase these pipes. We need to also, increase the computational power, put some workers in there, and then we also need a drainage system, right, that drains everything. And this would be the ideal blockchain. But let's kind of go into a more mathematical kind of abstract representation of this stuff. So we've got three resources: availability, compute, and storage. Let's not talk about, well, first, the availability and the compute, there are these, this rate of, there's technically an unlimited supply if you gave it an infinite time frame, but it's more constrained by like the rate of growth. But in the storage case, it's capped supply. So let's just kind of ignore the capped supply for now. That's a little bit of a different topic, and I'll talk about it soon. But let's talk about scalability in ETH1. So both the availability and compute of ETH1 are limited by the gas limit. So what does that mean? That means that as the availability usage increases, the compute usage has to decrease proportionally. And similarly, if the availability usage decreases, the compute can increase. It's basically like you can send a transaction, and you can either send a huge transaction, or you can send a small transaction that does a bunch of computation. Both of them affect the gas limit. So the gas limit is 12 million. And if you used all of it for the availability, you get about 70 kilobytes per second of available data. So the pipes are kind of 70 gigabytes or 70 kilobytes. Oh my gosh, it's way smaller than those two first things. Or if you do if you spend it all on compute, you'll get about 800,000 gas per second. So now let's take a look at not just ETH1, but let's look at optimistic ETH1. This is, ETH1 and optimistic Ethereum kind of running side by side. So boom, 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 we got this other optimistic compute. So the ETH1 gas limit, let's say, is 12 million. Let's say the OETH gas limit for the sake of this example is also 12 million. And so now we've got equal usage across all of these different, these different resource constraints, but notably, you can increase the availability or the compute of ETH1 without affecting the gas usage or the gas resource consumption of optimistic compute, right? The optimistic Ethereum, right? You can spend all of your money on availability, all of your resources, sorry, on availability, and you can then also spend all of your resources on the optimistic compute. And so this is actually fundamentally just how you are actually able to scale up the total resource constraints of Ethereum. So we've achieved more scale. That's really exciting. But let's keep going. So notably, this gas limit, this 12 million gas limit, Geth has been increasing this over time. It has been an incredible amount of work by a bunch of folks, and not just Geth, but I mean, all of the Ethereum clients have been increasing it over time, and in fact, could increase it even further. And in fact, some folks have been experimenting with, in practice, using things like 140 million gas limits, which is just kind of mind-boggling and does give you a 10x performance, and it's technically possible, but it doesn't come free necessarily. It does require increasing the full node requirements. And so that means that instead of, this node, you need that, and, a node of this size, you need that size. And actually in layer 2, it can be okay because you can increase the full node requirements without affecting consensus. And I have another talk about that, but you can't increase it infinitely. This is not a, perfect solution. And storage, the state bloat problem becomes way worse, right? Because you're bloating up the state really quickly, you're going to burst sooner. And it's just as simple as that. But don't fear, the Ethereum community is here, right? This has been a problem for the Ethereum community since, the early days. And this is why we are, building on Ethereum. So the great thing is Verkle tries. I'm very excited by this. This is combined with stateless clients. So if in order to provide the release valve on the water cooler, you can actually create stateless clients, and that will essentially drain the water. It allows nodes to throw away old state. That's why it's called stateless. Instead of holding on to all of the state, you're throwing a bunch of it away. And so that allows the storage to be, to not grow over time. It's just draining the water. It's just deleting the stuff from the state. Technically, you can revive it, but it's, you have to prove that it was in the state in the first place. But notably, this actually also has implications on full node requirement increases. So normally you compute your blockchain doing, single threaded work, you go just, one block at a time. But if you provide all of the witness data for all of the blocks, then you can actually, as an Ethereum node, compute the validity of each block independently of one another and just compute it all in parallel. And that gives you, definitely a huge scalability increase just by utilizing more threads on your computer. And that's pretty cool. That's a really interesting synergy that doesn't actually come with a lot more complexity on top of the stateless client design. And we're building stateless clients in Ethereum, in optimistic Ethereum. We can be the test bed for Ethereum 1.x. And so even crazier, you can go full zk EVM and prove all of the blocks validity up front, and that scales logarithmically with the amount of computation. So it's pretty, that's even crazier, and that's the final boss. But this is how you can actually address these problems. And with those things addressed, you can make the optimistic Ethereum gas limit huge, absolutely massive. And we've gotten more scale, but now availability is the bottleneck. And so guess what? Optimistic ETH2? Well, ETH2 is here to solve the availability bottleneck. For phase 1, we don't worry about compute. We only care about availability. And that's literally what ETH2 does. It just scales up the availability by, using random sampling and erasure encoding for the, consensus on the future blocks. So it's pretty sweet. And so now you can combine this massive amount of availability with this massive amount of optimistic compute, and they scale independently of one another, just like on ETH1, and boom, we can max it all out and we can reach scalability nirvana. This is what we mean when we say scalability, right? This is scalability. It is a big set of pipes with a big fluctuation basin going into a big tank of water, and that tank of water is being drained by the stateless clients, and we are happy and clams. We are happy clams. You can almost see the blocks in there. You can almost see the blocks. And so that's Ethereum, that's optimistic Ethereum. That's the combination of the two. It's great. So I appreciate y'all and thank you. And the time's up. Let's do this. So, okay, I will do one shout out to this amazing, thing. If you want to work on a crazy experimental EIP that is called Virtual Call, reach out. Let me know specifically if you want to work on some Geth code, because it is extremely cool. Anyway, that's it. Thank you.
Thanks so much, Carl. That was an awesome talk. And there's a couple questions that are coming in. So I'll ask you to just kind of hang out here on this chat, and we'll move on to our next talk, and we'll do a quick panel with all the Q&As. So with that said, I'm super excited to introduce our next talk, and that is Harry from Arbitrum. And Harry's going to talk about the internals of how Arbitrum works and how they're thinking about the optimistic roll-up strategy. So Harry, I'll ask you to turn on your video and kick us off with your presentation, and welcome to the live stream.
Awesome. Thanks for having me. Really excited to be here. Really excited to have a whole ETH Global hackathon devoted to scaling. It was super fun getting to see Patrick's talk and Carl's talk. And yeah, really excited to be here. Let me just share some slides. Awesome. So I'm going to talk about Arbitrum Rollup, which is our solution to scaling. My name is Harry Kolodner. I'm co-founder and CTO of Off-Chain Labs, where we're developing Arbitrum. And I want to start out by just talking about why Arbitrum is awesome, and kind of why you should be excited about the future of scaling. Transactions are cheap. That's I think that's probably the biggest thing I think people get excited about, especially if you're watching the gas prices as they've been on Ethereum mainnet recently. You start to really wish you had some cheaper transactions. And they're cheap, and it doesn't rely on any expensive cryptography. There's nothing kind of expensive to run on Ethereum at all. We're moving things into layer 2, and it really feels like magic. The system is fully trustless, it's permissionless, and the security is derived from Ethereum. So you're not kind of trusting your security to some set of nodes that are kind of different from the regular old machines that are validating Ethereum. It's all still in that same Ethereum security model. Now, Patrick was totally accurate when he said it's almost the same as Ethereum. A lot of times, we kind of gloss over some of those like precise differences just because it gets into very nitty-gritty details and kind of in terms of what matters. It's the same where it matters. And then particularly for Arbitrum, kind of one thing that I think is a really big deal is kind of full EVM support and really easy porting. That kind of same contract you can deploy to Ethereum, you can also deploy on Arbitrum using the exact same tool chains, whatever version of Solidity you want, Viper, whatever you're using. You can do the same thing on Arbitrum, which is pretty useful. So the other cool thing is that we have a testnet. We've now had a testnet out for I think about 6 months now. We actually about a few weeks ago launched our kind of testnet, which is a release candidate for our mainnet, as we kind of chug along towards mainnet, which is obviously where we want to be. And I think already in the last 3 weeks, I just looked this up right beforehand, there have been 174,000 transactions just over the last 3 weeks from 64,000 different senders. So it's pretty cool, and it's kind of open. Anybody can use it, deploy their contracts, whatever you'd like to do with it. So kind of what is Arbitrum? Well, so we'll start from the big picture. There's kind of a queue of transactions. So if you look at that and kind of squint, it kind of looks like blocks. So similarly to Ethereum, we have our transactions. They're in an order. We have some chain state, and the state is what you get when you evaluate the transactions. And then these transactions have some effects. And that's kind of the mile high view of the system. And then obviously we can dig down a little more and see what some of those details are. But there's kind of a bunch of initial questions that sort of pop out when you're thinking about this when you're looking at that sort of high level design. Who keeps track of this information? There's a bunch of different data there. There are the transactions, there's the state, there are the outputs. Where is that? How do we ensure that the state's actually correct and the outputs are correct? Like I can say, hey, trust me, it's right. But can you be sure of that? Where do users come in? So how do you actually get your transaction onto the chain? And how do we interoperate with Ethereum? So is this thing just kind of floating on the outside? Is it connected? And kind of it is connected. How do we actually sort of navigate between the Ethereum chain and the Arbitrum chain? So just to kind of start off, I want to talk about the rollup protocol itself, which is basically how this thing is connected to Ethereum and how it's secured. And so first of all, I'm going to answer that first question, which is where are the transactions? Where is the inbox? And the answer is it's on Ethereum. That Ethereum is responsible for data availability, like it's come up in a number in the kind of previous couple talks. Whereas execution and storage don't happen on Ethereum. They're pushed off chain. But they still need to be correct because we want to be as kind of as close to Ethereum security as possible, which means we need to know that the execution and storage of the L2 system are correct. And the way that Arbitrum achieves this as an optimistic rollup is through fraud proofs, where a claim is made on chain, and then anyone in the world can verify that claim and challenge it if it's wrong. And I'm going to go into detail as to how that works. And what this means is that the entire chain is secured by the Ethereum blockchain. So here's our rollup protocol. We have blocks. We have a bunch of green check marks. Those are the blocks that everybody agrees on. They've been verified, and we all agree they're correct. But now we have Alice. Alice is creating new blocks, and she's created this block 93, and it's proposed. So she's made a claim. She's put down a bond. And she says, hey, this is the correct new state. But Bob comes along and he verifies Alice's claim and he says, wait a second, that's wrong. Now, Bob is anybody. Bob could be me, Bob could be you. There's no permissioning here. And so this could be anybody running a node who's willing to put down a state. And so Bob then makes a counterclaim and he says, well, actually, the state after 92 should be this. And now we have a dispute, which we need to settle somehow. In some cases, this kind of looks like a fork, but Ethereum needs to resolve it because there can only be one true rollup chain. And so we can't really allow this fork to go on. And so the question then is, how do we prove fraud? How do we actually settle this dispute? And so in order to talk about that, I want to just sort of quickly restate the setup here, which is that all the inputs to the chain are posted on Ethereum. And basically what happens from those inputs is deterministic. And so if I'm honest and I'm looking at those inputs, I know what's correct. And then we have some validators, and those validators have put down bonds and they've made claims about that execution. So they both have some skin in the game, and they're kind of liable to lose that bond if they've made an incorrect claim. And anybody can do this. So that's kind of our setup. And then the question is, so what happens now that there's kind of two conflicting claims? Well, the answer for Arbitrum is we use an interactive challenge process. And so we narrow down the dispute into smaller and smaller pieces and then run a small unit of dispute on chain so that Ethereum can be the final judge of what's correct and what's incorrect. So what does that look like? So what we do is a process called interactive bisection, where essentially you can think about the entire initial claim was made and it said, hey, if you run these 10,000 transactions, the end result is X. Well, and then I come along and I say, wait, but X is wrong. So you can come back and say, well, if I ran half of those transactions, the result would be Y. Now, at that point, either the first half of the transactions is wrong, in which case I know the error was introduced somewhere in there, or it's correct, in which case the second half must be wrong if the whole thing was wrong. And so we continue along this process, down and down, until we get down to not a single transaction, but actually a single step of execution, which is then replayed on Ethereum. And so we've narrowed down this dispute over huge amounts of gas and huge amounts of computation into a very, very limited, small piece that has to be verified by Ethereum. And with the guarantee, basically, that if you're honest, you can engage in this process and you know you'll win. And this is why, basically, and this is how we achieve this property, that any honest validator can make sure that the chain executes correctly. And interactive proving is awesome. There are kind of various ways you can go about this process of kind of in a rollup, knowing that the state transition is correct. There's a lot of awesome stuff going on in the zk realm. There are various ideas in the optimistic realm, and my personal favorite, I'm a little biased here, but my personal favorite is the way we do things, which is interactive proving. It's hyper efficient in the optimistic case. I can just put down a single tiny little claim about vast amounts of computation, and I can success, and then if there's no challenge, it will just kind of be accepted by everyone. And so I can kind of bypass actually making claims about about each individual transaction by just making one big claim. It's also minimal in the cost of disputes in L1. So it's kind of super optimized in the happy case. It's also super optimized in the unhappy case, where we minimize how much work Ethereum has to do in order to verify whether there was fraud or not by cutting down in these simple transactions into a smaller and smaller segment that's been challenged, and then resolving just this relatively simple execution on chain. And further from that, the fact that we just need to run a single step means that the actual complexity of the contracts and transactions in layer 2 doesn't get affected by the fraud process at all. So essentially, we could have transactions. There are other reasons why you wouldn't want to have transactions that kind of use 100 billion gas or a contract that's a gigabyte in size. Don't get me wrong; these are not unlimited, but there aren't restrictions in place from the fraud proof mechanism, which means we can escape out of the limitations that are in place in Ethereum and have the L2 actually have kind of higher capacity for gas in a single transaction, higher capacity for the size of contracts than Ethereum has. And for anybody who's developed on Ethereum for a while, you almost certainly have hit that really annoying thing in Solidity where your contract exceeds the size limit. And kind of having L2 make that situation better is a pretty big win. And finally, implementation and fraud proof flexibility. This is kind of a bit more of a technical point, but essentially the Arbitrum chain is kind of secured by Ethereum, but it can make its own choices because we only need to be able to emulate a single step of execution. We can change around opcodes as much as we want. We can kind of alter the virtual machine. And so basically this means that there's a lot of experimentation that can be done. With kind of the initial version of Arbitrum mainnet, we're kind of staying pretty close to Ethereum because kind of those are the tried and true design choices that have done us well for a lot of years now. But the capability is there to really experiment, which is awesome. So now I want to kind of shift gears a little bit. We've talked about the rollup and how it's secure, but what does this actually look like to a user? And so we've been kind of like looking at basically what happens at layer 1 on Ethereum, but now we're going to talk a little bit more about what the layer 2 chain actually is. And so the typical experience is kind of from a user perspective, feels very much like Ethereum or like a regular sidechain where there's a network you connect to, you send transactions, and you get receipts back, and you deploy contracts, and you interact with those contracts. It all just kind of feels like Ethereum, which is pretty cool because behind the scenes, there's a lot of magic going on. The fact that you can deploy your contracts as the exact same bytecode as you would deploy to Ethereum deployed on Arbitrum, which means that you can use whatever version of Solidity you want, whatever version of Viper you want, any kind of weird EVM language I've never even heard of. the fact that like Ethereum tooling just works is pretty magic. And the way we achieve that is over here on the right side. And I'm going to talk about that a little bit more later. But it's this magic layer called ArbOS, which is kind of the L2 operating system or runtime, and actually does sort of the translation and does all of the bookkeeping for the layer 2 chain. And so you can kind of think of it as doing a lot of the things that an Ethereum node does, except essentially kind of trustlessly as part of the L2 chain itself, as opposed to being part of the client. And so that user experience, and this is really just reiterating what I was saying. We have the standard endpoint, which means the chain is compatible out of the box with MetaMask, with Hardhat, with whatever kind of your kind of the tooling is that you're used to. And we're kind of working really hard on kind of expanding out and supporting as much Ethereum tooling as we possibly can, because one of the key things about actually successfully getting people into the L2 ecosystem is not forcing them to learn a lot of new stuff. People are busy. People are busy and they've already spent a lot of time learning Ethereum tooling. There's already been a huge amount of effort to improve the Ethereum ecosystem and tooling. And we want to take advantage of that. And so that's kind of a really big deal, I think. And so the user experience then is you have a node. Maybe it's, a hosted node, maybe it's a node that you're running on your own computer. Either way, nodes always know the correct state. And so kind of there was this whole validator protocol I was talking about before. You don't really need to worry too much about that because the state is deterministic from the inputs. So your node, without even paying much attention to what the validators are doing, will know the correct state. And so you can just kind of ignore any sort of fraud or challenges in the normal case because you know what the correct state is. And there's no need to kind of introduce any trust into the validators here. And you can use all of the same languages and tooling you're used to. And so just to give a little more detail into the thing I mentioned earlier, the secret sauce, ArbOS. So ArbOS is the L2 operating system of Arbitrum. It provides a lot of really cool features, and we're going to be adding a lot more over time. But just off the bat, this is where we get our generalized and safe L2 to L1 and L1 to L2 transaction bridging. Which is also kind of lets you really easily and kind of in a really simple way port tokens between the two chains. We get cool things like transaction batching and the ability to handle BLS signatures at the chain level rather than having to use smart contracts, which is going to be really, really valuable as time goes on for saving costs because it lets you cut down on that precious call data because it lets you cut down on how much resources are needed on Ethereum in order to put your transaction into the rollup. ArbOS is where we get our EVM compatibility at the bytecode level. There's this really cool thing, which is basically when you deploy your contract, it's actually compiled or transpiled, I should say, because it's very simple, into kind of your L2 contracts. And so basically that's done in the L2 system, which means that you don't need to worry about it on your computer. It'll happen automatically and it'll happen securely, because it happens kind of as part of the core system rather than sort of an auxiliary tool that you have to run. And this whole system is easily extensible with new transaction types and features. And so kind of over time, all of the cool ideas that are developed in the context of Ethereum and in the context of Arbitrum as time goes on will be really easy to incorporate into the system in kind of a secure and kind of pretty rapid way. And so that kind of is going to really spur a lot of exciting development, which I can't wait to see. All right, so I think now we've been through enough of the system that we can kind of put these various parts back together. And so if you look at this diagram, I've probably touched on really all the components here, but if you squint a little and zoom in, you'll see a diagram with a bit more information in it. So this is kind of a little bit more realistic. That first diagram is a bit of a simplification. But what this looks like is this is basically the fusion of the L1 system that I talked about and the L2 system I talked about, where we have what's going on kind of off-chain. And here kind of off-chain really means like just the actual hardware and software that people are running. We have the layer 1 system running on Ethereum, which is the rollup protocol, which is the inbox. That's where the validators are staking and getting into challenges or getting slashed. And then we have kind of ArbOS and kind of the EVM compatibility layer where your smart contracts are being deployed to. And this is kind of how all the different parts come together in a really neat way. So yeah, so kind of little bit of background, basically just on who we are. As I said, my name's Harry. Also, I have two co-founders at Off-Chain Labs, Ed and Steven. All of us will be around on Discord, both the ETH Global Discord as well as the Arbitrum Discord, and would love to talk about any cool, scaling projects, Ethereum stuff, basically anything. We've been in this space for a lot of years now. Ed is a professor, well, has been at the full time at the company for a while, but is a Princeton professor who wrote, and along with Steven, wrote the textbook on blockchains a lot of years ago. And we started out with Arbitrum as a research paper, actually, that we wrote together before deciding that, hey, this could actually be practical. And spinning it out into a real applied project, which is how we got to where we are today, on the verge of actually kind of having something ready to scale Ethereum and solve a lot of the scaling problems that it's been having. So at the hackathon, we have a lot of cool prizes. This is and I think, some of this, if you saw the video earlier, you're going to hear some repetition because this is a slide I used in the promo video. But we have 4 different prizes totaling $12,000, which we're really excited for teams to win. That kind of bridge a lot of different areas related to scalability. Some for just using Arbitrum and deploying contracts and kind of taking advantage of the scaling it provides. Some more wonky stuff like kind of working specifically towards cross-chain interoperability or kind of integrating with the layer 1 protocol in interesting ways. And kind of one that I'm particularly excited about is improving tooling. So like, for example, and this one is kind of near and dear to my heart. There's a lot of work to do in helping kind of understand and display what it means to have multiple chains. People are kind of, there's already some work to this effect, but still most of the kind of wallets and kind of explorers and all of the kind of software around blockchains is really focused on kind of a particular chain. Whereas now we're really migrating over to this world where there's kind of, there's the Ethereum chain, there's the Arbitrum chain, there's the optimistic Ethereum chain, there's the zkSync chain, there's the Loopring chain, there's the Matic chain, there's so many, and the tooling really needs to catch up. And so kind of that's one area that we're really excited about in particular. And so yeah, just in terms of kind of like next steps, and if you found this interesting, kind of what you should do next. So Fred Lax and Daniel Goldman are giving a workshop on kind of the practical matter of building on Arbitrum and kind of what there is to know. It's going to be pretty short because it's pretty easy, but there is some pretty cool stuff in there. So you should get excited for that, and that's on Monday. Also, we're on the ETH Global Discord, but probably a lot more of the team, and it will be a little more responsive on the Off-Chain Labs Discord. So just if you visit arbitrum.io, you'll get the link to our Discord. It's worth joining. It's a lot of fun. And then there's some pretty nice developer documentation at developer.offchainlabs.com. And in particular, there's a section called Inside Arbitrum, which hence where I got the title of this talk from, which goes into kind of way more detail than you could possibly imagine into kind of all of the different parts of the system. This talk was basically kind of a sneak peek at some of the content in there. And so kind of if you're really interested in kind of rollups and Arbitrum and how all of this stuff works, I would highly recommend going and checking that out. So yeah, I think I'm coming in a little under time, but I think I basically covered it. So thanks for listening, and excited for the panel.
Thanks so much, Harry. That was super awesome. And I really like the takeaway on just there is a big focus on tooling that's needed. So I really like that you spent a lot of time addressing that and how you want to make sure that everybody is able to do this transition as smoothly as possible. So thanks for bringing that to the attention. That's kind of also how we look at it for all of our events. With that said, those were some amazing points that both Carl, Patrick, and Harry brought up. So what I'd like to do is just ask everybody to turn their video on, and we'll have Patrick do a quick panel on, or just moderate a quick Q&A session with Ari and Carl. So I'll let Patrick take it from here, and we have 15 minutes for questions. We did get a lot of questions on the chat, so we'll be relaying them here directly. And then I'm sure Patrick also has a handful of questions himself, so I'll let him take it from here.
Yeah, thank you very much for that, Kartik. So this is the first question that I basically got from the chat. So the question was more to do with the EVM, so the EVM on layer 1, how interoperable will it be with the EVM on layer 2? And this also sort of leads to my next question that's around this, because you both mentioned that your rollups are good for experimenting. So how easy is it to introduce a new EVM chains on your rollup? Let's say we wanted to experiment with EIP 3074. Could that be implemented on your rollup before it hits main chain Ethereum? So I'll let one of you guys go first. Maybe Carl, I guess, because he looks really excited, full of energy.
that may always be the case, though. Yes, definitely. You can 100% experiment with various EIP changes. And there are specifically certain things that are easier to experiment than others. But for the most part, yeah.
Yeah. What about you, Harry?
Yeah, I think I could basically second what Carl said. I mean, that's like one of the like cooler things about rollups is basically kind of like how much it opens up the design space. Now, the caveat to that is like once there's like launched rollup chains that have a lot of money and users, we're probably not going to want to get like too crazy. And we're going to want to like run test nets and kind of innovate, reasonably slowly over time. But essentially kind of, spinning up kind of your own rollup chain, essentially, that isn't kind of part of the main one and doesn't like synchronously communicate with the main one, but like is sort of your test bed environment is like, something that's like really awesome. So I would, for instance, like really expect over like a couple of years from now, when a new kind of when a new, EIP is proposed, there'll be like a rollup chain that's launched on mainnet, with the full economics that's kind of running with that EIP added in, so that kind of rather than just having like a separate test net, we can get like a much more kind of authentic test of the new tech.
Awesome. So that also leads to my next question on the EVM. So how vanilla will your EVM be when you launch your initial rollup? Are you going to have any like custom features in your EVM, or is it going to be complete vanilla upon launch? So are you going to experiment right away?
Yeah. I
go ahead, Aaron.
Sure. Yeah. Yeah. So ours is gonna be kind of mostly vanilla, but with a few exceptions. Kind of the two biggest ones that come to mind is with kind of supporting alternate transaction formats. And so the biggest one there is with support for BLS, which is kind of awesome, efficient signatures that are going to be able to cut down the call data usage of rollups even more. Another area where kind of Arbitrum, we've done a fair amount of work is on the kind of gas pricing and economics. It turns out that kind of for a rollup chain, there's a kind of a fairly kind of different set of concerns compared to Ethereum's L1 in sort of how the economics of the chain work. And so we've kind of done a lot of work there, like very inspired by EIP 1559 and kind of trying to achieve sort of the UX improvements that are kind of given by that EIP. So yeah, like kind of around the edges, basically sort of trying to innovate, but like with the core model essentially as similar as possible, so that we're not like, the thing we don't want to do is confuse people too much or cause things that would work on Ethereum to break. And so kind of those are the areas we're staying away from, and the areas kind of that don't have those risks are the areas we're trying to push the envelope a little bit.
So I can also second a bunch of that. However, one thing I will get into specifically is like what it really means, like what have we done with the EVM, right? We are literally running an EVM in Geth. And what we're doing is we're actually intercepting the calls to a smart contract in that EVM and then hooking that, like kind of creating a precompile for that contract and hooking into the Geth's internal storage. So when you say like, are you making modifications to the EVM? Like the only modifications that we are making to the EVM are actually how the smart contracts are structured, but we're using the EVM, vanilla EVM software to support those features. So it's this very interesting, like, you know, we are as tightly integrated and kind of along for the ride in that sense as, you know, I can imagine.
You actually just reminded me, I mean, Optimism definitely are dealing with the EVM because you, I think at one point crashed Go Ethereum is also impacted Infura.
Oh, yeah, and by the way, the reason why we did that, the reason why we found that vulnerability was because we are working with the EVM at such a low and insane level that we are using precompiles that just don't make sense in normal contexts. There is the identity precompile where you call it and it just returns what you called. And no one uses that. Like, that's some crazy stuff, but we had to use it for part of our software. And it's like, oh, of course, there's a bug in that precompile. By the way, if you want to find a hard fork vulnerability, look at the precompiles.
Exciting. So I'm going to move on to the next question then. This is also from the chat. So one thing I mentioned in my talk was, like, you know, withdrawal integrity. How do we guarantee someone can withdraw their funds, you know, if the sequencer disappears? And their question was, what's that interaction like going from an L2 transaction to the L1 transaction? So do you guys just want to give us an overview of what it's like on your systems?
Sure. So an L2 transaction is, you know, you're sending directly to the sequencer, but an L1 transaction is essentially an L1 to L2 message. And now notably that L1 to L2 message can be anything. It can be, for instance, a fully signed valid L2 transaction. And so everyone on L2 has a kind of smart wallet. It is implemented as a contract wallet, which actually, you know, you can then upgrade to, you know, whatever you really want. But the kind of general sense is you would essentially be sending a meta transaction-esque thing, which is a message into L2 that is eventually, you know, run in the L2 system, of course, with higher latency.
Mm-hmm. Harry, do you want to give us an overview as well?
Yeah. And I think, you know, for Arbitrum, the story is relatively similar. There's some differences there in that, like, our kind of L2 accounts are kind of relatively are basic EOAs. So basic kind of like we don't have like kind of smart contract wallets by default. We just have sort of regular accounts. And so for kind of in our system, basically that L1 to L2 transaction just basically sort of submits a regular transaction from that user. But you know, these are kind of like technical details. So I think sort of in practice that'll end up feeling pretty much the same.
Awesome. Well, also what I want to ask is, you know, we're at a hackathon full of newbies. You're really excited to get involved with this. Can you give like a 1 minute overview of what it's like to get started on your layer 2 system? What would the developer experience be like? Anyone can go. Maybe Carl, do you want to go first?
Okay. So the developer experience, we are trying to keep it as minimal as possible. So we have a tutorial that you can check out on our GitHub, like Optimism tutorial. And essentially you take for instance, a hard hat project and you add a couple lines in and then you run your tests and it all passes. And so that is very similar. The general format is add the optimistic Ethereum network to your MetaMask, and then you can start interacting with it and sending transactions, deploying contracts, whatever you want. So it's just essentially just think of it as a change to your provider. There are a few oddities around fee payment. You know, there's some caveats here and there, but that's at least where we are headed.
Yeah, for us, basically, and I think I showed on one of my slides, there's a kind of a little landing page, testnet.arbitrum.io. Really, all it is kind of if you have a truffle project, a hard hat project, where you fill in your provider. There's an Arbitrum network. There's a URL. There's a chain ID. It's a public test net, and so you can just kind of take your existing project, no need to do anything, and deploy it. There are a couple of corner cases and a couple edges you could hit, and we have kind of a little more. There's a little more detail in there, but if you try that out, chances are pretty good that it'll just work. So
awesome. So the next question is also from the chat, and I guess there's two variants of this. The one in the chat was, why do we have to use Ethereum for data availability? Can we use IPFS, Filecoin, etc.? So what do you guys think about that? Are we Ethereum maxis here?
Definitely. Sorry.
Oh no, go for it.
You go, Carl. You go. Yeah.
Okay. No Ethereum maxis here. We're blockchain maxis. But anyway, the thing that I was talking about in my presentation was availability is like the pipes, right? It's not the storage. So IPFS just doesn't really do the same thing as data availability that we're coming to consensus on. The reason why availability on Ethereum is really nice is because it's really confusing for developers to have tons of different security models for your different information, right? If I'm using the trusted internet, it's just easier for my brain if it's all trusted at the same level or a similar level. There will be gradients. I'm not saying there won't be, but generally speaking, for many applications of wide variety, it's just going to be nice to have a homogeneous trust model.
Awesome. Well, what about yourself, Harry?
Yeah, no, I mean, that's, I think, it's interesting how this will expand over time. Like, I think, Ethereum is the place to be right now, and it's the place to be hopefully forever. I think there is some kind of interesting work going on here. I mean, state channels, for instance, have their own solution to data availability, which is just the people involved agree that it's available. There's also there's all sorts of, I'm sure there'll be some discussion, I think a little later today, about the cool stuff that some of the ZK rollups teams are doing. There's like some terms bouncing around, ZK Porter, Volition. There's a lot of really cool stuff here. So there's a lot of ongoing work. Like, I totally agree with Carl that I think that simplicity here is king in a lot of ways. But there are a lot of really cool kind of research directions here that do the same thing as rollups, which are modify the security model of Ethereum a little, but probably within enough constraints that the systems are still sort of reasonable to use. So yeah, we'll see where we are in 5 years.
Awesome. So I'm going to ask two more questions. One's again to do with the data availability. So as we know, and you've both alluded to this in your presentation, the real bottleneck to these rollups is Ethereum's bandwidth, call data, how much data can you send, etc. And so that's going to be the main gas consumption for the layer one. So I'd actually I don't know if you have any numbers handy, you might not have numbers handy, but do you have any example applications that use your service and you're oh, they were using 5 million gas on Ethereum, but now they're using X gas on the rollup? How good was that improvement? And if you don't have numbers, it's fine. It's just interested. Do you want to go first, Harry, I guess?
Yeah. I mean, so I think, we've had a bunch of different applications deploy on our testnet. Normally, the way we figure this is we just sort of compare we have our block explorer just kind of displays the L1 costs associated with the transactions, and we compare it to what it would have been or what it was if they're also already launched on layer one. So I think we've seen kind of anywhere between I think in the worst case, a 10 or 20x, in the best case 500x improvement. I think our go-to a while ago, I think one of the first thing we did on kind of the Arbitrum testnet ourselves when we got it working, just because it's so core to Ethereum, was we tried out launching Uniswap v2, and I think and if I remember correctly, the transactions there were coming in at around 1900 gas per transaction. Assuming kind of the batches of transactions were of a sufficient size, which there's this interesting thing, which is there's a fixed cost for the batch, and then there's the variable cost per transaction. But one of the really cool things that optimistic rollups have is the batches don't need to be that big. And so for Arbitrum, I think it's kind of 50,000 gas fixed cost, and then we divide that over all the transactions in the batch. So you can kind of still be very cheap, even with not very many transactions.
Cool. Go ahead, Carl.
Very similar, but the maybe one thing I'll shout out is Synthetix in particular has a bunch of transactions that are like 2 million gas on L1. And, you know, we reduced that less than, you know, like 5,000 gas on L2. Of course, you know, caveats, batch sizes, etc. So like that is, some applications are going to be crazy gas savings. Now, just one extra note is that the more like people use the system, the more our compression techniques and like the more mature we get, we can actually offload more of that availability off chain, and we can improve those performance characteristics even more. So it's pretty cool.
Awesome, exciting. So I hope all the devs out there realize that you're going to get like 100x savings if you use optimistic rollups. So my final question is a very quick one. You know, as I think Carl alluded this in his presentation, we're one big community, we're all BFFs. You know, you're building competing products, but you know what, you're all like, you know, good community. So my question is, what's your favorite thing about the other project? You know, what gets you excited for it? That's a nice way to end.
Nice. Who gets to go first?
Whoever wants to go first. I'll give you a second to think about it if you want.
I mean, so I have a joke answer and a real answer. My joke answer is, you guys have the best memes. Like seriously, like your meme game is like so clutch. Like, you know,
background.
You know, I got to give it to you there. No, and you know, and the more serious answer is like, you know, the way that kind of be able to like, you know, use Geth is really cool. And like kind of reuse those existing components is you know, super cool.
My answer is, since I learned about Arbitrum, okay, the first thing was I was like, okay, Ben, tell me how Arbitrum works. It is like, I do not know, but it sounds crazy cool. Like, how do you have a virtual machine that like traverses a tree? Literally, it traverses a tree. That is legitimately like the coolest mind expanding thing. And y'all are always at the kind of forefront of just, you know, mind expanding kind of designs and design spaces. So it has been really inspiring to like understand all of the trade-off spaces, or all of the kind of trade-offs that y'all have made. And also I mean, man, I just can't get over the fact that y'all's VM just like goes up a tree and like goes down. And it's like, yeah, wow.
I feel like one of the kind of beautiful things has been like that, like both projects are just making each other better. Like I know that, like, you know, for instance, like kind of the EVM compatibility a year ago, we hadn't focused anywhere near as much. And like kind of seeing kind of where, you know, with like the work you were doing, and I think, you know, in a lot of ways inspired us in terms of like pushing for that sort of like, let's make this look and feel as much like Ethereum as possible, which is like clearly, you know, in hindsight, the right thing to do. And it seems like kind of, you know, one of the awesome things about optimistic rollups in general.
Awesome. So I'm going to finish there, guys, just for the time. So I'll hand it back to Kartik. Thank you very much for answering our questions.
Harry, Carl, thank you so much for that. And Patrick, thanks so much for asking that question and ending on a really positive and wonderful note. So thanks again. And now we are ready to move on to our next talk for the summit. So the next talk I want to introduce is by Chadwick Strange from Scale. And Chadwick will be talking about how Ethereum native app specific blockchains are made and just the internals of how Scale works. So without further ado, I'd like to welcome him on stage, and I'll let him kick us off with the presentation.
Hey everyone, good to be here. Chadwick Strange, VP of Product at Scale. Let me get this going. Yeah, so I'm really thrilled to be here today to talk to you about building Ethereum native app-specific blockchains. Again, my name is Chadwick Strange, VP of Product at Scale Labs. And just to set up the stage of everything, I know a lot of projects and teams are being formed and everyone's watching in. You know, as I talk and as I show slides, feel free to go to our GitHub at github.com/Scale Network. And then during the talk or after, you can hop onto our Discord, scale.chat, that will throw you into our core team community Discord. without further ado, let's get started. So just as an intro, Scale Network, our mission is to empower Ethereum dApps and dApp developers to scale smart contracts in a secure, reliable, cost-effective manner. Think of this as like the Web3 cloud. You can use all the Ethereum tooling, dev tooling that you normally use, Truffle, Web3, Ethers, Rebix. Scale Network's compatible with ERC20, ERC721 token standards. All the Ethereum wallets work out of the box. So just wanted to set that as a stage. And I want to go into deeper about some unique properties of Scale Network. Scale is an ETH native multi-chain network. And I want to break this down. Like, what is ETH native? What is multi-chain? To all of you, this might be new terms. This is something that the core team and the community has been iterating and developing over the many years that we've been developing the Scale Network. So let's put some context in here. So Scale Network, what is ETH native? ETH native is, my term is it's built with Ethereum technology. Scale, during its early inception, we took some of Ethereum technology like the Aleph client, which is a C++ client, and we tweaked it, made some bells and whistles, some changes to it, and it's now known as Scale D. It's sort of our Scale EVM Ethereum client that we use on all of our nodes. So ETH native is using the compositions of Ethereum technology, and then using part of that ecosystem. ETH native is also transacting with Ethereum. This separates it from other L1s that are in completely other different ecosystems. ETH native is transacting, coordinating, interacting with Ethereum mainnet. ETH native is also having security that's based on the Ethereum network. A security model where you're leveraging proof of work, you're using staking, you're using all the security guarantees of the Ethereum miner community at large, the Ethereum nodes, the network itself, to provide security or leverage that security for additional security. And you're not putting that security in something else or some separate technology or some separate black box where you don't know quite what's going on there. You're leveraging the security that everyone knows and loves about Ethereum. And ETH native is coordinating incentives, coordinating economic behaviors to be sure that all actors of an ecosystem are acting within the best interest of the community at large, and using Ethereum technology, the network, those technologies, leveraging them to incentivize good behavior and to disincentivize malicious behavior. So why does ETH native matter? Well, we can look at the contrary to this. What is non-native? What is that? I mean, this would be other layer ones that have their whole sort of walled garden ecosystem, where they're not, they have a whole different security mechanism, a whole different technology, and they might build some sort of bridge to Ethereum, but in that way, they're not ETH native. They have a bridge that supports that, but majority of their technology is a totally separate walled garden. And there might be interoperability or standard issues. Different L1 or a different ecosystem that's not ETH native might have different token standards, different cryptography standards. And so that interoperability or those standardization issues might go into conflict with, building with the Ethereum community. And there might be holdup and rent seeking. Another layer one might have a different community or different dynamics. They might take away transactions or scaling from the Ethereum at large and then put it in their network. So in that way, they have their own walled garden where they're not driving back value to the Ethereum network itself. And the other layer one, the non-native layer one, might have different governance issues. They might have different incentives to change things at will. So Ethereum community has been developing over a very long time. So ETH native kind of is contrary to that. There's a strong community sense. There's a strong governance sense. There's a strong standardization process that supports that sort of ETH native technology and that support. So we covered ETH native. I'm going to jump over to what a multi-chain network is. And a multi-chain network is not a side chain. I view as a sidechain as a network that is existing as one chain. Scale network is many, many chains. Blockchains on demand. So the Scale network is comprised of as of today, over 150 nodes. Each of those nodes are supporting all the scaling infrastructure. They're supporting multiple chains that can be selected at random out of the network. So in that way, Scale network can be hundreds of chains that are selected at random to support a particular dApp. And so as a dApp developer or any community that's using a Scale chain, your Scale chain, which is one out of many that the Scale network supports, is attributed to you and to your dApp and to your community. And you can set up the specifics and sort of dial that in to support your infrastructure. So your Scale chain, you have your own endpoint, you have fast block times, high TPS, full state smart contracts, decentralized storage. You can use an e-Scale bridge called IMA. You can deploy your own bridge. That is yours, that sort of component out of the network, out of the many multi-chains that Scale network supports. And why does multi-chain network matter? I kind of touched on this a little bit, but I'll go down into a little bit more detail. Your chain can be dApp specific. Similar to Web 2.0, you need scaling infrastructure. You go to different cloud providers, select your instance size, you'd select your elastic IPs, you select your scaling infrastructure, your S3 buckets and whatnot. You build that infrastructure, that scaling infrastructure, to the product that you're building and the users who are using your product. Similar to Web3, Scale network provides dApp specific chains that can be tailored to your or your community's specific decentralized application and to the users who use that. And I'll go into more detail. Multi-block or multi-chain networks also matter because of the pooled security model, where all the nodes collectively have stake and you're building on that collective pooled security of stake and selecting a chain that can be allocated to your dApp out of the many chains that are supported by this pooled security of stake. So into dialing it a little bit further, what is dApp specific? What is a dApp specific chain? So again, Scale network, out of 150 nodes of the network, that supports hundreds of different Scale chains, independent Scale chains operating and running. These can be dialed in and customized for a particular dApp. For example, at the very top, we have one sort of proxy as a Scale chain, this sort of oblong circle. It could be a different size Scale chain. We have three sizes: small, medium, and large. They have each size attributes to the amount of CPU, memory, and storage resources that are provided, similar to a T2 medium, XL large sort of AWS instance or other cloud instance. So a medium chain has medium CPU, memory, storage resources. That chain can be customized to use and leverage the Scale ETH bridge, which is called the Interchain Messaging Agent, or IMA. And this Scale chain might be set up that the project or whatever dApp is running on that can continue to fund and operate and sort of change that medium chain. Separately, if another project might request a large Scale chain, so this is the highest amount of CPU, memory, and storage layer resources that a node can be provisioned for. And this large Scale chain might be customized to support multiple bridges. So maybe not just the Scale ETH bridge that comes pre-deployed to each Scale chain, but you might connect in other bridges like Connext, or maybe a customized bridge to provide whatever specifics that your dApp might need in order to talk to Ethereum or other networks and whatnot. And then similar to a large chain, if that dApp needs specific multiple bridges, maybe it wants to leverage some unique properties of file storage. So file storage is another feature that comes with each Scale chain. It's a decentralized storage layer that uses the storage layer resource out of the nodes. And as a dApp developer owning your large Scale chain, you can then upgrade or modify those pre-deployed file storage contracts to provide additional functionality or features that you might need specifically for your dApp. And then just a third example, maybe there's another medium chain or even a small chain, and maybe that project builds out a very custom bridge particular for their chain, and that the entire chain, the upgrade structure, the continued funding of that chain over the months that it's in operation is community funded. So there's no central party. Maybe it's a DAO that continues to agree on like, well, should we again lease this medium chain with a custom bridge for another 12 months out of the Scale network? Do we want to have the community to decide whether we should upgrade file storage and whatnot? So in this way, dApp-specific blockchains can be customized around different central or decentralized structures around the management or maintenance of that infrastructure layer. And it can run multiple bridges or be customized according to size or different attributes to support your specific dApp, because no dApp is the same. A gaming dApp will have different requirements than a dApp that's deploying NFTs to a dApp that might be a decentralized exchange. There's different security models, there's different storage requirements, there's different throughputs. So dApp specific allows you to dial that in and have the resources, the Web3 scalable resources that you need to power your dApp in your community. The pooled security through ETH native, this is the second component. Scale network again is over, as of today, over 150 nodes. When a dApp developer requests a scale chain, a subset of those nodes are randomly selected using all the logic that exists in Scale Manager contracts on Ethereum. So we're pooled, we're leveraging the Ethereum mainnet. We have the Scale network has all these smart contracts that define how to create a scale chain. It defines how to select at random these nodes out of the network. It defines how nodes can register with Scale Manager, the requirement of stake to put up to register and interact with the Scale network. So the pooled security will select those nodes at random. Those 16 nodes then basically form one of the many multi-chains that the Scale network supports. And from that pooled security, you get a random node selection. You get the pool out of all the collective stake out of that network. That stake is supporting your scale chain to run your dApp. Those nodes can be rotated consistently to avoid collusion over time. And you get access to consensus and full state smart contracts. So wrapping it back around, we've talked about ETH native, we've talked about multi-chain networks. So how is the Scale network ETH native? Well, we have a couple of things I've touched on before. The entirety of the Scale network is operated and managed and orchestrated by probably the largest smart contracts ever engineered that define, not DeFi, but define scalable infrastructure that exists on the Ethereum mainnet today. Scale Manager has different logic layers. For example, Scale Manager defines how validators register with the Scale network by interaction and transacting with those contracts in Ethereum mainnet. Node creation, so validators can register any number of nodes and then basically stake for each node to be registered on the Scale network. So all that logic is also defined in Scale Manager through transactions on Ethereum mainnet. All the delegation that's used to pool, to delegate into validators to supply the amount of stake required to operate a node on the network is done through Scale Manager and is secured and staked through Scale Manager contracts on Ethereum. Bounties that are paid out to the validators for for providing resources to the Scale network, that's also done on Scale Manager. Distributed key generation, we use threshold, the Scale network uses threshold cryptography to assert data availability and provide the security model for all the independent nodes of the network. That's all orchestrated and coordinated through the distributed key generation and scale verification contracts on mainnet. And then scale chain creation, rotation, and slashing, those are also defined in Scale Manager contracts. And so in that way, the network is leveraging and is fully ETH native in terms of the logic management and orchestration of the network itself. And then to provide the economic coordination mechanism, we have this network has the scale token on Ethereum. And this is a ERC 777 standard with a couple modifications to provide delegation and staking functionality. And that exists as a part of Scale Manager. And if you go to our GitHub, we have Scale Manager contracts and the scale token code all available there for anyone to inspect. And the third component is scale node. So as validators register node, they provide bare metal compute resources. And part of that is a containerized system. And the basic, the parent structure is a containerized system called scale admin, which is a Python script that contains all the logic that's used to register a node, used to allocate resources out of the node, CPU, memory, and storage resources for each DApp-specific scale chain that's requested. And what the scale admin does, this Python script, is it's calling and transacting all the time with the scale manager contracts on Ethereum mainnet. So when a node registers, scale admin runs a Python script to then tell scale manager, hey, I'm registering my, this node, I have this amount of stake, and it's doing all those transactions. It's driving all those transactions back to the Ethereum mainnet. And when a dApp developer requests a scale chain, scale admin is notified if that particular node is selected to participate in a scale chain. And then scale admin responds by allocating CPU, memory, and storage resources to provide that dApp specific chain, all those resources and all those configurations needed to scale that dApp. So Scale Network is ETH native from Scale Manager, the entire logic, the orchestration logic that exists on Ethereum mainnet, the Scale token itself, which provides the coordinating mechanism between dApp developers, validators, and nodes, and the Scale node, which is a containerized resource, a bare metal or some machine that contains a Python script that's always actively communicating, calling, and transacting with the Scale Manager contracts on Ethereum. So how does ETH native support the Scale network? So we have this notion that the Scale network is many nodes, many chains, multi-chains, and each chain can be specified to run a particular dApp. And again, there's other layer ones where all of that, the entire node registration architecture validators is a completely separate system. When you register a validator and register nodes, or you do stake, none of those transactions actually exist on Ethereum. They're a totally separate network. Scale is different. We're Scale Manager, all those transactions, the validator registration, node registration, those are all transactions on Ethereum, all through the Scale Manager system. So the entire network is orchestrated and managed through logic Scale Manager on Ethereum. So we have node orchestration, node rotation, ERC777 token is on Ethereum. All the staking, bounty, chain fees, inflation, and slashing all exist on Ethereum. And this is really important because it's a decentralized shared value capture. Scale's mission is to make sure Ethereum is successful in scaling and supporting all the amazing dApps and community that are building on top of Ethereum. And being ETH native means that means not to be competitive or to take transactions away from Ethereum, but it's to make Ethereum successful in driving transactions back to Ethereum while allowing Ethereum to scale. So as Scale Network grows and as the number of nodes and validators continue to grow over time, as people request scale chains, these are all transactions that are driving back to the Ethereum mainnet, back to the Ethereum miners, back to Ethereum nodes. All of the Scale Network scaling as that grows is relying more and more on very key secure transactions on Ethereum. So again, we're driving transactions and value back to Ethereum as Scale launches, because Scale Manager and all the orchestration is done by leveraging all the great technology that Ethereum has to offer. And I can give you a result summary. Scale Network has been around for a while. We've got some data points we'd like to share with you about this synergy and these results. Last October, we launched what's called the Kilimanjaro mainnet. We've always been sticking to this sort of mountain theme. We began with Fuji, we moved to Kilimanjaro. So Kilimanjaro was last October. Since October, the network has been operating without pause, without any crashes for over 190 days. As of today, we have over 45 validators, some of which are shown here on the right. Collectively, we have over 150 nodes and are continuing to grow, which supports over 400 dApp-specific chains. Again, as a multi-chain network, we support many different sizes of chains, small, medium, and large, and all those chains can be customized to be dApp specific to help the dApp and the community scale as best as possible. And we have, the network has over 2 billion staked. Again, this is staked through Scale Manager contracts on Ethereum. So that stake is secured by the Ethereum network using logic from Scale Manager on Ethereum. And this week, we're announcing the next network phase called Denali. And this kicked off a few days ago. It's a multi-day upgrade process where we've been upgrading Scale Manager system to the newest features to support live skill chains on mainnet. We've been iterating this over many test nets and had great participation and guidance from our validators to help refine scale chains. And so our Scale Manager contracts have been updated. And the next few days we'll be updating all the nodes on mainnet, all of our mainnet nodes to support scale chains live on mainnet. We're super excited about that. So back to ETH Global Hackathon. So as hackers, as developers, you can request your skill chains from the hackathon. So many of you might be wondering, well, what can you do with Scale? It's awesome that you're ETH native and you're multi-chain, there's dApp specific and pooled security model. Well, what does that give me? There's a couple buckets here. Scale can operate very fast, very fast finality. Having a dApp specific chain and leveraging all those resources from a node, and then having that orchestration and management from Scale Manager on mainnet, Scale chains have very fast finality. And what we've seen in the past is some interesting ideas. People have, with fast finality, you can really change. You have a step change function and how you can provide user experience. You can make Web3 apps feel more like Web2 apps with very fast finality. And instead of having to wait 10 minutes for a transaction confirmation or trying to mimic, that instant gratification of a transaction going through. We've seen some projects in the past build media paywalls using skill chains. So as soon as you submit your transaction, you can get access to all the rest of the media. So it feels just like a Web2 app, but using decentralization and security models of Web3 and authentications, and excuse the spelling error there. Having people get access to sites and not having to wait for many block confirmations to go through. No gas fees. So skill chains operate with no gas fees. There is gas on skill chains. It's used as a metering agent to prevent any rogue execution of EVM. But if you deploy your dApp on a skill chain, all the transactions on a skill chain are no gas fees at all. And we all know how expensive NFTs are to mint on mainnet. So let me just leave you with this. Like, imagine what new business models you can create if minting NFTs are cost nothing on a skill chain. I think there's some really interesting new business models that you can leverage with NFTs way beyond what we've seen on Ethereum mainnet and using scale technology to provide greater depth of resources from NFTs and whatnot. DAOs, with all the big spikes in gas prices over the last couple months, to make any vote on DAOs could easily cost a single actor maybe $50, 50 US dollar equivalents or more. Obviously, that tends to skew who is then incentivized to actually vote. If you have thousands of dollars locked up in a DAO, you'd be more attributed to vote on a proposal than someone that might be a smaller token holder. So imagine what you can do now with DAOs and voting and governance if you have a skill chain that operates with zero gas fees. And then complex EVM. We've seen a lot of interesting projects using machine learning and file storage to basically put more complex transactions than just like architecting token transfers. But now that there's zero gas fees on Scale, imagine all the new business models you can do if you're not constrained as a Solidity developer to think about how do you minimize gas reduction, but now what are the new things that you can do with not being restricted to minimize gas in your Solidity contracts. And the third bucket is high throughput. Scale chains, depending on the size, can support hundreds of transactions per second. And we've seen a lot of interest for people to do immersive gaming. Imagine hooking Unity up to your scale chain and adding all the movements or all the transactions of the game design on a skill chain itself. or even streaming, having streaming data being written right to a scale chain itself. So there's a lot of interesting business models that you can create with just these 3 buckets here. And there's plenty more. I mean, think of Scale Network, the Ethereum native and multi-chain network as an infrastructure that you can build on top of. And there's many more things just beyond these 3 buckets that I think you can iterate with. So I hope this is inspiring for you all. I think hopefully this is generating some interesting ideas. So again, to wrap up, we've covered how Scale Network is Ethereum native being leveraging all the great that Ethereum mainnet and technology provides, and a dApp specific or multi-chain network. Scale Network is not a side chain, it's a network of many chains, and each of those chains can be customized to support a particular dApp or an infrastructure community. So thank you all. I know you've been watching lots of these videos probably today. So if you have any further questions, feel free to join our Discord or jump over to our GitHub if you want to inspect the Scale Manager contracts or see the technology of how we're leveraging Ethereum-based technology. And then again, you can go right to our documentation, scale.network/docs. And I think I'll stick around here. If there's any questions from the community, I'll just pause here as Kartik will maybe gather some questions.
Thank you so much. That was a really helpful presentation on understanding how everything is set up. Just in the interest of time, I just have a single question for you. How should dApp developers be thinking about liquidity fragmentation in this model? If they're all app specific, like what are the kind of the implications or side effects or just the considerations you have to keep in mind for liquidity in the protocols?
Sure. It all depends on the bridge that you wish to architect with. The Scale IMA bridge, you can build sort of liquidity protocols on top of that. But again, you can leverage any other bridge that you want. So you can customize how you're thinking about, messaging from a Scale chain back to the mainnet. Again, a Scale chain is 16 different independent nodes that are operating all independently. And each of those nodes are looking for messages on mainnet, and then each of those nodes are independently sending transactions back to mainnet to support that bridge model. At least that's the Scale native bridge. But again, you can use any bridge or any other sort of liquidity design to bridge from a Scale chain to Ethereum mainnet.
Awesome. Well, thank you so much again, Chadwick, and we'll all see you on the Discord and over the next few weeks as we help out with the rest of the hacks. So,
thank you, Karthik. Cheers.
And with that, we are ready for our next talk, and I'm super excited for this one. Here, we're going to be learning about what the whole Layer 2 spectrum looks like, and especially kind of from the perspective of Polygon, previously known as Matic. And we have Sandeep and Mihalo telling us about this from their end. So both of them are here. I'll let them turn their videos on and kick us off, and I'll let them take over from here. So welcome, Sandeep, and welcome, Mihalo.
Thanks, Karthik. Thanks for having us here. And yeah, amazing work, as always by ETH Global. So yeah, so thanks for giving us this opportunity also to talk, in general about the Layer 2 spectrum. So we wanted to give, with this presentation, give a larger flavor of something that we, these days call as Ethereum scaling techniques, because there's a lot of information that gets missed in the semantics. So at the very last stage, I also asked my fellow co-founder Mihalo also. So hopefully we'll be able to give you a decent flavor of what all is there when we talk about Ethereum scaling techniques. So yeah, so we'll get started. I see I have screen sharing, right? So this is not a presentation or anything. I have basically a very, very simple few notes. Actually, you can say these are my notes basically I prepared just for this presentation. So, it's a very simple thing. So yeah. So, I mean, at a very, very, very simple level, the goal for all of us is Ethereum scaling, right? So at the end, there are various different kind of techniques, and I've also tried to create a, kind of a spectrum in some form where you can actually see what all mechanisms are possible, and then just kind of touch base more on this layer 2 semantics also, and what exactly constitutes a a layer 2, and then what might not be layer 2 but then still is working towards let's say Ethereum scaling technique, like we'll talk about some examples also on that sense. But first of all, I want to talk about two key things here, and let me see if I have that pointer here. So the two main thing, like when we let me start from here. So like when we talk about Ethereum scaling techniques, there can be a lot of different flavors. There can be side chains, which are standalone chains. There can be, a different flavor called commit chains, which commit some proofs to the main chain, Ethereum main chain. Then there are, Validum kind of solutions. And then there are kind of, layer 2, which can be pure layer 2 kind of solutions. So, so let's first start from what constitutes a layer 2, right? Where we can kind of see. So two key parameters over there are, first is like dispute resolution, where you can even also see my kind of cursor, and then the other thing is the data availability. So here we have mentioned that the data availability is basically whether it's an on-chain, whether it's an off-chain, and dispute resolution is what kind of dispute resolution mechanism you are using in case the off-chain. So let's take a step back. Like, what exactly is layer 2 or scaling technique? How we are trying to scale Ethereum? We are trying to do some of these computations off-chain, right? And then so that Ethereum main chain doesn't have to have so much of computation. It has limited kind of bandwidth in that sense. So how do we do that? So these two things: dispute resolution and data availability. So when you're doing this computation off-chain, you need to make sure that if it's a pure layer 2, which is completely dependent on Ethereum, you need to see that where exactly the whatever transactions are happening on the off-chain, where the data is being kept, and how the dispute resolution will happen in case the off-chain there is some sort of fraud or some sort of inconsistency in the in the off-chain kind of computation. So these two things get very important over there, that whether the data, whatever you are computing on the layer 2, whether the data is available on Ethereum, or the data is not available directly on Ethereum layer, and then how are you going to solve the dispute? So primarily we have two main categories over there. One is on-chain, as I said, on-chain and off-chain data, and then in dispute resolution, whether you have validity proofs or whether you have fraud proofs to kind of resolve your like dispute for let's say if there's a dispute arises, whether you're using fraud proof. That the difference between validity proof and fraud proof is, so fraud proof is, as you can already see by the name, that if some fraud has happened, then you can prove that fraud on chain of using a smart contract where you provide some sort of information or a challenge, and then it can be an interactive fraud proof, or it can be a single interaction fraud proof and things like that. And a validity proof is more like when somebody is trying to exit from the layer 2, and and then it checks for the validity of that exit right at the time of the exiting, right? So based on that, there are you can see there are primarily 3-4 kind of mechanisms. So you have like when you have the on-chain data, right? So, and you are using validity proof, they are called zk rollups. When you have on-chain data and you are using fraud proof for your dispute resolution, it is called optimistic rollups. Similarly, when you have off-chain data and it's a validity proof, then it is called validum. And like good example of validum can be for this thing, let's say Starkware's solution. Recently, Matter Labs also announced their zk porter, so I think that will also fall under the validum category, because they are talking about a data availability solution on the outside, and the dispute resolution will be on on Ethereum main chain. So these are this thing. And then when you have the off-chain data and then you are using fraud proof, that category of solution is called Plasma. And then you have some hybrid kind of categories also, like volition and optimistic volition. These are like, more evolving techniques. So largely this is the spectrum. Mihailo, if you want to add anything more to this particular this thing, or explain more about the hybrid side of things, feel free to chime in. Otherwise, I'll kind of move to the other kind of scaling technique.
Yeah, sure. Maybe just a few quick quick things to follow up on what you said. So yeah, basically it's like this is basically 2x2 metrics. And as Sandeep already says, we either have validity proofs or fraud proofs. Validity proofs are just proofs that are proving the validity of a whole batch of transactions. And we are also popularly calling this type of proofs zk proofs. So these are basically succinct cryptographic proofs that the whole batch of transactions is valid. And that validity proof is validated or processed on the Ethereum mainnet. And that is how actually these types of solutions are deriving security from Ethereum. So this is these sorts of proofs are by default non-interactive. On the other hand, we have fraud proofs, which are by default interactive or reactive, if you will. So what does that mean basically? For fraud proof based solutions, it is necessary that some party, ideally the owner or the end user, so if you have some funds that are in a solution that is based on fraud proofs, ideally you should be monitoring that particular chain or that particular scalability solution. And in case you notice some malicious activity, you should ideally, or some third party that you might then necessarily have to trust, should submit this challenge that Sandeep already mentioned. So that is kind of a major difference between validity proofs and fraud proofs. Validity proofs, there is no need for that sort of constant monitoring of the scaling solution, i.e. activity in it. So that is, I would say, one advantage of validity solutions. Unfortunately, the trade-off with validity solutions, there are multiple, I guess. All solutions, of course, have trade-offs, but basically, validity proofs tend to be larger in size, tend to be computationally intensive. It is kind of not trivial in terms of computational power to generate these zk proofs. The cryptography is still being improved. Many of these solutions, excluding probably only Starkware, because their validity proofs are based on Stark, which is a separate type of or separate flavor of cryptography that doesn't require that thing called trusted setup. All other solutions are actually requiring that trusted setup, and trusted setup is basically a ceremony where you generate some initial parameters that are required to actually later produce these validity proofs. And if at any point this ceremony, this trusted setup ceremony, is compromised, there can be basically any sort of exploit, and the entity that managed to compromise the trusted setup is able to basically steal users' funds and steal them in a very, if I may say, catastrophic way, because the Ethereum mainnet would just process that fraudulent validity proof without even being aware that it's fraudulent, because the setup is compromised. So yes, I mean, we could talk for hours basically about these solutions, but yeah, and maybe just on the other side, to cover the other side of the matrix is, and that is basically where the data is stored. If data is on chain, the situation is very clear in a sense that that's the highest level of guarantee that the data is available. But and that's why these solutions like optimistic rollups and zk rollups are so popular recently, because it is like a trivial way to solve data availability problem that is basically a pretty challenging problem. And however, the major downside of storing data on chain is that you're kind of continuing to clog the Ethereum mainnet. And we all know that the capacity of the mainnet is very, very limited. And that is why we should, I guess, as a community, be aware that optimistic rollups and zk rollups are very exciting solutions, but they are not, unfortunately, long-term solutions for Ethereum scalability, because again, we are storing all this data on the Ethereum mainnet, thus ensuring really high guarantees for data availability, the highest guarantees, but we are significantly limiting throughput of such solutions. So to put that into perspective, zk rollups and optimistic rollups can offer us maybe 2 orders of magnitude of scalability improvement, which is, I guess we will all agree, not that amazing. On the other hand, these off-chain data availability solutions don't have that trade-off, but it is, as I said, data availability is a challenging problem, and it is pretty hard to ensure or guarantee data availability if the data is off-chain. So there are basically many techniques that are being explored, but none of them, of course, can offer the guarantees of Ethereum. So with any scalability solution, basically the point is it's all about trade-offs.
Exactly. Yeah. So as you already saw that, you know, the on-chain, like with this kind of category on-chain data, it's really secure, and that's why we call them rollups, because even if, let's say, the layer 2 setup completely goes for a toss, you can actually, you know, roll that chain, like, you know, kind of create that chain back from the available data. So it's much more secure, you know, in terms of any fraudulent kind of events or fraud events. But then it has limitations because the data is on Ethereum main chain. Same, but with off-chain data, that trade-off is not there. But then if the data availability setup goes for a toss, then you know, it can be catastrophic, as Mihailo mentioned. Coming to the then other kind of solutions, how, like, you know, these, like, again, the pure layer 2, because see, again, on a higher level, if you see the trade-offs, at the end, you want Ethereum to safeguard the off-chain setup. So if you want Ethereum to safeguard the you know, layer 2 setup, then it is going to be costly. So and then, you know, there can be a lot of use cases where projects do not, or kind of the solutions that are being developed, they do not want let's say you know, that high level of security, and like, you know, for example, some sort of NFTs, like, you know, small ticket size NFTs, or you know, somebody is issuing, let's say, tickets of the events and things like that. So there are huge number of, you know, use cases wherein you might not need that level of security. Like Mihailo at times gives that example that, you know, do you want like a global level, like Ethereum main chain level security for a like a convenience stores transactions, right? So it might not be required. So the philosophy, and then, you know, like right now we are not speaking too much about the Polygon, but the idea of Polygon, or the core thesis of Polygon, revolves around this, that Ethereum is going to be the ultimate settlement layer. And then on top of it, you will have all of these different techniques, like layer 2 techniques. So, you know, for example, we are also working on some of these optimistic rollup, zk rollup related, you know, techniques. We have our Plasma, you know, solution, and like the proof of stake or the commit chain solution already live. We expect to, you know, kind of launch like more solutions, like which I'll talk about, like shared security solution for Ethereum, which, let's say, you know, the popular example for that is, let's say, Polkadot, where Polkadot is trying to create a shared security layer which will be a central chain, and around that you will have you know, parachains. So what we want to eventually build is, and in some form, the Matic POS, because it works using a validation layer. If you want to go deep into that, maybe we can talk offline, that, you know, there is a sort of a beacon chain, and on top of which you know, the Polygon commit chains work. So they can actually, the same security setup can spawn off multiple such chains, right? So that will kind of in some form might look like a sharded kind of architecture or like a Polkadot kind of architecture on top of Ethereum. So our approach is that what Polkadot is building as a separate ecosystem, we want to offer that opportunity for the Ethereum developers, wherein they can spawn off their like I don't want to call it para chains, but let's say standalone chains using shared security mechanisms run by the Polygon validators, and they all kind of center and connect into Ethereum. So that's one way. And then you can also have standalone chains. So standalone chains means, for example, standalone chains can be like there's like Lazy Ledger is one a very off example, although it's more into data availability. But then the examples of completely standalone chains can be, let's say XDAI chain, which is has standalone consensus. Everything is separate. Or you can think of like Cosmos like chains, which are completely standalone chains. So with Polygon, and we are coming out with something called Polygon SDK in some time, which will be like something like what you have Substrate in the Polkadot ecosystem, or Cosmos SDK in the Cosmos ecosystem, wherein you can spawn off these Ethereum compatible or EVM compatible chains, which can then work on top of Ethereum or readily connect to Ethereum. And then finally, I want to lastly, kind of show this spectrum that, this Ethereum scaling techniques, like whenever you are thinking about it, think of them as a larger kind of, larger like larger spectrum, wherein on the complete left side, you have a lot of side chains which are contributing back to Ethereum. Like, there is like XDAI is a very good example. That's a completely standalone chain, but they are hosting quite a lot of Ethereum applications. Like people are building a lot of casual as well as some DeFi applications, and DAOs have been built on XDAI. So they are also contributing back to the Ethereum ecosystem. Similarly, the next and when you see this line, basically consider the left extreme, the sidechain extreme, as completely standalone, which does not depend on Ethereum's security at all. And then the right extreme that you can see where I've posted as layer 2, this right extreme is completely secured by Ethereum. So, and then there are multiple, these things in between. So sidechain is on the left spectrum. Then you have, Polygon PSS's commit chain, where everything, the staking happens on Ethereum main chain, the slashing, the reward systems, everything is on Ethereum. And this is a very, very kind of coupled chain to Ethereum. And then, if let's say there is some fraud happens on the layer 2, if it is Plasma, then you can actually, exit your funds directly from the main chain. But even with the normal POS chain, if there is some fraud happens, at least you have the slashing available for the the validators which are validating the commit chain. So that's one layer above, let's say a normal sidechain, and that has some security benefits in that sense. But then one layer above that would be, let's say, Validum kind of solutions, which, as Mihailo was explaining, that the data is these are pure layer 2 solutions. But then if, let's say, the data is being stored off chain, there is certain level of trust assumption of the the off-chain data availability providers. If they go for a toss, then it can be catastrophic, as Mihailo mentioned. But as far as that layer is secured enough, you have a fair amount of security of the Ethereum main chain. And the last and the biggest, like the most secured solution by by Ethereum main chain are your pure layer 2 solutions, which include zk rollups, optimistic rollups, because they're both dispute resolution and the the data availability is directly on Ethereum main chain, so they are more secure. There are other solutions like State Channel and Plasma, which have been explored before. Plasma has, like, although everything works fine for transfers and all that, but then there are scenarios of, let's say, mass exit, wherein like some chain goes off and then everybody is trying to exit and Ethereum main chain gets clogged and all that. So those kind of scenarios are there, but then there are mitigation techniques with dynamic withdrawal periods and things like that. And with state channels, like, it is specific to, or kind of, people have, or the community has realized that they are useful for certain kind of mechanisms. If you want to see state channel based solutions, you might want to look at, let's say, Connext network, who's building now this layer 2 and layer 1 bridging solutions. So that also, those are also, interesting solutions. Yeah, and on somewhere between this layer, like I think before that, I think Scale Network was doing the presentation. So Scale Network will also lie somewhere here, because they are because I think their staking and everything also happens on Ethereum main chain, if I'm not wrong. So they will be somewhere between here. So that kind of, this gives you a rough kind of spectrum of the Ethereum scaling techniques. Hello, if you want to add anything, please feel free to add. Just before
yes, basically, as Sandeep said, Ethereum scaling is definitely a spectrum, and all these solutions have different trade-offs. And as Sandeep said, there is this left extreme side, which is completely standalone chains or solutions, and on the right side, just a small basically correction. Plasma should be in that section before the last one, because Plasma also has off-chain data availability. But basically, I will kindly ask you to forgive us. We were not really prepared, honestly, for this presentation, because we thought actually it's going to be a panel, believe it or not. So yeah, I think you can forgive us, because this was last minute kind of for us. Anyways, just to maybe add a few things regarding Polygon. We at Polygon are, first of all, in love with Ethereum, and in among other things, in Ethereum scaling ecosystem. It is amazing in a sense that many different independent teams with lots of brilliant people are working on these exciting solutions, and it is an organic ecosystem, and again, we really love it. But we believe, number one, that there needs to be some sort of structure to this creative chaos of Ethereum scaling ecosystem, and that's where we see the place for Polygon. Polygon is basically a project that aims to introduce structure in some way to this beautiful, organic, but somewhat chaotic ecosystem. Also, we believe that we are still very, very early in terms of infrastructure maturity. Ethereum as a project aims to kind of build alternative financial global ecosystem, and basically to change the way we collaborate, we work with each other, even the way we organize ourselves. And it is like a very, very transformative idea, and the infrastructure, building the infrastructure to actually achieve that idea, that will actually able to onboard billion plus people to actually use this system is going to take time. So we as a community, of course, and as human beings, we really want things to happen today if possible. But in our opinion, that is not going to be the case. Definitely, Ethereum is 5 years old, and Ethereum scaling solutions are generally like 3 years old. And to achieve this great vision, great dream of Ethereum that we all believe in, we believe it's definitely going to take years of hard work. So when people say this is the year of Ethereum scaling, we believe that is unfortunately definitely not realistic. And with that in mind, we just want to kind of facilitate further innovation on the Ethereum scaling front. And there is that famous misquote that says, "Let 1,000 flowers bloom." So that's what we want to do with Polygon. We want Polygon to be Ethereum scaling and infrastructure hub that will support innovation and help Ethereum go through this transitional phase of infrastructure maturing, if you will. And yes, basically it's kind of a overlay thesis on top of all these flavors that we try to introduce today. So basically, all of them have their trade-offs, all of them have their merit. So we just need to kind of facilitate and allow innovation to happen and see where that will kind of take us in the years to come.
Awesome. Thanks a lot, Mihailo. And I think we are already, we've exhausted our time.
So,
sorry, Karthik, for thanks a lot.
Yeah, no, Mihailo, Sandeep, thank you so much for that talk and a really good overview of what's happening. And I largely agree with everything you said. Mihailo, at the end, is a very contrarian opinion, but I sincerely hope you're wrong, because that's when the whole ecosystem gets to move forward really faster. So thanks again for the talk today. And
moving faster is not really always the best thing. As a human being,
Absolutely.
also like to move faster, but it's not really always the great way.
It's about the compounding, not the velocity. So
yes.
That's
but I totally hear you. Sure.
But yeah, with that, thank you so much. And for any future questions that anybody has about Polygon or questions related to using the Matic network for your hacks, you can ask this to the Matic team and Polygon team on Discord. And thanks again for the talk today. So with that, we are ready for our first break for the summits today. We'll be resuming in 15 minutes or 12 minutes, and I hope you get to enjoy the radio in the meantime, and we'll resume with our next talk in 12 minutes. So see everybody soon. All right. Well, hope everybody had a chance to quickly stretch or get something to eat or drink, and I hope you all enjoyed the lo-fi beats. We are ready to resume for the rest of the day. We have a few more talks going on, and with that, I want to actually welcome our new co-host who's going to be taking over for me for the next couple of hours. So Eva from the Graph Foundation is going to be here with us for a couple more talks, and she'll be the one entertaining us for the next few talks. So welcome, Eva, and we're excited to have you help us out for the summit, and super glad to have you here.
Awesome. Thank you so much, Kartik. Yeah, I'm excited to be here. It's kind of wild. It's almost exactly 2 years since, the depth of the bear market. We hosted a sort of Scaling Ethereum mini conference in Toronto, and most of the projects that are presenting here today have literally been grinding for years. So it's cool to see them, finally coming to fruition and their work in production. So yeah, ready to hear more, about what Bartek is working on with MakerDAO, and how they're thinking through, optimistic rollups.
Awesome. So, yeah, for a little bit more context, like 2 years ago, there was another event called Scaling Ethereum, which Jing and Eva organized, and there was a lot of stuff that we talked about from the technical side of things. And after all this time, we're all here. So I am personally excited to hear about some more bear market stories that you want to share with us as we go through the rest of the day, because there's so many lessons learned from how all this has kind of come from where it was to how where we are now. And kind of with that said, we are ready for our next talk. And I think you've already made the intro, but we have Bartek coming on to talk about withdrawal schemes from optimistic rollups. So Bartek, you are already here, and I'll ask you to turn on your video and kick us off with the talk.
All right, thank you very much, and welcome everybody. Let me just share the screen. It's all good. Okay, so let's just talk for the next 20 minutes about how we can actually enable fast withdrawals for the optimistic rollups. As you probably know, for the optimistic rollups, there's this big concern regarding the time that it actually takes to withdraw your funds. And this is one of the main concerns or critiques of this kind of a technique. And I'd like to actually dive a little bit deeper so that you have all a really good understanding, like what exactly is preventing users from withdrawing in a short time frame, and how can we actually alleviate this problem, and what are the proposed techniques and solutions to this. So a little disclaimer, whenever I talk about a layer 2, I actually mean a rollup, which is like a thing that you build on top of L1 and not a side chain. A little bit confused why some people, including Ethereum Foundation, they kind of call all the scalability techniques layer 2, but just to simplify for me, L2 is something that you build on top of L1, and it actually uses the security of L1. So a very quick summary. I mean, you probably must have heard already about the Optimism, and we've had some great talks. And yesterday there was a fantastic workshop from Ben and Calvin from Optimism team. I have to admit that they got the picture wrong because the L1 should be at the bottom, and you build above L1, you build L2, so L2 should be on the top. They got it backwards, but other than that, let's have a look quickly what happens when the end user submits a transaction to L2. So there's the sequencer, which is like a mining node on L2. And the end user, when they submit a transaction on L2, it gets bundled with a lot of other transactions. And the whole bundle is actually included in L1. It's sent simply to a smart contract on L1, which is called OVM for optimistic virtual machine canonical transaction chain. And you can see here in yellow that this is actually stored on L2, this transaction information. Now, after a while, the sequencer also appends what's called a state batch, which is literally a new state root for the whole bundle. So it says to us that if you were to execute all these transactions in the bundle, you'll end up with a state tree with that root. And anybody can check if this is indeed correct, right? So, so when the sequencer sends the state to L1, it doesn't send the full state because there will be like a massive amount of data. It only sends the state root. And as you can see, this is pretty cryptic, and we can kind of trust the sequencer that the state root is indeed correct. And this is, by the way, no different from L1. If you look at the Etherscan of any block, you'll see that there's also a state root of all the transactions, like here, 271 transactions included in this block. And we have to kind of assume that this is correct. There's this cool cryptoeconomic game played between Ethereum nodes. It just does not make sense for the nodes to publish not the correct state root. However, there is no proof, right? There is no like a zero knowledge proof or anything like that in the Ethereum L1 chain. So this state root, this is for L1, and this is a very similar technique that's used by the optimistic rollups. They just publish a state root of the L2. So what happens after 1 week? After 1 week, actually this state updates, it's just assumed to be correct. That means that since nobody was challenging the state root, the whole chain and the whole construction is assumed to work normally, and we kind of trust that this may never be changed. However, if during this week somebody made a valid claim that this state was actually wrong, then we delete it, right? So there's kind of a reorg happening here on L1 and of course on L2 as well. But it's important to know that the reorg only is happening at the state level here, but the original transaction is still here. And this is why we call it a canonical, right? Once this transaction is submitted to a chain, to L1, that cannot be deleted by anybody because it's just baked into L1, and there's no way, and this is guaranteed by a smart contract on L1, that this can never get deleted. So the key insight from all this really to enable fast withdrawals and all sorts of other cool features that you can build on top of Optimism is that once the transaction is submitted, it can never be deleted from the canonical chain. And whenever we see this transaction here, we can actually compute the state ourselves, right? We don't have to wait for the sequencer. I mean, anybody running a full node of L2 can look up at this transaction, can actually read the canonical transaction chain straight from L1, and they can compute the correct state for themselves. Very much like you would be doing running the full node on L1. So if you look up this transaction, you can check yourself whether this transaction will actually succeed. And if this is actually initiating a withdrawal transaction, you can actually see whether that will succeed or not, and whether the DAI should be sent to the user. Or you may get a revert, right? Like an insufficient balance or whatever. I mean, there can be a lot of reasons why this transaction can revert. But again, you can check it yourself. You don't have to wait for the sequencer. This is the clue for how you would like to approach the fast withdrawal scheme. So to go into a little bit more details, there's this mechanism in Optimism rollup that allows you to send messages from L1 to L2 and vice versa. They do it by having two different contracts, so one on L1, one on L2. And this guy on L1 that allows you to send a message to this contract, and this message will get relayed to L2. And vice versa. If you send the message to L2, it will get relayed all the way back to L1. And let's see exactly how it happens using the actual bridge, ERC20 bridge as an example. So We deploy 2 additional smart contracts. So these are ours, not from Optimism, right? On L1, we've got the L1 part of the bridge. On L2, we've got the L2 part of the bridge. And the user on L1 would initiate deposit. They would simply send a DAI to this smart contract, to this part of the bridge. This will actually lock this DAI inside the smart contract. It will invoke a method called send message, and this takes 2 arguments like the destination and the payload. So in this case, we want to send the message to the other side of the bridge, right? And the way it works, it actually inserts this transaction directly into the canonical transaction chain. It's kind of like almost like a backdoor, if you like, and you can use this backdoor for your transactions as well if you feel that the sequencer is like censoring you or whatever, but this backdoor is extremely important in the whole construction. So this backdoor is actually used by the cross-domain messenger, and once it's included, now this is canonical, right? This is as good as any transaction that was inserted by the sequencer inside the batch. Because of that, now the sequencer has no choice. It has to execute this transaction, because if it skipped, the state would be challenged, right? So now this is very canonical. So the sequencer has to execute it, and execution is very simple. It's just passing the data payload to whatever destination. So in our case, it was to the DAI bridge, and the method was complete deposit. The payload was 100. This actually informs the DAI bridge to mint the equivalent of DAI, the equivalent token for DAI on L2. And of course, this token will be sent to the user, right, on the L2 account. And I think it's important to know that this construction is 100% permissionless. Like, this bridge does not introduce any additional trust assumption. There is no operator, there is no multisig, there is like nothing, right? I mean, this just works, and it will always work. So let's have a look how it works the other way. It's a little bit more complicated. We initiate withdrawal on the L2 bridge. It actually burns the tokens on L2 and sends the message the other way, right? Sending the message the other way, this guy, the L2 cross-domain messenger, they have to simply put this information into its state tree. That's the state on L2. And that's it. They don't need to even issue any event or nothing like that. It's enough to simply update the state, because this initiate withdrawal, that will be eventually put into this update, initiate withdrawal, this update transaction batch, right? So this initiate withdrawal will end up in the canonical transaction chain. Then the state, including this little message here, will be appended to L1. And now, because we are not sure if this is correct, now we have to wait, right? We have to wait through the fraud-proof window, and once that passes, anybody can actually pick it up and can relay this message to the cross-domain messenger, right? There's this little check inside this smart contract. It actually checks whether the fraud-proof window elapsed. And if this is so, it actually assumes that the state is correct. The actual initiate withdrawal can be passed, and it's easy to imagine what happens next. This method is invoked on the DAI bridge, and eventually the DAI is sent to the user, right? So how do we actually deal with this 1 week delay? And by the way, the frequently asked question is, what if the state hash submitted to L1 is actually incorrect and nobody submits the fraud proof, right? What happens then? And the answer is that the security assumption of the whole construction is broken, right? So if that happens, we would need to basically shut the whole rollup and start all over. To make this construction fully secure, we have to make sure that this actually never happens. So if the state is wrong, somebody has to be incentivized to actually submit the correct state, right? To submit the fraud proof. All right, so let's have a look at how we can approach the fast withdrawals from the very simple schemes to schemes that are somewhat more complicated. Well, like I said before, anybody can look up this transaction as soon as this is actually put into the canonical transaction chain, and they can validate this transaction by simply executing it and looking up the actual state. So because anyone can check if this will succeed and or fail, we can introduce this little guy here that we will call a liquidity provider, and they can assist the end user. How would they do that? So imagine that the end user does not want to wait for 1 week, right? They have initiated withdrawal, they can see this transaction on chain, and now they have to wait, right? So the liquidity provider can come to the game, they can validate this transaction themselves without the waiting for the sequencer, and they can offer this user the DAI or the token that will be withdrawn eventually after 1 week. And if they have this DAI right now, they can actually give this user that DAI and claim the original user's DAI in a week, right? And note that because this can never get deleted, it doesn't really matter whether this new state update from the sequencer is actually correct or not. It's completely irrelevant. If I can validate myself the initiate withdrawal, and if I don't make a mistake doing so, I can be 100% certain that after a week, the DAI will be actually released, right? So if we can find a way to make sure that this DAI released to me, I can make this swap. And this is called the liquidity provider enabled fast withdrawal. It's very simple to actually implement. However, it's got a couple of drawbacks. Well, first of all, it can be quite expensive for low liquidity tokens. Also, the big withdrawals may lead to liquidity crunch because, I mean, maybe there's actually more tokens on L2 than on L1. And if that's the case, and if somebody wanted to suddenly remove all the liquidity, there may be simply not enough liquidity on L1 to assist such a huge withdrawal. And also that probably wouldn't work at all for NFTs because these are unique, right? So unless user is withdrawing an NFT to sell it immediately, this scheme wouldn't actually work. However, for a lot of use cases, that could be actually quite good. How can we do better? Well, now we're going to the Maker protocol. Maker protocol actually can provide virtually unlimited liquidity. A Maker protocol can mint DAI using whatever is available as a collateral. Is up to the governance of the Maker protocol, but it can actually serve as a cheap liquidity provider. And the intuition would be to simply mint DAI for 1 week and give that DAI to the end user. And after 1 week, since we can validate this initiate withdrawal transaction ourselves, this is almost like a risk-free loan, right? So it would be very similar to the flash mint, but for the duration of the fraud-proof window. Not of one transaction like a normal flash loans or flash mints, but for the duration of the whole week. We'll mint DAI, and after 1 week, the DAI will be returned and it will be burned. And we can go one step further. We can actually remove the liquidity provider, and we can do everything in a smart contract by using oracles. And it just happens that the Maker protocol has an oracle network, and that oracle network can be quite naturally extended to do the validation of this canonical transaction chain. And if that's done like this, we can imagine that perhaps the bridge itself can simply ask the oracle whether the withdrawal will succeed. And if the oracle says yes, then it will simply release the DAI, right? So that looks very simple. It does not introduce any additional trust assumptions except for the oracles themselves. But this is actually important that this scheme is actually dangerous, because if the oracle fails, then this architecture can actually lead to a double spend. And I don't have much time to explain why this is the case, but I leave it to all interested viewers to sort of think a little bit about it. But let's try to improve on this. So now, instead of just releasing the DAI, we actually print or mint DAI in a Maker Vault, right? So the way now it would potentially work is that the user who would be trying to mint DAI, now they would actually ask the bridge to do the fast withdrawal, and the bridge would ask the Maker Vault to mint DAI. And again, the Maker Vault will ask the Oracle whether the withdrawal will succeed. If the Oracle confirms that this DAI is actually minted, right? So there will be some debt here recorded. The original DAI still stays at the vault, but the DAI, the freshly minted DAI, can be released all the way to the user, right? And after a week, the DAI will be released. Now, of course, not to the user, but to the vault, and it will erase the debt, right? So that would work. And the interesting feature of the design is that now, if the Oracle fails, then the maker will have to cover the loss, right? And interestingly enough, this is not any extra additional security assumption, because the way the Maker protocol works today is that it actually relies on the Oracle networks, and the Oracle failure, the potential Oracle failure, is covered by the various mechanisms inside the Maker protocol, right? So we're actually piggybacking on the whole Maker infrastructure to do that. And the good thing is that such potential failure of the Oracle network that does not affect DAI users, it will affect MKR holders. And this is literally what the MKR token is for. The only downside of this particular design is that it's not particularly flexible, because the user, to make a fast withdrawal, they have to go to the Maker Vault every single time. That's actually gas consuming. So let's improve on that. How about we actually tokenize the withdrawal claim, right? So instead of sort of going to the bridge and going to the vault, the user may go to additional component, which we will call FDAI Minter. F stands for a forward DAI, and this represents a tokenized withdrawal claim. Think NFT, which says, I have initiated the withdrawal and I will get this amount of DAI in a week from the deposit contract, right? So we will use this as a collateral potentially, but we don't have to. We can actually swap it with somebody else, right? And here, the liquidity provider may be back in business. We can create a sophisticated swap market. We can create some additional secondary liquidity solutions around it. And the users can maybe perhaps even bundle these tokenized withdrawal claims and use them as a collateral to mint like a mint DAI in bulk, if you like, right? And hence the gas fees will not be such a big problem here. So this is probably the most sophisticated type of structure and construction. But as you've seen, I mean, we can iterate, we can build different type of bridges. And the last point that I wanted to make is that given the fact that there are different type of bridges, now you have to sort of realize that users will be able to actually use many of them with different mechanisms. So for example, they can use the DAI bridge with our fast withdrawal scheme, but they can perhaps use some other type of bridge, like a multi-token bridge. And this will also create DAI on L2, right? However, these are not the same DAI. They won't be fungible directly. I mean, you can easily swap them one-to-one. However, they can't be like mixed and matched, because you cannot go through one bridge and exit through another bridge, right? So I think it's important for the community to realize that there must be some sort of a social consensus on what is the actual DAI token on each of the layer 2s. And I guess from the user perspective, you wouldn't want to wait to end up in a situation where there are a lot of different competing DAI implementations, right? So main takeaways, message passing from L2 to L1 is an Oracle problem, and Maker already has an Oracle network, and DAI security actually relies on them, so we can easily leverage this construction. Maker also has no liquidity constraints at all for DAI, so there will be no problem of liquidity crunch. And also, this scheme can be used to provide DAI liquidity to support fast withdrawals for other tokens as well. It's a little bit different, but it definitely can be used, and we're really happy to talk with other projects on how we can achieve that. And also, the last note, we need social consensus around the issue of what constitutes the real token on L2. So thank you very much, and I hope I made everything quite clear. And if you've got any questions, I don't know if we've got time for them or not, but that's the end of my presentation.
Awesome. Thank you so much, Bartek. And I guess as a bear market story, I can share, I don't know how many viewers realize, but MakerDAO, basically started DeFi. When DAI launched about 3 years ago, that was the first, decentralized product, CDP vaults. And what's really exciting now about Maker, building this bridge and working on rollups is the original vision of Maker and DAI, being accessible to lower income communities, or, just anyone who may have not had access to the banking system. So really excited to hear Maker focusing on that and making it affordable, basically, to do transactions with Maker. Awesome. So up next, we have Arjun Bhuptani, the CEO of Connext. Really excited to hear more about what Connext has been doing. And, another little bear market tidbit, Connext has been around, for several years doing state channel research. Started off by receiving a grant from the Ethereum Foundation for some state channel work with Spank Chain, and now pivoting to vector payments. Really excited to see the progress you guys have made.
Awesome. Yeah, thanks so much, Eva. I guess let me start by sharing. Cool. This talk is called Cross-Chain Swaps and Liquidity Providers. I've missed the providers here. But the idea behind this is that I want to cover kind of a little bit about like the ideas behind why Connext exists and what it means for as we go into like this layer 2 ecosystem and this new layer 2 world, and go give a little bit of an overview of how Connext works and then also where we're planning to go. So I think the first kind of core thesis that we started with was that Ethereum layer 2s need interoperability. This means a lot of things. So like, of course, there's like layer 2 exits, fast layer 2 exits, fast Optimism exits that Bartek just talked about. But then we're also seeing that there's a big need for just like broader L2 to L2 communications. And the core idea behind this is that like, especially with Ethereum gas fees increasing kind of exponentially over the course of the last few months, we've seen that users kind of want to treat ETH layer 1 as like lava. Like if they can avoid having to go through Ethereum layer 1 at all, then that ends up being like a 10x experience for them. And not having access to that, so it kind of brings about the same sort of like minimum liquidity or minimum value requirements that currently exist on Ethereum layer 1 itself. So for instance, pricing out like users who don't have tens of thousands or hundreds of thousands of dollars in order to like make large and expensive trades on Uniswap. Those same users now end up having to deal with the same problem around, even if they're like on a solution like Polygon and trying to get to another solution like Arbitrum, they have to deal with the same problems unless you have like native layer 2 to layer 2 interoperability. And we're seeing that this is like becoming ever more necessary. So like when we started talking about layer 2 interoperability last year, it was a really controversial topic. I think the philosophy at the time was that people would be moving to a single layer 2 ecosystem, and that there wouldn't be this like plurality of different solutions out there on the market. And even if there were, like over time, everyone would just like aggregate to one thing. What we're seeing though is that that's not really the case. Like we have a diverse set of service providers providing different layer 2 solutions, and then also DeFi projects and other kind of like key players in the ecosystem going to different solutions as time goes on. So we've seen in the last like 2 months, every single DeFi project that's out there is pretty much every single DeFi project has announced some sort of like multi-chain strategy. And this begs the question of like, how do you deal with cases where users have funds on one system and want to get to another system? And ideally do that again in a way where they're not having to deal with like, significant layer 1 gas fees and the 1-week exit window. So there's a bunch that's out there on interoperability and on like Ethereum on like layer 2 fast exits. And so here I'm just going to try to give like the highest and broadest level overview around like what it means to communicate between different blockchains. So there's 3 general approaches that people have seen so far. There's and everything that's out there kind of falls into one of these 3 approaches. There's native cross-chain validation, basically like the idea here is that like the virtual machine of one chain natively validates the virtual machine of another chain. This is hard to do because like it typically either requires you to have custom chain implementations or it's extremely expensive. So like for instance, rollups fall into this category where like you have Ethereum validating a lot of the rollup state, and either that's happening through fraud proofs or validity proofs with zk rollups. And the native validation aspect of this is kind of what keeps rollups trustless. So like in a mental model for a rollup is that it's also just kind of like a POA sidechain, but it has a trustless bridge. And I think that's a key part of it because like fundamentally when you think about it that way, that means that the entirety of this layer 2 problem really comes down to how can you build trustless bridges. Now, what does it mean to have this kind of validation? So luckily, native cross-chain validation is trustless. It's entirely trustless, and it's about as trustless and generalized as you could possibly get. And that's what makes like rollups so powerful, and that's also what makes things like IBC so powerful. However, there's sort of this like trade-off space then around like the amount of time that it takes to make updates and the amount that it costs. So like if you have purpose-built chains that are designed to be communicating with each other this way, or at least one of the 2 systems is purpose-built, like with the rollup, then the cost is not super high. I mean, it's still somewhat high in the sense that you have to keep publishing rollup blocks because you need data availability, but it's not like you're paying like thousands or millions of dollars in order to like submit transactions between chains, which is unfortunately what ends up happening in the case of things like the Neo Rainbow Bridge. However, on the flip side of that, you also have like exit windows for things like optimistic rollups. And so in those cases, you have this like 1-week exit where you could do things like, like MakerDAO suggested, where you provide liquidity for the exit, or you have cases like zk rollups where you can do that in a single block. Now the other 2 approaches are a little bit different because they're kind of like exist in a slightly different paradigm where you're not having to have these like native systems that are built purpose-built to be interoperating with each other. Instead, POS and one-to-one swaps are both mechanisms that can be used against existing chains, so things like sidechains, even other Ethereum, even other non-Ethereum layer 1s. So examples of POS and MPC bridges are Thorchain, Ren, as Bartek just talked about, like MakerDAO's Optimism exits kind of fall into this broader category. And like the Polygon POS bridge. And the core idea behind this is that there's like some third-party validator set and that acts as an oracle. And that third-party validator set has some mechanism to keep them trust minimized. So there's some like economic bonding mechanism that reduces the trust on this set of party. Now, of course, the idea is like if you're going for maximal trust minimization, where like you are defaulting to Ethereum's trust model, which basically means Ethereum's economic security. Having a POS/MPC model means that you are diluting that economic security. You do have a secondary mechanism, like a secondary economic backstop. And in the case of Maker, it's basically the MKR token that is used as like the Oracle backstop. In the case of Thorchain, it's Rune, et cetera, et cetera, et cetera. Now, depending on the mechanisms, the amount of cost, the cost is like usually low to medium, and it's usually anywhere between slow to fast. And there's like a lot of variety here because this is sort of like the broadest category where you can have a lot of variability in how people implement solutions. And then the last approach is a one-to-one swap model. So the core idea here is like take this like n-party consensus system or this n-party Oracle problem and turn it into a one-to-one system. And the cool thing with one-to-one systems is that like both people have skin in the game, and because both people have skin in the game, you could kind of expect them to always behave in a way that's like economically rational for them. They're not ever going to like behave in a way where they're losing their own funds, and if they do, then it's only their funds that are on the line. And this includes constructions like atomic swaps. It includes what we're doing at Connext with channels. But the idea here is like it is trust minimized in the same way that like native cross-chain validation is trust minimized, because it just inherits the core properties of the base chain. Now, of course, there are like downsides to this as well, and I'll kind of talk about those as we go on. So how does Connext work? At the highest possible level, what we are is just a regular old state channel network. And with any kind of regular state channel network, you have a set of liquidity providers. These are state channel nodes. We call them routers that provide that basically front the liquidity in a receiving side channel in order to get a payment in a sending side channel. And all we do is we extend this model across chains. So basically, if Alice wants to send funds from Arbitrum to Optimism, so say she wants to send ETH from Arbitrum to Optimism, what she would do is like send a payment in a state channel in ETH to a liquidity provider, to a Connext router. And the Connext router would send a corresponding payment in a state channel back to Alice. Because we're using channels here, we can make sure that those two interactions are atomic, and that enforces the fact that there's no way for the router to kind of like steal Alice's funds, and there's no way for this whole cycle to not complete once the router has actually initiated the process of like completing this transfer. Now, there's definitely a lot of nuance to this. This is like, again, the highest possible overview, the highest possible level overview I could give. But there's a few key design principles that we've baked into this that we feel really strongly about as part of our core assumptions. So first of all, we think it's really important to utilize the security of the underlying chain. And the reason that this is important is because we don't quite know what mechanisms are going to be used for Ethereum layer 2 solutions in the future. Right now, we see rollups as like the most dominant mechanism for securing, like for a very secure model for layer 2. But there's also downsides to rollups that people like that I think are not really discussed often enough. And those downsides are things that I think people will start to see once we start to get rollups live around like the actual the absolute scalability of a rollup model versus other models that don't necessarily post constantly to chain. And this is kind of like the core idea behind like zk rollups versus zk porter that I think Alex from zkSync is talking about, and either he might have already talked about or he's talking about today. And so our goal is to say, okay, well, we don't necessarily know what mechanisms are going to be used to bridge between these different chains on the base layer, quote unquote. But we do know that whatever mechanism is used, you do always need this ability to allow for fast, cheap swaps between different assets. And kind of going back to this model, the good thing about that philosophy is that means we can work in tandem with like existing POS MPC bridges and existing native cross-chain validation models, because the fundamental assumption with our one-to-one swap model is that an asset already exists for us to swap into, right? There's no way for us to do what we're doing with Connext unless you already have liquidity on the receiver side. Second, and this is kind of building off of the same core idea, don't create lots and lots of representative assets. So Bartek was talking about how there's this problem with like that is going to show up with Optimism, and as we've already started to see with like XDAI, where if every single new person that builds a mint and burn bridge into XDAI or into another chain ends up creating new representative assets which are not really fungible against one another, and you can trade them against one another, but this just increases the complexity of these assets massively. I had this problem myself yesterday when I was trying to swap, where like I ended up giving liquidity for Aave on Polygon, and I ended up with like AM USDC, and I tried to swap it for something else on QuickSwap, and it turned out that QuickSwap only has liquidity for MA USDC, which is actually the liquidity that you put into Aave in USDC on Ethereum and then bridge to Matic, rather than the other way around, bridge to Matic and then put into Aave. So there's just like a huge user experience mess there that we are currently barreling towards that I think folks really have not been aware enough of yet. And then the last idea is kind of one that I've touched on already, which is don't incur those layer 1 costs when moving assets from layer 2 to layer 2. We've had a number of users come up to us and say, hey, I had $40 or $50 on this chain that I had pretty much just given up on in dust as dust. But because like I didn't think that there was any way for me to get it out of XDAI or Polygon or whatever and get it into another system, and that's unreasonable. Like $50 is a lot of money for a lot of people in the world, and we shouldn't be pricing people out in that way. So is it working? Yes. We've seen that this model doesn't just work. It actually scales pretty well. It's incredibly capital efficient because we're actually netting off liquidity going in like different directions, and so you can have like swaps that are going from like a lot of this is like BSC to Polygon interactions. We have a lot of swaps that are going from BSC to Polygon because people are onboarding to Polygon, and then a lot of swaps going in the other direction because people are trying to exit into fiat. And all of this $4.3 million in volume is actually happening on about, I think about $4 million of this volume is happening on about 250K in liquidity, which is insane. That's an incredible capital efficiency. And you can also see very clearly the point where like the DeFi apes discovered that this was a model that works and it's incredibly cheap, because that's where we went from that's where we 8x'd our payment volume. Now this model doesn't really exist without its own drawbacks. And there's a couple of things that we're working on in the kind of like short to medium term that we think really need to happen in order for us to keep scaling this up, because if we keep going up in this direction, we're going to keep running into problems. The first thing is automating router rebalancing. So the biggest kind of like user experience hurdle that we're dealing with right now is that you have these routers holding liquidity pools on each chain, and then a user, similar to what Bartek was talking about where like users come and do like larger transfers. A user comes and does a larger transfer, pushes all of liquidity to one side, and now nobody else can do transfers. A part of that is solved by just having deeper, more liquidity depth, but ideally what we want to do is create an incentive for people to come and rebalance this thing for us, so that way we or whoever the router operator isn't actually having to do this themselves all the time, because that's expensive and it's a pain. And then second of all, there's decentralizing scaling of liquidity itself. So how can we have more routers in the system and aggregate liquidity across all of these routers? So something that we're starting to explore now is the concept called virtual AMMs. We all kind of understand the AMM model, which is let's take the price between two different assets, or perhaps even potentially many different assets in liquidity pools, and bond that to a pricing curve. For Uniswap, that pricing curve is like a constant product function. For stable swap, is this more complex equation that optimizes for stable one-to-one assets and things like that. And the core idea behind this, and what makes this really powerful, is that the price between these assets moves as a function of the available liquidity within the system. And because this price moves, you now have this incentive that gets created for other people to come and arbitrage this thing if that price doesn't actually reflect the true price of the asset in the market. So for instance, if I go and I swap 1 ETH for 1 maker sorry, not 1 ETH for 1 maker, but if I go and swap some ETH for maker on Uniswap, and I push the ETH, I basically end up putting more liquidity of ETH into the ETH pool, and I reduce some of the liquidity in the maker pool. That will change the price between ETH and maker on Uniswap. Now, if say Bob is a person who is watching this interaction and has liquidity in maker, and he sees that the Coinbase price of maker is actually lower or higher than the price that is available in this that is available on Uniswap, he now has the ability to go and arbitrage it. And I think this is one of the things that makes Uniswap so powerful is that it's just so easy to arb. I think we can take the same kind of concept and apply it to these routers. And we're calling this virtual AMMs, because it's not like these are actual AMM contracts on chain. It's just that we are bonding the swap rates that the router provides between assets in this chain, or assets on Arbitrum for assets on Optimism. And we're bonding that swap rate to another AMM curve. Now the cool thing is here, we're doing the same thing that we're doing with Uniswap, where over time, as you continue sending ETH on Arbitrum to ETH on Optimism, this actually changes the price between these two assets. And that difference in price reflects the available liquidity on those systems, which again incentivizes somebody to come and push liquidity in the opposite direction. The cool thing is that because we are not actually taking control of the rebalancing mechanism ourselves, we're just incentivizing that somebody comes and rebalances this thing. That means the ways that we have to rebalance this thing, the ways that other people can come and rebalance this thing are dependent upon not just the existing bridging mechanisms like rollup exits and entries, but also on other liquidity that you can find through OTC trades, through swapping through fiat. And I think the idea behind this is that like, even if in the case of something like, Binance chain, where like the Binance bridge ends up being taken down, there is actually a really interesting mechanism where people can still continue doing virtually uncensorable swaps between in and out of Binance chain because they can continue arbing through the Binance exchange or through OTC. Now, of course, the swap rate might be awful, but hypothetically, this ends up being a lot harder to censor. The second aspect of this, and this kind of gets into like, how do we scale this thing up and make it available to a lot more people a lot more quickly, is aggregating liquidity across a bunch of different routers. And we call this route auctions. So the core idea behind this is that like, when Alice wants to send liquidity from Arbitrum to Optimism in ETH, she doesn't really care that much which router she's routed over, or sometimes which several routers she's routed over. All she really needs to do is broadcast the network saying that this is the entry liquidity that she wants, and this is the exit liquidity that she wants. And the cool thing is that over time, what we can do is have many, many different routers providing this kind of liquidity in the same way that you have many different liquidity providers on Uniswap or on any other AMM system. And Alice can be routed over one or many of them concurrently. If we put this together with the virtual AMM model, what's really interesting about this is that Alice has an incentive once she kind of hears back from all of these routers who are willing to supply this liquidity. She has an incentive to always pick the cheapest one, and that's always going to be the router that is the most unbalanced. So you end up creating this really interesting economic flywheel where over time, through the combination of these route auctions, where Alice is broadcasting to the entire network saying, hey, I want to swap X for Y, and routers returning saying, okay, I'm willing to provide that liquidity for X amount of dollars. The combination of that, and then also the fact that these routers are pricing their liquidity based on an AMM curve, means that Alice is always going to end up in a position where she is actually de facto rebalancing somebody else's liquidity. So you have this really cool flywheel where the network sort of starts to rebalance itself over time. Now, of course, there's still space for arbitrageurs, and that's still an important role within the network. But the idea is that over time, you can end up with a system where like you don't really need so much ARB anymore. You just have this very, very efficient mechanism for targeting where the liquidity is most needed. There's still a lot of really interesting stuff here. It's a big open space that we're exploring. We absolutely would love to get people involved in building on top of us. So if you're interested in getting involved, you can build on us by like checking out our hacker kit. It's at connext.network/scalingETH. And then you can also hit us up on Discord in order to start participating in some of these open research questions that we have around like virtual AMMs, penalizing disbehavior, route auctions, and a lot of other things that we're working on in the future that we think can help make this into like a very, very interesting mechanism for communicating directly between different layer 2 ecosystems and also to layer 1. Like our mental model for Connext is sort of like this cross-chain clearinghouse that sits on top of any of the chains within the Ethereum layer 2 ecosystem and allows you to kind of net off volume between them. Cool. Thank you all for coming to my talk, and I hope you all have a good rest of your scaling Ethereum.
Awesome. Thank you so much, Arjun. It looks like we might have a few minutes. Do you have a minute to maybe answer a few questions?
Yeah, absolutely.
Awesome. The first one I have is, how are you thinking about Connext and vector payments in regards to ETH2 and the transition? Yeah, so there's obviously like a lot of open design questions around ETH2 right now, where like, I think the current model of ETH2 is that like shards are basically going to be like data availability layers for rollups. And in that model, like the idea of having many different rollups actually only becomes more powerful. So what our philosophy is that with ETH2, we're only going to see like a dramatic acceleration of the trends that we're already seeing, where people are moving to a bunch of different ecosystems and you're going to be fragmenting across these ecosystems. It kind of sucks because like, obviously fragmentation means poor user experience, but also like that is sort of the definition of decentralization, right? Like decentralization isn't always going to be the easiest path. Yeah, for sure. And one last question, maybe, what are you most excited about now that we're finally at this place several years after doing so much research? Now the DeFi apps, NFT apps can actually start using these L2 solutions. So what are you most excited about as we move into production?
Yeah, that's a really good question. I think like I'm sure a lot of the other L2 researchers will like, I'm sure they feel the same way, but it sort of feels like a catharsis moment where like there's been so much uncertainty for so many years around like what layer 2 will look like and how it will work, and we've gone through so many iterations on like that have just not worked, and like that's both within channels, also with like things like Plasma, and now rollups. And of course, there's still a lot of open questions that will have to be solved, especially once users start using this stuff, because like as we've seen with channels, like users end up just breaking your shit all the time, and there's nothing that you could do about it. And like that's just how user testing works. But I think like I think what I'm most excited about is to like kind of get to this next step where we actually have like some of these things that we've been talking about for years actually start to come to reality, and we can think about what comes afterwards, because we've been stuck on these problems for so long that we haven't been able to progress past them yet.
Right. Yeah, looking forward to it and what scaled Ethereum will look like.
Yeah, hopefully we can have a scaled Ethereum ETH Global conference.
Yeah, exactly. Awesome. Thank you so much for joining us, Arjun.
Awesome. Thank you so much for having me. Yeah.
Next up, we have Mo Dong leading the Stellar project. Stellar is actually another team that's been working rigorously through the bear market. And so they were focusing on state channels. They also created a really revolutionary state guardian network. And what I most remember Stellar for is the Gomoku game that you guys did that got a lot of traction. So welcome, Mo.
Yeah, thank you. Thank you for the invite. And it's great to be here. So today, I guess I will just first share my screen here and talk about some of the new things that we're working on. So as let me just see if this works. All right. All right. As Eva had pointed out, we are a scaling platform, and we started out with state channel solution, and we actually are the first one launching on Ethereum mainnet with generalized state channel. And the generalized state channel side of things are running very smooth right now. The initial Gomoku game right now has evolved into a whole platform called Synthetix gaming platform, and the games built on top of that is processing payments using state channel, and now has approaching 1 million users in the US market actually. But most recently, we're also kind of looking at different kind of scaling technology, and we always see layer 2 scaling as a holistic landscape that we need to have combine different kind of technology pieces together to offer a holistic view for the market and for the developers. So this is one of the motivations that leads to the things that I'm going to talk about today, which is layer 2 finance. And what this really is the DeFi cities public transportation system. And I'll get into how that is the case. Well, we all know DeFi is awesome. Basically, this summarizes it all. The most stable and safe DeFi protocol provide 10 to 50% of APY. And if you want to go to a little bit degen world, it's really no upper bound on this. While we look at the entire traditional financial world, set along banks, traditional banks, even if we talk about fintech banks, neobanks, challenger banks, these guys are always 50 times, 100 times away from the kind of yield that can be offered by the DeFi space. What this tells us is that this huge amount of a difference between the kind of yield, we should see a huge influx of demand and exponential growth of user numbers. Well, not so much. So these are the data we pulled from doing analytics, and what the graph is telling us is that after the last DeFi summer, that we are seeing a very booming trend for the entire DeFi space. The entire DeFi growth, the key protocols on them, I'm just showing some of that, is actually slowing down. This graph, the y-axis here is a day-by-day user growth new address thing, and the axis here is actually the time. So you can see that after the huge spike around the last summer, everything started to quiet down a little bit. And another interesting way to look at this is that we look at the total amount of the daily active user for the entire DeFi space. This is also data we pulled from doing analytics. And so basically based on on-chain data, we're seeing about 40,000 daily active user in this entire DeFi space. Okay, so we have 40,000 other DAU in the entire DeFi world. What does this mean exactly? Okay, so it basically means a US Apple App Store based app. I'm just talking about the US market, and it ranked about 500th in casual game category, which is like one example is a cut roll. This particular game's the daily active user exceed the total daily active user of the entire DeFi world. So DeFi is still small and it is not exponentially growing. It begs the question of why. Really, why that is the case? It just doesn't make sense. So, you know, one way to kind of look at this problem is to really visualize the DeFi landscape as a city, right? So like you have your home, which is your MetaMask wallet, and then you have all these shops, which is DeFi protocol you can park your money on at and kind of earn reward. Now, the problem happens at the point where you want to travel from your home to these shops to actually drop off your money. And the problem about this particular city is that this particular city only have one type of transportation system, which is the expensive limo service, like super expensive, highly expensive taxi. This works fine for Alice, who has like $1 million to play with. So Alice goes, you know, to a shop called Compound, which is offering 10% annualized gain, paying about $250 for the limo fee. And what's going to happen is that, you know, after 1 day sitting in this particular protocol with $1 million minus that limo fee, she can turn into profit in just day one. Now let's look at a different scenario, who is Bob, who are early majority. He wants to try this out, but only have like $1,000, $2,000 to just try the water and test out what's this DeFi all about to actually get hands dirty. So same thing, but just as the limo fee is fixed, no matter how much like money you're actually taking to these shops, and you know what's going to happen to Bob is that even after 1 year, Bob still lost $175 after parking his money to Compound while paying that super expensive limo fee. Now we probably all know that what this limo fee is referring to is basically the layer 1 transaction fee we need to pay in these you know, these days, like to interact with these kind of protocols. Now this is why we believe that DeFi hasn't really started to grow exponentially, because for many of the early majority adopters in the space, it is actually very hard to get the promised APY while you know, eating all this kind of upfront gas fee cost and kind of learning frictions of using DeFi. So, you know, any kind of a reasonable city designer and city planner would at this point say that, hey, this totally doesn't make sense. We should have like a public transportation system in this entire city where, you know, people can just gather around and take the train all together and split the vehicle cost or split the gas cost of this entire train. And everyone will pay like $1 instead of a $250 limo fee. Well, this is exactly what Layer 2 Finance is trying to do. Layer 2 Finance is trying to build a Layer 2 rollup system that essentially act as another layer on top of the existing DeFi landscape without actually asking the DeFi protocols to move to a different layer, but just adding another layer of liquidity on top of that to allow users to use DeFi system as if they're taking a public transportation system in the DeFi world. So this is what Layer 2 Finance looks like. Let's walk through a very simple user flow here. And you know, it's right now live on Robston. This is actually the new UI we're launching in mainnet next week. So you know, in this particular you know, UI, the first step is really just move users fund from Layer 1 to Layer 2. Well, you know, using the same kind of a subway analogy, you're basically buying a subway ticket this time. Like you're entering this entire, you know, Layer 2 space. And then the next step is among all these protocols that you see, like basically we're actually aggregating all these protocols together, like the Compound, Earn, Alpha, Ape, and all these other future protocols and strategies that user can express their intent to actually put their money in. So user can actually click the deposit and specify a certain amount of fund to actually deposit in. And this is like they're now getting at a station to wait for a train to leave. Okay, so what actually happened under the hood is that they're sending a layer 2 transaction in this layer 2 rollup chain, indicating that, oh, I want to allocate my fund to compound by how much. And what's happened after that is that they will have an aggregation pending phase, where this rollup chain is essentially aggregating and waiting for a sufficient amount of users who are all going to compound, basically having the same kind of intent. And then what's going to happen is that it's going to aggregate all these demands together and form a kind of a layer 1 call, basically layer 2 to layer 1 call in the form of kind of a commitment, and saying that, hey, now let's allocate the fund pool in layer 1 to basically direct 3 users combined fund all going to compound at once. And therefore, if we have like 100 users all wanting to go to compound in this train, they will be able to split the cost by 100 times. So basically, everyone will get the cost reduced by 100 times. So this is like the basic idea of layer 2 finance and using rollup to solve the DeFi kind of a problem. And then after that, the user will be able to just directly get their gain on layer 2 while their fund is actually moved to that protocol. The good thing about this is that it doesn't cause any kind of liquidity fragmentation. So basically, we don't need to push different protocols into different chains. We're merely moving users and their liquidity in layer 2 and aggregate their demands in layer 2 and combine their demands back into layer 1 and allocate the entire pool of fund all together at once and split the single transaction cost instead of asking each and individual user to make one single layer 1 transaction cost all by themselves. So this is basically the kind of a high level idea of layer 2 finance. This is what we're building, and actually there's a live testnet running today, and we're also releasing a new mainnet with this new shiny UI next week. So the immediate question is, hey, wait. So this sounds like really something like I'm putting my money all together and someone seems to be managing it. So like, is it possible for the layer 2 or whatever the system you're calling it actually be malicious and actually take the money and just wrong? Well, that's a very, very legitimate question. The answer here is that no, really, because this is actually built as a in-house optimistic rollup solution right now. So, how the process works is that a user starts from layer 1, and they all have funds. The first step is, they will put their fund into a rollup fund pool smart contract, just like any rollup. They will just put the fund there, and then they're moved to layer 2, essentially. They have balances on this layer 2 finance rollup chain. And then they will specify their fund allocation intent, basically, to this layer 2 finance chain. So it's very critical to note that these type of fund allocation intent now becomes the transaction on this special layer 2. And what's going to happen then is that, for example, these 3 intents are all sharing the same kind of a strategy goal. And what's going to happen is that this rollup chain is going to, of course, post all the call data and state root. And very importantly, a fund allocation proposal. And in this case, it's basically telling the layer 1 fund pool contract and saying, hey, I can prove with the call data and state root that in combination, you should allocate $300 to this strategy 0, which is, let's say, compound. And then there will be challenge period passed. And what's going to happen is that the fund allocation confirmation will happen, and the fund pool will actually allocate fund into the corresponding strategy adapter. And then the strategy adapter themselves will actually interact with DeFi protocols to actually allocate fund to the DeFi protocols. It's essentially kind of a combining many users' fund allocation strategies and the transaction into one. So this is how this is done. Now, an immediate question would be, okay, does this actually cause a lot of kind of a delay in the sense? Well, not so much. There, of course, will be the aggregation delay, but the challenge delay is definitely not going to be something like multi-weeks. It's actually going to be in the hours. The reason for that is that the rollup state in this particular rollup is so much simpler, because it's not an arbitrary EVM. It's just like a kind of you can think of this as kind of pretty simple ledger. That is, I'm putting my money into which protocol or which strategy. And the type of transaction is also pretty simple. So it's very easy to verify. It's very easy to catch any kind of malicious intent. It's extremely cheap to challenge in the case of any kind of malicious attempt. So let's talk a little bit more about the strategy side. The strategy can be very simple, direct the wrapper to the existing strategies like Compound, where we basically wrap the Compound with the auto harvest of the liquidity mining token, comp token function. And Curve and the Maker and all these other protocols can be very simply wrapped around. And what can also be done is we provide this thing called Layer 2 Finance Strategy SDK to allow user to basically develop a strategy as long as it's conforming to a certain interface that is connecting to the fund pool. It can be plugged into this Layer 2 finance system dynamically. What this means is that you can create a strategy, for example, put ETH into Maker and lend out DAI at Compound and earn interest rate. And we can combine multiple kind of strategies all together. That's all perfectly fine. The good thing about this is that you can really start to expand the complexity of the underlying strategy while maintaining an extremely simple user interface for the user to use. So in a way, Layer 2 Finance become a very nice to use and easy to use aggregator. And at the same time, it avoid any kind of, the key challenge people face in today's Layer 1 aggregator, where, in today's Layer 1 aggregator, people are actually paying higher fee because this additional layer is actually costing higher amount of fee. But like actually in the Layer 2 Finance, the retention of user using this aggregator is going to be pretty strong, because they really will be better off using Layer 2 Finance, and at the same time, in terms of like a transaction fee is also much lower comparing to directly using Layer 1. So for that, we are offering $705,000 to as prices to build using Layer 2 Finance Strategy SDK, with two prices, $3,000 to the best Layer 2 Finance strategy, and $1,005 each for 3 runner-ups. And we hope to see the community start to build some very cool strategies and connect them to Layer 2 Finance and allow more users to use Layer 2 Finance. And you can always find us at East Global Discord space, and you can follow us at Stellar Networks Twitter, and we have pinned the tutorial video on our Twitter, and all the relevant code and documentation can be found in our GitHub. So, we're basically trying to build a DeFi public transportation system, so to allow everyone to be able to easily access DeFi. So yeah, that's all from us.
Awesome. Thank you so much, Mo. And it looks like we have a few minutes for questions, if you don't mind sticking around.
Sure. Yeah, I can definitely stick around.
Cool. The first question I have for you is, you've been on this journey for a while, as you see, Gomoku into a gaming platform, starting from state channels to where you are today. What has been the biggest learning for you, as a researcher, in how you've seen L2 scaling solutions evolve?
Yeah, I think the biggest learning is that it's always a trade-off game, and it's basically defining and finding out what is the right trade-off to choose. In the early days, like if you think back, like in the plasma days, people were thinking we can achieve this kind of a quadratic scaling by cascading plasma layers, like a one layer on top of one layer two and another layer two, and then along the way, people quickly find out that the trade-off doesn't actually pay off while we kind of continue to cascade. And I think the biggest learning for us is that there are different kind of application scenarios suitable for different kind of underlying scaling solutions. And our goal is still very much the same as we first started out, which is like trying to combine different technology pieces together into a holistic platform and a holistic application to offer to the end users and bring more kind of end user to the platform. Yeah.
Got it. And how are you guys thinking about the future? So we've got quite a few layer 2 options, and my personal view is that every dApp, every layer 1 chain, they'll choose the solution that makes most sense for their use cases. But as we also expand to ETH2, how are you guys thinking about Stellar's role in scaling Ethereum?
Yeah, definitely. I mean, like, there are a couple of different pieces, right? So like, while we're moving to this multi-chain world, Stellar also have this, our state channel solution is easily extended to something called C-Bridge, which is able to bridge different kind of chains from layer 2, layer 1, and all that stuff. So, we're launching pretty soon with all the other layer 2 solutions together, and it will be something pretty interesting that everyone actually can participate and provide liquidity for the liquidity bridging between different chains. It's kind of almost like a liquidity pooling, which is pretty cool. And for the roll-up perspective, right? So like there are really two kind of a stream that is going on. One is that let's build a separate chain and move every application possible to that chain. And what's going to end up very soon, towards the end of this year, is that we'll end up with almost a sharded Ethereum. Basically, you will have like multiple kind of roll-ups that is spinning up. It's good for scalability, but really horrible for UI UX, especially for new beginners. Like they will have a hard time in terms of figuring out where to send the fund to, and the ecosystem also need to catch up a lot. Like the Ethereum, each exchanges need to be able to figure out how do they connect to different kind of Ethereum. Does the layer 2 Ethereum actually have the same price as the underlying Ethereum? Because there's always this kind of inherent friction there, and these kind of questions will actually create increasing kind of usability hurdles. And our approach here is that, instead of taking this view, we kind of trying to take a unifying view, but like basically helping all these layers and all these kind of different chains be able to aggregate together all of their application, application together and into a unified interface for the users and into a unified pool of liquidity for the users. So from a user's perspective, they don't really care like where they're traveling. As long as they're in this kind of DeFi subway system, they can kind of travel intercity or kind of across different city, basically. Yeah.
I really like that analogy of like traveling between cities, and each layer, 2 or smart contract is its own little village. Maybe one last question, and this one can be sort of a prediction. So, it's very clear that DeFi needs layer 2, as we can see through gas prices and just, massive adoption. What use case do you think will be next for really needing layer 2 to solve the UX and getting more users onboarded?
Yeah, so I honestly think that we are still like just scratching the surface on the decentralized finance and open finance space, and I'm seeing a lot of the exciting things popping up, like with very exciting new DAX kind of design and things like that. And what layer 2 is going to enable is it's just like 4G enabled the TikTok, basically. Like you couldn't have TikTok in 3G networks, in 3G mobile networks, and with kind of this layer 2 capability, the capacity is going to be quickly filled in layer 2, and with a new type of application that couldn't be built with the existing layer 1 capacities and costs, basically. So yeah, and I think there are a very large class of open finance applications that can be built and couldn't be built today because of this kind of a high gas cost. And I'm really just looking forward to that. And aside from that, I'm looking at various different things, but like I haven't found out that it's something that is extremely interesting, except for several very interesting experiments going on with some kind of social tokens and social interactions and kind of self-organizing stuff, which is kind of dated back to even in the DAO time, right? So like it's still social coordination, but like I'm very interested in kind of how some of these experiments is going to go.
Awesome. Yeah, looking forward to seeing you guys also support a lot of these apps that are coming to fruition.
Yeah, definitely. Thank you. Thank you guys so much.
Thanks, Mo. So coming up next, we have Alex Gluchowski of Matter Labs and zkSync. This will be a recording, so I guess I'll just intro Alex a little bit. My background is that last time I saw Alex was at the Scaling Ethereum workshop that we did in Toronto 2 years ago, and I just remember them being so hungry. And at that time, you know, zero knowledge proofs were really exciting, but we didn't have the research or really understanding of how to scale ZKPs in a way that was affordable and efficient for a lot of these custodial or you know, typical use cases, you know, like high frequency trading. And so excited to see, you know, zkSync now rise, you know, as we're becoming clear where, you know, which use cases will need what kinds of scalability solutions. It's becoming clear that zero knowledge proofs, you know, are really powerful and a great one for this NFTs gaming use case. So let's tune in to see Alex speak about this.
Hi, everyone, and welcome to the talk about zk Porter, why rollups are not enough, where we're going to talk about scalability on L2 and discuss some of the predictions of what we're going to expect this summer and beyond that. My name is Alex Gluchowski. I'm CEO and co-founder of Matter Labs and one of the co-creators of zkSync, which is the first EVM-compatible zk rollup. zk rollups are one of the promising way to scale Ethereum, and there is a kind of consensus in the community that the rollups are the way to go. Ethereum embraced the rollup-centric roadmap. There are two rollup families, Optimistic and zk. There is kind of also a consensus that zk is a superior technology, which is going to be the end game of scaling, and because it has a number of properties which make it outstanding from like everything else, including optimistic rollups. Specifically compared to optimistic rollups, it's more scalable if we assume rollups using like true EVM compatibility with ECDSA signatures, single round fraud proofs. zk is going to be a lot better. It has a much stronger security than optimistic rollups. So optimistic rollups rely on some pretty strong assumptions about security, whereas zk rollups offer exactly the same security guarantees as layer 1, of course giving the bug-free implementation, but that's true for all systems. And they are a lot more usable in different regards. Most importantly, the finality is short. Finality of zk rollups can be reached within minutes, and this means you can withdraw from L2 to L1 or to a different L2 within minutes, and you don't have to wait 1 week or more, as is the case in Plasma and optimistic rollups, which is very important, especially for periods of high price volatility for many traders. Also, zk rollups are actually a more proven technology. They are in production since 1 year. We launched zkSync 1.x in June 2020. However, the rollups which were in production for this year were all application specific. So we were able to test the basic technology and basic R&D behind the tech and make sure that it's secure. But the engineering necessary to build the generic programmability and EVM compatible zk rollups were not there back then. And it took a couple of breakthroughs throughout the last year to come to this. So we will probably launch into production around August, whereas there might be some optimistic rollups that launch earlier. So the question is, should you wait for zk EVM or should you just launch with whatever is available today? So let's explore this question. And let's first look at what our scaling expectations are on rollups in general. So we all hope that rollups will bring us alleviation of the high gas prices that we have, that all the users are going to jump on rollups on L2 immediately, and we're just going to get 100x cheaper transactions. Whereas I think realistically, the reality is going to be slightly more complex. Specifically, if we look back at what happened with zk rollups, big players were kind of hesitant for a while embracing them because it's a new technology. It has to be proven. It's going to be the same with all EVM compatible rollups. It will take some time to gain trust, and we'll probably see big money on L1 still staying in L1 protocols for a while because they offer the most security. You're not going to move $1 billion immediately of your own money into some new L2, sorry. However, we're going to see a lot of smaller users who are more risk-friendly and who will immediately move into L2s. And we see this happening already with Plasma, with sidechains, even with other layer ones. And what I think is going to happen is a lot of those users are coming back to Ethereum, to the proper Ethereum solution, which is rollups. But they will also bring a lot of new users from outside because the fees will get lower and it's just going to become more affordable, right? So we have an influx of new users, which are currently not using L1, an influx of new use cases such as NFTs, which is just going to explode on the rollups, and probably some new, more interesting scenarios. And we're going to have a lot more trading because the trading, like if the fees are lower, there are a lot more transactions that you can make that will be profitable for you as a trader. So trading is going to explode and intensify. So what we will likely see is like lots of these new users and aggressive trading and new use cases, all gonna create a lot of pressure on Ethereum network through these layer 2 solutions, which all compete with each other for the bandwidth of Ethereum blocks. So we will likely see similar situation to what happened over the past year on mainnet, where the gas fees grew quadratically proportional to the number of users. So if we get 100,000x, 10x, 100x, 1000x more users on L2, the prices are gonna be likely like rising. So right now, a single Uniswap trade on a rollup would cost something around $1. You can imagine if this number goes up 10x, 20x, 50x, we're kind of going to come back to where we are now, or where we were half a year ago. So there will be a whole class of users who are excluded again from the economy, and this is not cool. So they are all going back to side chains or other L1s, which we want to prevent. We want them to stay within the Ethereum ecosystem. So what can we do about this? With zkSync 2.0, we're going to introduce this new solution called zk Porter. It falls under the class of Volition systems, and it's based on zk Rollup. It's very similar to zk Rollup with a key distinction. In zk Porter, you will have accounts of two types. The first type is zk Rollup accounts, which have all the properties of zk Rollup. You get the security of a layer 1, and you get the price of zk Rollups. A second type of account is zk Porter accounts, and they will be similar in all regards. They will be like, from a user perspective, they're going to be exactly the same. You can interact with other zk Porter accounts, with zk Rollup accounts. The entire system is transparent. It's a single shared address space and liquidity space. But zk Rollup accounts are going to be just a lot cheaper by 2 orders of magnitude, in exchange for slightly lower security. Actually, for significantly lower security, but they are still going to be pretty secure. So let's deep dive into how this works. And to explain how zk Porter works, let me start by explaining how a zk Rollup works in the first place. So with zk Rollup, we have the state is held off-chain, represented as a Merkle tree. The leaves of this Merkle tree are zk Rollup accounts. And we have a root hash, which represents a cryptographic commitment to the state. So this root hash is stored on a smart contract on Ethereum. And whenever we have a block that contains a number of transactions that updates the state of some of the zk Rollup accounts, some of these leaves will change, and necessarily the root hash of the entire tree will also change. And we will have to submit it to the smart contract along with the proof of validity of this block. So this proof, this is a snark, zero knowledge proof that verifies that every transaction in the block has been correctly done, so that it has a valid signature, that all the rules of these transactions were enforced, and so on. So we submit it there, and the contract will check the proof, and if the proof is valid, then it will update the storage slot which holds the state root, right? And we'll get the new state root. So we just do one storage as store on Ethereum for like arbitrarily many transactions, which gives us scaling. However, in zk rollup, the zero knowledge proofs can only guarantee the validity of the state, but not the data is available. So you as a user, if you want to rely on yourself and not on the operators of a zk rollup, you should be able to prove to the Ethereum contract at any time that you own some assets in one of these accounts. And to do this, you will need to provide a Merkle proof, Merkle path of your account. And to do this, you necessarily need to know all of the all of the state details of all the accounts, but they are not stored on the smart contract. So how do you get them? For this, we will publish the state updates to the Ethereum network as call data. So we're not going to use the storage, but instead we're going to send, like, whenever some of the accounts change in the block, we will send the what changed or the final state of those accounts as a part of transaction, which will make it, which will be propagated to the entire network, to all the full nodes of Ethereum. And this will guarantee that all the users have access to this data. If the operators withhold it, users will be able to get it from Ethereum network. And our snark, or proof of validity, will also ensure that the data that we publish actually corresponds to the state transition. So the Ethereum smart contract will have to actually hash, make a hash of the state updates and check it with the snark. So it guarantees that the data is available through the Ethereum network, but it also comes with the limitation that we only have the block size limit, which is the bottleneck of throughput, right? So, okay, to overcome this bottleneck, oh yeah, it's important to note that it gives us the same security guarantees as L1. So it's the only layer 2 solution which has the same security properties, because no matter what happens to the operator, no matter what malicious actors might try to do, you can always just go away for a year, come back, and be sure that you will be able to fetch the your funds and get them back to L1. Okay, so now we want to scale that. So we want to augment it with the zk Porter accounts. How do we do this? It's actually pretty easy. We just select a subtree of zk rollup, and we say, okay, the accounts in the subtree are going to be zk. We're going to consider them zk Porter accounts. And the only difference of these accounts is going to be that we are not publishing the state updates as call data to Ethereum, which is going to ignore it. Like, only the zk rollup accounts are going to go to Ethereum as state updates, and the zk Porter root hash will also go to Ethereum. So this will ensure that no matter what changes in the zk Porter accounts, the users of zk rollup will be able to reconstruct their state, because they will know all the blue points here and this one blue point. So it gives them all necessary data to construct the Merkle proof for their accounts. Now, what happens to the data availability of zk Porter? We will publish it, but to a different network comprised of what we call guardians. Guardians are zkSync token holders who will store the data on behalf of users. They will get rewarded with some small fees, and they will provide the data to the zk Porter users, and they need to sign every single block with 2/3 or like with super majority of their signatures. weighted by stake. So with two-thirds of the stake has to sign the state update. Only then will the Ethereum smart contract take the state update, which will mean that at least 2/3 of guardians by stake know all the details of this block. Okay, so as you can see, the zk rollup security is not affected, but let's consider what happens to the security of zk porter accounts. Like how is this different? So since we are still in the same system, which is based on zk rollup, and we send the proof of validity for the entire block, which contains all the transactions for all accounts, it protects us against theft, forgery of any assets, and any sort of state corruption whatsoever. All the rules of blockchain are going to be enforced by zero-knowledge proofs. So operators can never steal, can never do anything wrong with the state, mess with the state. What they can do is a couple of scenarios. One thing that can go wrong is that the guardians, like at least 1/3 + 1 guardians are malicious, in which case they will just block, like they will halt the block production. They will there will be no operation of the system, which is kind of like what you get with any L2. If the operators are not cooperative, then there will be no blocks. It's not a tragic event because you can always go and withdraw funds from zk porter through some forced exit mechanism, which we're going to discuss we will have a talk about zk EVM in a couple of weeks from now on zk Summit held by ETH Global, and I invite you to this talk. We're going to talk about priority queue, how things work, how security is ensured. But long story short, you will be able to exit, and we will even have a mechanism for mass exit to a fork of zkSync. So it's not such a big deal. It's going to be just short disruption where a lot of stake is going to be lost because the stake is going to be frozen then. But a more severe situation would happen if we had 1/2 of malicious actors. Then they could actually freeze the entire zk porter account state. So the zk rollup accounts would be able to withdraw, but not zk porter accounts. However, in this case, the attackers would also freeze their own stake, which would be at least 2/3 of the total staked token, which is going to be a pretty large value. So this is an unlikely situation. The attackers have no incentive to do this because they cannot directly exploit it. If they freeze the state, it's just a suicidal attempt for them. Like it's a suicide because they cannot steal, they cannot do anything with the funds of users. So it can only be done for some weird political reasons, but it will be very costly. So for the same weird political reasons, you can attack optimistic rollup at a probably lower cost. So the cost of attack on optimistic rollups and on zk porter is roughly comparable. Some researchers might disagree with me, but like it's if someone really wants to mess with the system, they will have to spend a lot of money, and they will be able to mess with the system. So it's not the same security guarantees as Ethereum. However, the beauty of zk porter or of this volition hybrid design is that every user is free to choose the option. Every user can select the zk rollup account, pay higher fees, and get full security, or go with the zk porter, which offers pretty high security but is extremely cheap. So let's look at scalability properties of both systems. With zk rollup, we're limited by Ethereum block capacity, which would be like 2,000 transactions per second, 2,000 transfers per second, because all transactions are different. But let's measure everything with transfers. If we consume the entire Ethereum block, which is unrealistic, because all rollups are going to compete for the block space with each other and with all L1 transactions. So we're probably going to have only a small part of that, and like the same applies to all rollups. But on the zk porter side, we're not limited by Ethereum at all. We might be only limited by our hardware and by the capacity of the consensus in L2, which will probably get us to 20,000 TPS and more. And there are ways to push the limit further. So we will be the throughput is going to be a lot more, which will lead to the price of the transaction on zk Porter accounts being like roughly around 1 cent, maybe less. It's going to be more or less fixed until we reach the super high levels of throughput. Whereas with zk rollup accounts, it's always going to be linear compared to the mainnet costs, which are roughly 1/100th of transactions on mainnet. So if the gas prices are rising, the zk rollup transaction costs will also rise. But what's interesting, what's the most exciting part about zk Porter is that you can have interoperability between these two parts, between the two account types, completely seamlessly, because it's exactly the same system. It shares the address space. It's the same state. And zk Porter users will be able to access DeFi protocols on the zk rollup side, which are super secure, which can hold billions of dollars in the same secure way as L1. And these millions of zk Porter users will be able to access them at a very, very low cost. And the reason this works is because we only need to update we only need to submit the final state of a zk rollup account at the end of the block. So if in one block we have 1,000 Uniswap trades from hundreds or thousands of users, 1,000 users or less, the updates for their accounts will go to the guardians, so they're going to be cheap. But for the Uniswap, we will need to only publish one update on the on chain on Ethereum, which will only cost us like one zk rollup transaction, which will be amortized across all these 1,000 swaps. So each of the users will pay some very small fraction, maybe 10 cents, maybe 5 cents. It depends on the zk rollup prices, but it's going to be a lot less. So you're still interacting with the same big with the same big Uniswap or balancer or compound or Avi or Curve as all the whales and all the lending partners enjoying the full security there. So you have access to the main liquidity channel, but you're paying the costs of a very cheap side chain, and you still get very high security, a lot better than a side chain, actually comparable to optimistic rollups. So this is a breakthrough. Okay, let's move on. Yeah, it's important to know that optimistic rollups cannot have such an extension because for an optimistic rollups, they need to know the full data availability of all the accounts that are part of a block. You can't really hide part of them. With zk rollup, with zk Porter, we can hide part of them because they're still part of a zero knowledge proof. So the validity is ensured by zero knowledge proof. But for optimistic rollup, the validators, the full nodes, have to actually check every single transaction. So they can't do this. It's not as extendable. So yeah, the big question is when all of this is gonna be available. We are launching we expect the EVM zk EVM testnet in May this year. To go, like we will open it to the public, and we are targeting August as the mainnet launch date. But before then, we'll also have an interesting update. We will have swaps and NFTs on mainnet of zkSync 1.x in May this year as well. So I encourage you to check out our documentation and or contact us, and we're happy to talk to you and go in details on this. And yeah, so I encourage you to look deeper into this and ask any questions. We're also happy to provide assistance anytime. Thank you very much. Follow us on Twitter.
That was awesome to hear Alex just catch us up on everything going on with zkSync and zero knowledge proofs. And just wanted to add a little tidbit. He talked a little bit about, how long it took Matter Labs and zkSync to get where they are today, and spoke a bit about Plasma. And a lot of people don't know, but scaling Ethereum, has been an ongoing challenge for, over 3 years now, with hundreds of researchers, developers helping out. And it started with, the Plasma paper written by Joseph Poon and Vitalik Buterin, projects like Omise Go, Loom, and a few others, were first implementing it, and it eventually transformed into rollups and zk rollups. And so it's exciting to see, the same teams being so intellectually honest and pivoting as it made sense. And so our next speaker is Tom from Starkware. This will also be a recording. Tom, and the Starkware team has also been working hard through the bear market. And one fun, memory is Eli Ben Sasson is actually a very good chess player. So if you ever get a chance to play with him, but I'm personally excited to see, Starkware and the other zero knowledge proof layer 2 solutions excel in the NFT space, where bonding for withdrawals and sort of this like exit liquidity isn't as much of an issue. So let's hear more from Tom.
Hi, everyone. Thanks for coming to watch this talk, and thanks for 8 Global for having me here. My name is Tom Brand. I'm the product lead of Starknet at Starkware. And today we're going to talk about Starknet. We'll go over what we see, what is Starknet, what is the vision, on what foundations it lies, and how we plan to reach there, or what is the roadmap towards Starknet. So let's dive in. Yeah, so Starknet, in one sentence, is a decentralized permissionless zk rollup, which offers scalable and secure Ethereum-like state. And what I mean by that, so first of all, it's a zk rollup. I won't dive into what is exactly zk rollup here. You can see it online and on other talks, but generally speaking, it's the mechanism of offloading from L1 or mainnet, both computation and storage, and moving into L2, and using a proof system, and specifically in Starknet, Stark proofs, in order to securely prove state transitions on L1. So Starknet is a zk rollup. It will be permissionless, both for, of course, for the user, so everybody will be able to use it, but it will be permissionless for the operators and for the provers. And the Ethereum-like state means that developers will be able to deploy Starknet contracts, which are the equivalent of Solidity smart contracts, which will support general computation, and they will all be deployed in a one single composable state, meaning all the contracts will be able to interact with each other. So this is our vision to Starknet. And before we go to understand how we plan to reach there, it's very important to understand that Starknet lies on a very strong foundations. So Starkware is live almost 3 years, and we've been developing really hard in those 3 years the Stark stack. And what I'm going to describe now is how we plan on what technology we plan to build Starknet. So first of all, we have Cairo, which is also what we offer here on East Global to developers to develop. But basically, it's our Turing complete language for scaling dApps using Starks. I will get to it in a second. But Cairo is what allows us to write the stack for Starknet. Next, we have our Stark provers. So once you write your program and you want to generate a proof to it, you need to have strong provers. And our provers are, at least as far as we know and as far as was proved on mainnet, are the most powerful provers in the world. And lastly, we have StarkX, which is an actual zk rollup application, which works in production, which uses both Cairo and the Stark provers. And it's a real live application that allows us to make sure that the technology that we develop actually works. So let's dive into each one of those a little bit and understand how they allow us to later build Starknet. So first of all, Cairo. I won't dive deeply into Cairo here because during this global hackathon, there are many talks that Starkware has given and is going to give about Cairo. So first of all, on Monday, we had a workshop which included an intro to Cairo and a live coding session. I encourage you to come to our Discord channel and search for it there. Eli also gave a talk. Eli Ben Sasson, our president and co-founder, also gave a talk about how Cairo changed the paradigm for writing proofs and why if you want to build on Starknet, you should first go learn Cairo. And next week on Friday, Shahar Papini, which is one of the inventors of Cairo, is going to give a talk that technically explain how we built Cairo and how it works. So what is important for us to understand is that Cairo is allows anyone to write any program that they want, and all those programs, a proof that is generated for those programs can all be verified in one smart contract. So this is the first thing that allows us to use Cairo in order to build Starknet, which hold many programs. Second of all, Cairo was built to be efficient and secure, meaning that even if we want to take a very big computational statements, for example, a batch of many transactions, we are able to generate a proof to it in a very short time. And it is also very secure, meaning there are ways that we can audit and test a program and know that it is secure. Most important is to understand that this is already in production on mainnet. On July, we demonstrated a program on the Reddit's scaling bake-off. And since November, all Starknet systems use Cairo. It is available to the public, as you may know, and this is actually what we offer developers to build in the hackathon. And all the information that you need in order to start developing in Cairo is you can find out through the site cairolang.org. Perfect. Now that we understand Cairo, or maybe I would add just one sentence. So why Cairo is important for Starknet? Because for two reasons. First of all, it allows us to write what we call the Starknet OS, which is the base layer. You can think of it as the EVM, which runs the logic of the state transitions of Starknet. Now, since Cairo is just like writing a program and it is very efficient, it also means that Starknet and proving state transitions of Starknet will be very efficient. And second, Starknet contracts, the native language that they will be written, I'm not talking about transpilers from higher languages or from Solidity, will be written in Cairo. So this also allows us to give a lot of flexibility to developers to, and maybe I will go into it later, but to write very efficient dApps. Okay, great. Now we understand Cairo. The next foundation is the Stark provers. So as I've said, they are the most powerful provers in the world, and they power all StarkX deployment since June 2020 on mainnet. I may be repeating myself that that our technology is on mainnet, but I think it's a very important thing to understand. So just some Stark Guinness record. So the Reddit scaling bake-off, as I've said, was on July 2020. It was a rollup, meaning that the data was on chain. And there we generated proofs of 300K transactions in a single proof, which resulted in an amazing gas price per transaction of 315. In immutable StarkX deployment, which is live on mainnet since last week, in order to move their state from L1 to L2, we generated huge proofs of NFTs, which actually minted them on L2. So we generated proofs of 600K NFTs mint in a single proofs. which resulted in less than 10 gas per mint, right? So what those provers allows us in the context of Starknet is the ability to generate huge proofs, which results in a very, very high scale. Not only that we're able to generate very, very big proofs, we are also able to generate in a reasonable amount of time. Those two parameters allows us to have a lot of flexibility in the way we construct the protocol of Starknet. And lastly, the last foundation is Starknet itself. Already today, there are multiple deployments on mainnet. So we have, wait, I'll go a step backward. So Starknet is a zk rollup application. Starknet is a zk rollup platform or layer, which allows many contracts to be deployed on top of it. And Starknet is a specific application. So we have Diversify, which supports payments and spot trading. We have the YDX, which supports derivatives trading. And we have ImmutableX, which supports minting and trading of NFTs. And we have more coming, which hopefully we'll announce publicly soon. And what Starknet actually gives us is the ability to dog food our toolchain and technology and build it against real world needs. We're working with customers, we're working in a production environment, and this allows us to make sure that both approvers, both Cairo and all the development tools that we are developing are actually able to build real world applications. Perfect. So now that we understood the foundations of Starknet, or where we are today, we can go and understand how we plan to achieve Starknet. And as we do everything on Starkware, this is also we will do in a stepwise approach. And what I mean by that is that first we will the first step is planets, and in this step we will build the basic building block of Starknet, which is the Starknet contract. In the next step, we will take this Starknet contract and put it in a one composable state with many other contracts. And the last step is, once we have this composable state, we can decentralize the network and have permissionless operators and provers. So let's go into each one of those steps and understand it a little bit better. Okay, I see that okay, perfect. So as I've said, the first step is a single app rollup, and this is already expected on testnet in a few weeks. I think it will be mid-May, maybe a little bit later. But what, as I've said, this basic step is developing the Starknet contract. So what developers will be able to do at this step is to write Starknet contracts, deploy them on Starknet, and run them. What I mean by run them is send transactions to them, update their storage, and those batch of transactions will be proven and verified on chain, and a state update to the contracts will occur. Those contracts will support arbitrary logic, meaning you will be able to write anything you want with them. And this will actually be the first zk rollup that is available to developers that support general computation, meaning up until now, there was no zk rollup that allows a developer to just write whatever arbitrary logic they want and to advance the state with sending transactions to it. So this is the first step, and be ready to hear from it in a few weeks. The next step, okay, multi-app rollup, will take this building block of a Starknet contract and we'll put it in an Ethereum-like permissionless state. And you will you can expect everything that you expect from Ethereum. So you deploy a contract can interact with each other. users interact with the system with transactions. Users will be able to sign either with a very efficient Stark proofs or with Ethereum, with a very efficient Stark signatures or with the Ethereum signatures. And we expect this to be on mainnet, meaning live on mainnet later this year, probably by the last quarter of this year. And what this, so I said that it will be an Ethereum-like state, but what it will offer is a massive, massive scale. Again, I don't want to throw numbers in the air, but you can, they won't be very different from what we've demonstrated with StarkX, and hopefully even better, right? So this is the second step, and we expect it somewhere by the end of this year. And the last step is decentralizing the network operation of this zk rollup. And the most important part of it, which we didn't have at step 2, is allowing permissionless operators and provers, which of course result in a censorship resistance network. Now, what is very unique in zk rollup is that we are able, and since we are a layer 2, is that we are able to rely on Ethereum consensus in order to achieve very efficient leader election mechanism. And the validity proofs allows us to have very fast finality. Again, I don't want to throw things here, but in the coming months, we will write more and more about how we plan to build this network. And of course, we will use the crypto economics mechanisms to even further incentivize the efficient operation of the network. We won't use them in order to achieve the basic security properties, but we'll use them in order to make it much more efficient. Okay, perfect. So maybe if I go back to this slide, so step 1 is something that we already have today. We have StarkX deployment on mainnet. Cairo and the Stark provers are operational, and Cairo is open to the public. The step 1 and step 2 is something that we plan to have this year. And next year, we will probably have step 3. Okay, perfect. So we've discussed our foundations, we discussed the roadmap. And I would like to sum up what are the fundamental advantages that we see for Starknet. So first of all, scalability. The layer 2 scaling solution, the first thing that they need to provide is scalability. And we think that Starknet have the best chance to provide the highest scalability possible. So first of all, off-chain, as I've said, we are able to generate the largest proofs. This comes from both the strong provers that we have and the fact that we are writing things in Cairo. So many optimizations are trivial to write in Cairo. For example, having a Patricia tree is something which is very complicated to do if you don't have a programming language, but once you have a programming language, Cairo is almost trivial to write. And on the on-chain part, we have the smallest data footprint. First of all, again, using Cairo, we are able to make huge optimizations on that on-chain data. Just to give an example, applying Hoffman tree on the on-chain data can reduce it by a factor and is not very hard to implement in Cairo. And second of all, we have many ideas on how to allow secure network, but minimizing the data on-chain. And just to give one idea, we will allow developers on the contract level to decide which storage they would like to have on-chain and which storage they would like to have off-chain. And so everything which is required for the user custody will have to be on-chain for the contract to be sound. But storage which is not required for the user safety and maybe only required for the functionality of the contract on L2 might not be on-chain. And the flexibility that we will allow developers for deciding which data will be on-chain or not, we think will have major advantages. So the first thing is the scalability. Second of all is the security. I think there's no argument that zk rollup is inherently more secure than optimistic rollup. So this is the first thing. And the second point is, and I think is not less important, is that our technology stack is production tested. I think I said enough, but it allows us to have a lot of confidence that both approvers and Cairo and the paradigm of rollup is sound, and that, I mean, everything have bugs, but that we are able to discover them already in our work on StarkX. And lastly is the state finality. So since we're using proofs, all the state updates that occur on chain are final. We've written a lot about why this results in a capital efficient system. But I think one thing that was not much discussed in the ecosystem is the ability to create interoperability between L1 and L2. So since the state is final, once it is being updated, we will support a mechanism that allows contracts on L2 to call contracts on L1 and contracts on L1 to call contracts on L2. And since this call happens immediately at the state update, many interesting applications can be built on top of that. So if I maybe will sum up what I've said here. So Starknet is currently what Starkware is working towards, and it will offer a general computation, composability, and experience of Ethereum on one hand, and on the other hand, the security, the capital efficiency, and the scalability of zk rollups. As I've said, it lies on solid foundations, and the roadmap, as I've described it, allows us to go in a stepwise approach, and first build the building blocks and then apply them to a larger system. So thank you very much for your time. You're more than welcome to our Discord server to continue the conversation and ask any question that you might have. And I'm really hope that you will build amazing stuff with Cairo in this hackathon, and I can't wait to see what you'll build. Thank you very much.
That was awesome hearing Tom from Starkware speak a bit more about their plans. Next up, we have David from Synthetix. And I guess just a little tidbit about Synthetix. You know, they're probably one of the most innovative teams and dApps in the space. So not only in being, you know, one of the first DeFi derivatives platforms, and now also being the first implementation on Optimism's optimistic rollups, Synthetix has also pioneered a really unique community DAO system. So I'm not sure how many people are aware of the Spartan Council and how a lot of the really excellent work coming out of, you know, the Synthetix community, like the logos, are actually part of the DAO's purview. So really excited to hear more from David about how you guys are thinking about layer 2 scalability.
Great, thanks so much for having me. So I guess I can go ahead and share my screen. So yeah, today I'm going to talk a little bit about what we're doing at Synthetix around layer 2 and Ethereum. And then we've actually been one of the first protocols to integrate with Optimism. And so pretty excited to share with you some different aspects of where we've been. So one of the things that we get asked a lot is like, why did we choose Optimism, right? So as far as Ethereum scaling goes, there's many solutions. It seems like we're hearing about new scaling solutions all the time. So one of the things that was really important to us was to have one Solidity code base. We wanted to avoid rewriting our contracts and then maintaining a set of smart contracts for mainnet Ethereum, layer 1, And then having contracts for layer 2, we wanted them to be the same. And so Optimism really gave us that ability, which was huge. The second thing that we really liked was the security and the simplicity of how they're designing their system, right? In decentralized blockchains, the more complexity that you bring into the system, the more risk there is, both from a security perspective and from just business logic bugs, security bugs, et cetera. And so Optimism is trying to fork as much as they can from layer 1. And for example, they have a Solidity compiler that's just a 200 lines of code diff between what runs on layer 1. And then their Geth client is like 1,000-line diff. So it's a pretty lightweight implementation, and they're trying to stay as lightweight as possible. Then I think the last reason is because it's not just about the tech, right? Part of what makes Ethereum special is the community, right? Where are people going to be moving is kind of what we've tried to get ahead of and figure out. And so we think that most of the community is going to be going the Optimism direction. And so that's why we've kind of bet on this as our path forward, right? And then, if you think about where we anticipate liquidity flowing, that's something we're trying to get ahead of. And, we want to be where the liquidity is when it moves to L2. So there's also a social aspect to it. And if you want to learn more about it, Kane Warwick, the founder of Synthetix, has a blog post called Why Optimism that you could check out. So if I keep moving here, some of the features that we're rolling out as part of Synthetix, if you're familiar, what is Synthetix? Synthetix is a derivatives trading platform built on Ethereum. So we have, anyone can come on, create synthetic assets that we offer, or sorry, not create, but purchase synthetic assets that we offer, and then do things like derivative strategies with them. And so the way that people get value from, or the way that we've created liquidity in the system is through staking SNX. So people come on, they stake their SNX tokens, which creates liquidity. So then as people trade in and out of synths, synthetic assets, right? Like we have a synthetic version of Ethereum, synthetic version of Bitcoin, synthetic version of Tesla stock, for example. We're going to be releasing pretty soon a synthetic version of Coinbase stock. So things like that, the way that the liquidity comes into the system is from staking. And so we're going to look at an example of how we've implemented staking on Optimism mainnet to provide liquidity for synths on L2. And then on our roadmap coming up, we're going to have exchanging of synths on L2. And then, the ultimate goal is to offer leverage for synths, right? Things like shorting synths, futures, margin, stuff like that. So, so we'll walk through, let's see like an actual kind of walkthrough of the different contracts that we have. So one of the fundamental concepts of, if you tuned into the Optimism talk, I think it was yesterday, around an introduction to Optimism, they talked about the bridge, right? The bridge contracts to Optimism. And so this idea of a bridge, you can think of it as layer 1 and layer 2 need to know about each other and need some way of communicating, right? And so what I'm going to do is I'm going to show you our code around the bridge contracts that we have. And again, the bridge is just basically how do you go from, ERC20 tokens on L1 and move them over to L2. And then when you want to withdraw, like how do you withdraw them from L2 back to L1? And I guess you're not really moving them over. It's more of like a mirror kind of, which we'll look at in a second. And then if you're interested in learning about these contracts, you can find them on our GitHub. So I've included the link here, but if you just go to Synthetix.io GitHub and then you look at Synthetix, which is our repo, you'll see that the contracts, you can find our contracts, and then the two contracts that we actually care about are going to be Synthetix Bridge to Optimism and Synthetix Bridge to Base. And let's go ahead and I'm going to switch over to my code editor so I can show what the actual code looks like. Like I think the presentation yesterday gave a great overview of how they work at a high level. I'll try to recap as I go along here, but I just want to show you like an actual example that's been deployed and is running on mainnet. So just want to make sure you can see my code editor. Is there a way someone can just maybe confirm?
You're all good.
Cool.
That's great.
All right, awesome. So yeah, so the first kind of thing to think about is, as I mentioned, you could just imagine like there's two sides to a bridge, right? On one side, we have layer 1 Ethereum, And then on the other side, we have layer 2 Ethereum. And they need some mechanism to communicate. So what I'm going to show you is how we're doing that. So the first thing to kind of pay attention to is, let's say someone wanted to initiate a deposit, right, to stake on L2. It actually might even be easier to just show you our the UI first to kind of see the dApp and then look at the code, because I feel like it might give you a sense of like what we're trying to do. And I'm actually going to show you an example of how we're going to stake on L2. So you can see right here, I'm on our staking.synthetix.io, which is our dApp. It's our decentralized application, right? And the front end's built in React, and then we've got the back end built in Solidity. So the back end's powered by Ethereum. So as you can see here, right, we have a tab called layer 2, right? So when you come to staking.synthetix.io, you go to layer 2. And then what you can do is you can deposit SNX and transfer it from layer 1 to layer 2, right? So what I'm going to do here is I'm going to, you see how I have 10 SNX in my wallet, right? So I'm just using MetaMask. We're just hooked up with MetaMask. For those of you who are familiar, it's just, I assume most people are familiar. If you're not, this is just a wallet that lets you interact with the Ethereum blockchain. And so I'm going to go ahead and I'm going to deposit 10 SNX into layer 2, right? So when I click on deposit, you can see I've already done the approval. So whenever you're sending ERC20 token, there's the function that's called transfer from. That's the function. And before I'm able to do this, I had to approve that this contract can interact with this ERC20 token called SNX that's in my wallet. So I'm going to go ahead and deposit 10 SNX. Now you can see the gas fee that I have to pay is quite substantial, right? This really solidifies the need for scaling Ethereum and for moving towards layer 2 solutions, because once we see me move to layer 2 and actually do a transaction, you'll see there'll be no gas. Now, there will eventually be gas. Right now, the Optimism team is just covering the gas. But eventually, you'll have gas costs on L2 that will probably be in the 10 to 100 times cheaper order of magnitude than what you see on L1. And one thing to keep in mind is as the gas costs change on L1, they'll also change on L2. So if you have higher gas costs on L1, like we do right now, like the gas costs right now are pretty high, you'd have relatively higher gas costs on L2. Then if the gas costs were lower on L1, they'd be a little bit lower on L2. But just remember, like right now, it looks like I'm going to pay somewhere around $132 for the gas cost to submit this transaction. You can think of like on layer 2, you'd probably be paying $1.30 to $13, like as a rough estimate, somewhere in that range. It just depends on a number of factors, but the difference between $1.30 and $13 and then $130 is quite substantial. So I'm going to go ahead and confirm my transaction. So now basically what's happening is we are just waiting for the transaction to go through. And just out of the interest of the sake of the demo, I'm going to go ahead and speed up my transaction. So I'm going to actually go ahead and speed it up so that we, let's see, what is the current, why don't we just go to advanced and I'll just put in like 250 as my gas price. Oh, it's excessive. Okay, let's go with 200 just to make sure that it goes through. So I'm going to save it. Now it should go through pretty quickly. And what we're going to see is the deposit's going to go through, and then we're going to be able to do something on L2 with our funds. Okay, so while it's pending here, I'm going to go back, and now maybe we could go back to the code so we can just look at, just while we're waiting here, we'll just go ahead and look at the example of what's actually happening in the code as we did that. So let me just share my code editor again. Okay, so the first thing you can see is we're in the Synthetix Bridge to Optimism contract. And again, you can find this on our GitHub by just going to the Synthetix repo and then looking at the contracts folder. Okay, so let's go ahead and, so we're in Synthetix Bridge to Optimism. We've got a couple of things to take note of. The first thing is we're going to have a function called initiate deposit, right? So this is a function that can be called externally, right? So somewhere where I clicked deposit SNX, remember where I deposited the 10 SNX, that what it was doing, it was under the hood, it was calling this initiate deposit function, and that takes in an amount. In this case, it was 10 SNX, right? And so we have a few things that we're requiring here to make sure that I'm actually able to make this deposit. In the interest of time, I'm just going to keep moving. And so we go into the initiate deposit function. This is a private function, but again, this just gets called by our public initiate deposit function. Here we have our 10 SNX we've sent in. Remember how I mentioned you first have to approve a transaction, which I had already done before the demo started, but we're using the transfer function to transfer an ERC20. So you can see we're transferring an ERC20 from this call here, gives us an ERC20 implementation. And so the sender, right, is my wallet address that I was showing you in MetaMask. And what we're doing here is we're sending the 10 SNX from me, from my wallet, into this smart contract, right? So the SNX is going from message.sender, which is my wallet, into Synthetix bridge to Optimism contract. And then we have the deposit amount, which is 10, right? So that's the first step. So now we've taken the 10 SNX from my wallet and put it in the smart contract. So now it's locked in our L1 contract, which is Synthetix bridge to Optimism. So it's locked there. Now what happens? So here you can see we have this Synthetix bridge to base interface that we get, right? And remember, Synthetix bridge to base is the contract that lives on L2. So what we're saying is we have this interface, right? And now we're going to get the ABI, which is the encoding of what the signature, how does that contract work, the one that's on L2. And so we're going to say, take the interface, and then the function we're going to care about that we're going to want to call on L2 is called complete deposit. So we're initiating a deposit from L1, and we're just saying the function we want to call on L2. Imagine we started here and we walked across the bridge and we went to the other side, which is L2. We're saying call complete deposit, right? And again, we're saying the sender, which was the MetaMask wallet address, that's my address. We're marking that as the sender, so L2 knows who the sender was, and then we're sending in the deposit amount. So this builds the ABI. That doesn't actually send the message, right? That's just saying, it's just telling our contract, you need to know what to call on L2, right? So then what we do is we have this messenger instance. So if we look at what this is doing, so if I look at messenger, right? So this is basically the base cross-domain messenger contract that was provided to us by Optimism, right? So we didn't actually write this base cross-domain message. This is part of Optimism. And they've also given us, basically an identifier here for what the contract name is. And so here, when we're in, remember, initiate deposit, we are basically here calling the function send message on the messenger contract that Optimism has given us. So Optimism supplied the messenger, and we're saying, hey, messenger, send this message across the bridge to layer 2 with the message data. And remember, the message data is saying, call complete deposit with our address and the deposit amount, right? And so then what's going to happen is we also have to deal with the gas limit. The gas limit on layer 2 Optimism currently is 9 million. There's a number of reasons for that. We can probably skip that just because it'll take us down the rabbit hole. But now we're going to go back over. So basically this message, we send the message, right? And so the messenger says, okay, I have to go find the Synthetix bridge to base contract. I have to tell that layer 2 contract to call complete deposit, right? With the sender and the deposit amount, right? So now if we go back to Synthetix bridge to base, remember that now we're on layer 2, right? Synthetix bridge to base is running on layer 2. And we said the function name was called complete deposit, right? You see how this is invoked by the messenger on L2. So now we call complete deposit. We have, remember the address was my address, message.sender, which was the MetaMask address I was using. And then the deposit amount was 10 SNX. Now, here we have a modifier. So if you're familiar with Solidity, this modifier is basically a check that needs to happen. And so this runs, right? And I can explain modifiers. I'm just going to assume some basic level of familiarity with Solidity here. So what really happens here is this little underscore, it represents the code block of the function that's using the modifier. So first, before we run the function that was being used by only Optimism bridge, we're going to first call only allow for Optimism. So this is going to do two things, right? This is going to say only the the sender has to be the relayer, right? And then the original caller needs to be the bridge to Optimism contract. So we're saying if either of those conditions aren't true, that the relayer didn't make the call, which is again the messenger contract, right? Or the Synthetix bridge to Optimism, the L1 contract wasn't the first point of entry, then revert and fail the transaction because we don't want it to go through, right? Don't call complete deposit. So now, assuming that check has gone through, we'll then proceed to execute the body of the function that's using the modifier. And remember, the modifier is being used by complete deposit, right? So again, what this was saying was first run those checks and then proceed with this code, right? This code gets plugged in where the underscore was. So let's just go back down to where that, where we had only Optimism bridge. So you can see we reuse this in a lot of places, right? That's why we have it as a modifier. Otherwise, we could just have those checks directly in the function, right? But anyways, so what happens is this gets replaced for that little underscore that we saw. And then, so we did the checks and now this executes. And so what we're gonna do is we're gonna mint 10 SNX. We deposited 10 SNX from L1, right? That's now locked in the Synthetix bridge to Optimism contract, which runs on L1. And then over here, we're gonna mint 10 SNX. So now we have a mirror. We have 10 SNX locked in our L1 contract, and then we have 10 SNX we've created on L2 in the Synthetix bridge to base, or in the Synthetix contract on L2. So now there's like a mirror between the two, right? And then we'll emit an event that this happened, right? So now we've got 10 on L1 that's locked, and we have another 10 on L2, and they kind of represent each other, right? So now let's go ahead and think about, okay, so we're on L2, we've got our 10. What if I wanted to withdraw my funds from L2, right? I'll show you what I'm gonna do with them in a second, but what if I wanted to withdraw them, right? What's gonna have to happen is on the layer 2 Synthetix bridge to base, right? Remember, Synthetix bridge to base runs on L2, right? I would kick off and initiate withdrawal. Let's see if I can spell that right. So initiate withdrawal. So basically what would happen would be on our L2 DApp, right? I would click on a button that's like withdraw. It would make me sign the transaction just like you saw before. And it would call this function initiate withdraw. And so I'd specify, like if I wanted to withdraw everything, I would specify 10 SNX, right? Because remember, we had 10 on L1, 10 on L2. So the first thing it's gonna do is gonna check that I have 10 SNX to withdraw, right? And if I do, okay, so I've got my 10 SNX, it's gonna burn the SNX on L2. So now we went from 10 to 0, right? So we had to burn that SNX before it could be withdrawn, because when it goes back to L1, you can't have, both existing, otherwise we will have created money out of thin air, right? They have to be kind of like in sync. So we burnt the 10 SNX and L2. And remember, burning is just like destroying, right? Minting is like issuing. So in the previous example, we issued, now we're destroying. And so then we do the same thing that we did when we were coming from L1 to L2, but just vice versa, right? So we say, okay, give me the ABI for the function that should run on L1, right? And that's gonna be complete withdrawal, right? And remember, complete withdrawal is gonna live on L1. So that's gonna be in the Synthetix bridge to Optimism contract, which runs on L1. We're gonna send in the sender, right? So we're sending in, again, my address as the sender and the amount I'm withdrawing, which is 10. And so then what happens is, so we do the same thing. We take the Optimism supplied messenger contract, we relay the messenger, or we relay the message by calling send message, but this time we're calling to Synthetix bridge to Optimism, which runs on L1. We have our ABI that says call complete withdrawal with these arguments, message.sender and amount. And then, we have to specify the gas limit. We have to abide by that 9 million gas limit. And so now what's going to happen is this gets sent. We emit the event, but what happens is we go back to Synthetix bridge to Optimism, and now we need to call complete withdrawal. All right, so we're here. We've called this from layer 2, right, on my address that was in MetaMask, and then the amount, which was 10 SNX. We have another modifier here, which was require active. I think we've already looked at what modifiers do. But just know that there's a check there that happens, right? And then again, we make sure that the relayer is calling this, right? And we make sure that the synthetic bridge to base was the original caller, so to speak, which means that it came from our L2 contract. And then what do? We transfer the 10 SNX from the smart contract. Remember how we locked the SNX in the smart contract? And basically like step one, when it went from my wallet into L1's contract locked. Now we're basically unlocking it. We're saying, take it from the smart contract, send it back to the original user or the original sender with the amount. And that's it, that we just completed the withdrawal. So this is the bridge, right? They have to kind of be in sync. And I think just looking at a real world example, hopefully would be pretty helpful. So now that we've covered that, I'm just going to jump back into Chrome here. You can see how the deposit went through. Like if we open up, let's see, might have ended my screen share there. So let me go back in here. So we can see that there was success. We deposited 10 SNX, right, from my wallet on L1 onto L2. We paid $210 in gas, which is just insane, right? And that's part of the reason why we're so excited about moving over to Optimism, because again, in this type of transaction, you know, if it occurred on L2, again, withdrawals, I don't know, but like if you were just sending money from L2 to L2, like an L2 address to an L2 address, you might be anywhere from $2 to $2.10 to like $21. Again, that's just a broad kind of range, but just to show some expectations there of like what to expect over time. And so now if we go back to the DApp, right? Let me just go ahead and refresh here, just see if it's updated. So now what I'm gonna do is, you see how I have now 0 SNX, right? That's because I sent it to L2. So if you look at my account here, right, and we look at my assets, I now have 0 SNX, right? And now if I'm gonna, you see how we have this switch to L2 button here, right? So this is like, again, this might even give you a good sense of how to, as you're building dApps that integrate with L2 from a user experience standpoint, like how do you manage going from layer 1 to layer 2, right? We put a lot of time into thinking through how should the experience go. So now I'm gonna go ahead and switch to layer 2, right? This is gonna bring up my MetaMask. Hopefully you can see that. And you see how we have Optimism mainnet as the selector, right? As the network that's being selected. So I'm gonna switch to that network. Now that I'm on Optimism L2, you can see I'm on L2 staking, right? Our layer 2 dApp, right? If I open my MetaMask, you can see I'm on the Optimism mainnet account. And then, you know, you can see there's also an Optimism Covan testnet that we have, but right now we're actually on mainnet. And so then if I come down here, I can mint SUSD with my staked SNX. You see how I have 10 SNX I've staked, right? So we're gonna go ahead and mint $35.12 in SUSD. And again, because of the collateral ratio, right? That's all the SUSD I can mint. Again, this is a thing that's specific to Synthetix. So when you go on Synthetix, when you stake your SNX, you have to have 500% collateral ratio compared to, or it looks like 600% compared to what you can actually mint. So I can only mint like, I have to have 600% more than what I can mint. So here I can mint $34.95. So I'm going ahead and click mint USD. So that's going to bring up here, and you can see how the gas is 0, right? That's currently because the Optimism team is covering the gas costs on mainnet. You know, again, this will change. Like normally, maybe this would cost me like a couple dollars, like very cheap, right? Or relatively inexpensive. So I'm going to confirm the transaction. Look how fast that was. It was like basically instant, right? We now have $209 staked, right? Because that was my 10 SNX, 209. And then I've got active debt of $34.95. And my collateral ratio is 600%, right? So I'm right where I want to be. And you saw how instant it was. It's like so exciting to see Ethereum transactions that fast. And so, yeah, that's pretty much it. I mean, that's the demo. We talked about the bridge contracts, kind of coming back to the presentation for a second, and then I'll try to wrap up because I know I'm not sure exactly how long I'm supposed to be here for. I could be here all day if you wanted me to. So, but yeah, so we talked about the bridge. We looked at the demo. if you're interested in some good resources, these were really helpful for me as I started to get ramped up on Optimism and Layer 2 and rollups. And so Georgios Konstantinopoulos has a couple great resources. So almost everything you need to know about optimistic rollups and how does Optimism's rollup really work. The first one is more high level. The second one is much more detailed around like the technical implementation. And I can try to make these, either slides available, or, if you wanted to DM me or find me on Discord, you can find me in the Synthetix Discord if you want these actual links. I'll put the link for our Discord on as well. And then Vitalik has some great resources as well that help me kind of gain an understanding of rollups. So those would be two good ones: an incomplete guide to rollups, and then a rollup-centric Ethereum roadmap. The first one is on his blog, and then I think the second one was on either Reddit or Ethereum Magicians Reddit, I think. So yeah, and then the Optimism team has like a scenario walkthrough where they kind of go through like a complex scenario of depositing, transferring, and then like a scenario where fraud proofs would come into play. So if you want to learn about that, that would be a great resource. I'd also suggest in the ETH Global Discord for the hackathon, Optimism has a channel. So if you have specific questions, you can go in there and post about it. Yeah, and then here's my Twitter. Here's Synthetix Twitter. If you wanted to join our Discord, this is the link. In there is David G. And yeah, just really excited to have been able to give this presentation and share with you just some learnings we've had as we've gone along here with our L2 implementation. And we're just really excited to be working with Optimism and the Ethereum community to make this happen. So thank you so much.
Amazing. David, thank you so much for that awesome presentation. It's just incredible to see over the past few years from you being part of ETH Global events and going from hacker to mentor to developer to giving a talk and just making these events even more useful for everybody else. So thanks again for that, and also for a really comprehensive walkthrough of how Synthetix does everything on Layer 1 and Layer 2. So thanks again, and I want to just share some quick closing thoughts for everybody. And with that said, I also want to make sure that I give our guest MC, Eva Balin, a really big thank you from our side. She really did an amazing job just introducing all of our speakers and sharing so many cool and fun stories. It was awesome to have her help us out, and we'll aim to get her involved again in the future. So all that said, this was our last talk of the day. We had so many introductory talks on how everything from optimistic rollups to zk rollups to side chains to specific chains to what's happening in Layer 2 altogether and cross Layer 2. It's just been a massive overflow of information on how all these things work. And if you were not able to catch all of these talks, they are recorded and they will be made available live over the next couple of days on our YouTube. And after this live stream ends, you can also refresh ethglobal.tv and just catch the whole summit all together as a single video. So I don't have a lot more to say. I just want to remind everybody that this was the first of 3 summits. We did the scaling introductions and just talked about high level what's happening in the world of scalability. Next Friday, the 23rd, we'll be hosting our merge summit, where we'll be talking about what's happening on the Layer 1 side of ETH2 and what the merge is going to look like and everything that's happening from the Ethereum development side. And then the week after, which is Friday, the 30th of April, we are hosting our summit on zero knowledge. So you'll see a lot of applications about the possibilities of zero knowledge proofs and how that technology and those primitives can be applied to scalability, programmability, and everything else. So with that, I want to thank all of you for being here today. And thanks to everybody who was on chat asking all these amazing questions. And we look forward to seeing all of you for the next summit next week. For all the information about the talks, the upcoming speakers, and the schedule, you can head over to scaling.ethglobal.co. And I hope all of you have